Oh, wow, exactly.
You get to 2.
Okay, looks good now.
Good.
So we left London Saturday morning, and we got the rental car. So we got a Volkswagen. Lots of space. So we drove to Buffalo, and we drove to Pittsburgh, and then went down to Memorial, and then we drove around Washington. Almost up to the National Park, but we were running behind. And then we did the boat canal.
Well, basically, someone just went down.
It took us basically 2 days. Oh, in the middle, we stopped, just past Pittsburgh. Yeah, it's just It's gone okay, yeah. Yeah, this is Matthew. Do nothing about it. That's what he treated me here.
Yeah. I'm much more than
That's really good. Are you really? Yeah. Wow. When I do a show, San Jose, I'm gonna let's see this.
It doesn't.
Yeah. I'm up here in a week.
Does it say what it has? We have see any posts of it having tape. But they do.
Hey!
Carlos, how's it going, buddy? What's up?
I have to thank you for introducing me.
Any tape perchance? Yeah, can I use that real quick? Just a little bit.
Do you have the crumping vinyl?
Yes.
I thank you so much.
Did you start listening to them?
Yes. Oh my
They're
God,
awesome.
they're amazing.
They're awesome.
Good.
Yeah.
I was like, what is this stuff Nick's talking about? And I'm like, I started listening to them.
Yeah,
I'm not sure. I listen to all kinds of music.
Yeah.
And I don't think I've listened to it before.
It's actually
amazing.
It's actually really
And from there, there's a shining past and music.
similar stuff.
Yeah.
Send me your recommendations. I always have my recommendations.
Yeah.
Cool.
Yeah. We'll let it happen.
Hold it, I'll take it. Already approved.
Forever celebrate a very, very good driving experience.
Girl? Yeah. Sound inviting?
No, I don't
Hard
need
for-
to.
I don't know, if he needs to go further. Actually, yes, I would go back to-
No, no, I can wait for it. Rush it up there, please. She's okay. When I spend the day, we don't get any LPC. Just waiting to rest. Memorial, no,
Yeah.
we were in the condition to be more.
Were there protests?
I shift how they fit into the things I'm starting to get now. So now they, so now they make like an add-on of oil. Because you know, like. And so, in chunks, they were doing like this each other.
Sorry.
Yeah.
Oh, yeah, which
Our
are
internal
internal. Yeah, I get your. No, I. There was something there.
Yes, always, yes.
The helicopter.
Only need to last for 8 hours. It does have a lot of interesting engineering design decisions to make. It only needs to last for an hour.
Just how John said, we won't come to Japan on it forever, famous last words. It's now the standard. Are we supposed to start at 25 or 30?
Whatever. You guys are gonna go over, so we'll start. We are.
You want to do
I
it?
think- Oh, you direction.
No, you do it.
No, I don't want
Okay, let's go.
Okay.
Is this working really?
It should be, yeah.
Okay, so welcome. One more year to the Toolsys track. So the first activity today would be keys list and sync list for security features which are reservable for the kernel in the Toolsys.
So.
Hi, welcome everybody. I'm Case. We'll also have Bill up here talking about specifics further on the slides. This is toolchain hardening features they are generally applicable to outside the kernel, but these slides in particular are focused more on what the kernel needs. First step always is to sort of look back at what we talked about last year. These are sort of the relevant things we were at. And then we'll go back and forth probably between the two. So this year, I've added another column for Rust. So we've got a separate compiler in a way. So we've got GCC, Linux, and Rust. I'll talk about that more in the next slide. It's not what we call attention to. It's we've got what we were talking about last year. That script is done. Yeah, that's been taken care of across the board. And the more exciting attribute, we call it element count last year, so I cheated on the slide. I media here, two slides. The counted by attribute is now so we'll get back. I think it gained back reg CFI, the shadow call stack. So I'll take a step forward to Rust. So one of the major concerns we've got is a class of attacks sort of called cross-line attacks. So we've got, let's say, the old big Rust, now producing binary output from the Rust compiler. And those things may not have the same methods in the binary output that was produced by the C compiler. That's sort of really making sure we've got as an example, something like control flow integrity. If you partition all of C, but not the Rust pieces, then the C part can use binary output that Rust produced as is. Turn that to be sure that our harmony across the memory is consistent. A bunch of stuff has already been finished, but I'm just calling out the zero and column registers, the randomized structure supported as needed.
The RANSTRUC work is needed pretty quickly because if you try to build, with randomized structures, obviously anything in Rust is going to melt down very quickly because things aren't in the right order. The kernel CFI, the forward CFI is in progress. It might already be landed. Ramon was talking about this, but you can check those slides. The details are on slide 58 of that very large deck that's linked there. And we need to look at how counted by needs to be added to Rust. An interesting spot that is a little strange is for arithmetic overflow handling. Right now we have sanitizers on C code that can check for arithmetic overflow, and they'll generate a UBSAN trap or warning. And Rust has its own math overflow handling, but they don't really resolve to the same thing. So we need to try to figure that out. Moving on. So what we have parity on -f strict flex arrays, and just as a reminder, this is to for any trailing array in a structure. GCC and Clang treat it as a fake flexible array, no matter what its size was defined as. And this led to very weird situations where there was basically ambiguous meaning to the code that people were writing. And the compiler had to stay pretty hands-off. It was like, I don't know if this is a real array or a fake array or whatever. So that's been finished. That was in GCC 13 and fully finished in Clang 16. Most of it was in 15, but we need the stuff the kernel depended on started in Clang 16. And this gets us unambiguous handling in the bounds sanitizer, so dealing with array bounds checking, and in the internal built-in for being able to ask about the array size, which is used in Fortify stores, like the memcopy and strcopy, all that family of functions. When they're used, they sort of interrogate their argument to see, is this an array? How big is it, et cetera? And if before this, it wouldn't be able to enforce anything for trailing arrays. So that's been solved. That was enabled in 6.5. So the stack protector guard location, this is basically the sort of old stack protector was a global canary. So if you could get the canary in one thread, you could apply it in an attack in a separate thread. So having per process canaries was, has been a long-term fix that we've gotten. We actually had 2 implementations on x86. We don't have this yet on RISC-V or PowerPC. We've got an open bug in Clang. I should clarify, Clang doesn't have this for RISC-V and PowerPC. It exists in GCC. There's an open bug for RISC-V. There isn't a bug for PowerPC, so that's why I have a question mark after the needed. Like, is anyone paying attention to this? I'm hoping that IBM could get someone to take a look at this, if that's something they care about. So looking at forward edge CFI, I've always split these slides into, like, we've got hardware support for this kind of thing and software support. The hardware support tends to be much more coarse grained, saying you have a function pointer, you're going to make an indirect call, and you can jump to where? For hardware support, this basically says you can jump to any function entry, which is very nice in the sense that you can't do inter-function gadget. You can't jump into the middle of a function, but it doesn't really stop you from calling whatever you want. It's nice, but it's not very fine grain. The software control, this is the KCFI implementation that we're using. That gives us a per function prototype. So only functions of the same, from an indirect call, you can only call into other functions of a matching prototype that was expected. So it's encoded, the C prototype ends up being encoded in a hash that's checked in the binary output. Clang has this, GCC still needs this. This is pretty important. There was an earlier effort to do this for ARM64, but that person's not working on it anymore. It would be great if someone could pick this up. And the reason this is important is really the attacking function pointers and gadget analysis is pretty well totally automated. Like, this is a solved problem on the attacker's side. So if you gain function control, you have total access to the kernel without really doing any manual work at all. So locking down this, getting this exploit mitigation in place is pretty powerful, or at least raises the cost of exploitation quite a bit. Backward edge is the return path. So this is corrupting your stack return addresses so that you can redirect returns. Hardware support, we're pretty good on the kernel side. Like, this was supported by both compilers for quite some time now. Kernel support finally landed for user space. The in-kernel use of shadow stacks, hardware shadow stacks, has not really been explored, and that's mostly because people have been tearing their hair out over all the weird CPU mitigations. Like, there's, in some configurations, there's a single return instruction in the entire kernel image because you have to jump to it first and do cleanup, and it's kind of nightmarish to deal with that. So no one's really stepped up to look at, can we add shadow stack support on x86? ARM64 has protection for this using PAC. This is working fine. On the software side, there is a method of doing a KCFI-like return hash checking that, again, is not yet in Clang or GCC. No one's stepped up to do it. But there is, on ARM64, there is a shadow call stack, which sort of emulates the hardware call stack as well. So these are areas it would be nice for us to take some next steps in, but given the hardware support, things are looking a lot better. As far as the tool chain, everything we have for supporting hardware is there. So now I'll get to probably what is the bulk of this. So looking at bounds checking our flexible array members. So if you've got a struct like this that has no fixed size, and you're going to allocate a bunch of space for it, there wasn't any way to check this. And so the idea was to add this attribute that says counted by, and gives the hint to the compiler that, hey, the size of this array is defined by this other member. How many elements we have is defined by, in this example, the items member in the object. And then this logic gets wired up into the array bound sanitizer and the built-in dynamic object size built in. so that it says, oh, instead of doing a compile, like instead of hard coding is this index larger than whatever the hard coded number was in the array, now it says, I'm gonna actually load that member and do a comparison against the index. So it's a little bit more work at runtime, but it's actually able to do it at all, which before this it wasn't able to. So I think the next slide, I went too far. I'll hand it over to King, who's talking about what's happening on GCC. Stairs over there.
Yeah, so, sorry. So the current plan for GCC to implement the counted by feature, yeah, actually we divided the whole task into 5 items. So 1, 2, 3, 4, 5. So the first 3, that's, yeah, the first 3 is we plan to implement into the GCC 14, and the 4 and 5 we plan to implement into GCC 15. But due to the review process, during the review process in GCC 14 for the first 3 items, we found a major issue in the patch submitted. Thanks a lot for Sedish and Karas, yeah, for identifying this major data dependence issue. So with this data dependence issue, we have a redesign to the whole task, and then we have to postpone all the tasks into the GCC 15. So that's the current status. So for the 5 items, the first one we need to provide the attribute first, and then we need to use the attribute to the consumer of this attribute. That's the first consumer is the built-in dynamic object size. And the second one is the sanitizer, the bounds sanitizer. So after these 3 items, we will try to improve the built-in dynamic object size to estimate to use the attribute for the whole subject. Right now, we can only use it for the sub object. And then after that, we try to issue warning when the user violates the user requirements. So we'll explain a little bit more in details in the later slides. I'll explain a little bit in the missing data dependence issue in the next 2 slides. So this identified missing data dependence issue. So in this small example, we can see the structure A has 2 fields, and the second field buffer is a flexible array member, and it has an attribute counted by the size given by the first member, the first field of the same structure. So in the routine full, the line 7 and the line 8, you can see the line 7, the size is get initialized, and then at line 8, we call a built-in dynamic object size, and to try to estimate the object buffer, this subject, what's the size of this subject. So in this call, built-in dynamic object size, we try to use the object size information in this call, but this implicit use information is missing in the source code and also in the intermediate language. So this missing data dependence, because there's no data dependence, compiler don't know the line 8 depend on 7. So compiler is free to reorder these two statements and also can apply some other incorrect transformation to hoist or CSE, those kind of things, and make a wrong transformation. So this is a major issue currently identified, and the compiler need to resolve this data dependence to represent this missing data dependence in the intermediate language to prevent the wrong transformation. So the next, so after extensive discussing inside the GCC community, we finally agreed on a solution. So that solution is we will introduce a new GCC internal function to try to carry this data dependence and pass the data dependence into the intermediate language. And then the compiler knows there's a data dependence between these two, then compiler will not do the wrong transformation. So the name of this new GCC internal function is access with size. So in this internal function, we have two arguments: the object, the pointer, the reference to the object, and reference to the size. So, and then we will use this internal function to replace every reference to a flexible array member field that has counted by attribute. Then, yeah, you can see the previously the line 7 and line 8, the line 7, line 8, yeah, and now we will add one more line between the line 7 and line 8. Yeah, we will change the reference to the buffer with the internal function call. That's internal function will connect the buffer and the size together and then carry the data dependence into the data flow of this program. Then the compiler will see the complete picture of the data flow information. So then we can resolve the missing data dependence issue. And with this solution, we also can combine several other attributes for the object size information together. And then, yeah, the implementation of this area will be more consistent. So that's a very good design, I think, yeah. So I think we will change the current patch with this new internal function. And because the introduction of this internal function, the intermediate language, will change it a little bit more. So there will be quite a lot impact to the compiler optimization. So right now, GCC is in the last stage of the GCC 14. So put in this big change will be a little dangerous. So we'll decide to delay the checking of this patch into GCC 15 in the early stage of GCC 15. So the counted by attribute, so what's the user interface provided in GCC? So we will provide counted by attributes which will attach to the FAM field. And that attribute will have one parameter. That parameter will be another field in the same structure. So that field will tell the flexible array member have the count number of the array. So that's a bound information to provide to the compiler how big this array is. And there are two requirements to the user to use this counted by attribute. So the first one is so you have to initialize this count field before the first reference to the array. So that's the first one. And the second requirement is the P array. So that buffer has at least P count number of the elements available all the time. Otherwise, the array checker, the array sanitizer, and the dynamic built-in object size will have undefined behavior. I will have two small examples in a later slide to explain why these two requirements need to be met. Yeah, and there is one important feature with this interface. After the design change, right now we can support the dynamic array for the flexible array member in GCC. Well, what means that is, so this is a small example. Let me see. The P count equal to value 1, then reference 1. Then the P count is changed to another value, then reference 2. So that's a sequence. So with the new design, the reference 1 will use the value 1 as the bound of the P array. And the reference 2 will use the value 2 as the bound of the P array. So the P array, this buffer, the size can be dynamically adjusted during the program. So that's a feature needed by the kernel. Yeah, so I think this we can support this feature, fully support this feature. Yeah. So this is a small example to show how GCC can use the counted by attribute to support the array bound checker and the built-in dynamic object size. So this the first structure annotated is a structure with the array and the count, so connected with counted by, and then we the routine alloc buffer, so that one will malloc size of the memory assigned to the counter P, which has the structure annotated type. And then we initialize the count field with the number of the element to that array. So this is the header file. Yeah. And then the first thing is we use the counted by in the bound sanitizer. So in this main routine, you can see the P annotated array 11, that one, because we allocate only 10 elements, so the 11 element will be out of bound access. So before the counted by attribute, we cannot report the out of bound information. We cannot report this error to the user with the sanitizer, bound sanitizer. But after we add the counted by attribute, the GCC can do this without any issue. Yeah. So that's used in the bound sanitizer. And similarly, we can also use the counted by attribute in the dynamic object size. So you can see we allocate 10 elements to this flexible array member, but previously, without the counted by attribute, when we try to estimate the flexible array, the size, we cannot get any information. But now with the counted by attribute, we can report the size, the subject size correctly when using the counted by information. So that's two example how to use the counted by attribute in the compiler to
Previous slide. Could that not be a compile timeout?
Which one?
The error there, could that not be reported at compile time?
Compare time, no, because the because that counted by information will not be, it's a variable during the compiler time. Only in the runtime it will know the variable size, a variable number.
For this specific example, it did get reported at compile time, but then if you imagine like a more general purpose. There was those count, yes. In this case, the allocation is visible. But in the
No,
function-
no, it's not visible because alloc buffer is non-inline. Yeah, I missed to tell. Yeah, this is the previous header file, so you can see the alloc buffer. That function has the attribute no inline. So that's I added intentionally to prevent the inline. So then in this function, the alloc buffer cannot be inlined. So then you cannot see.
Compiler could see what happened one best compiler.
Yeah, if you can inline it, then you can see the number. Yeah, from the alloc, from the malloc. Yeah, but now I try to show. Yeah, it's not cannot be inlined. Yeah. So all the alloc buffer, that one is no inline. So I add that attribute. So compiler cannot inline it. Then in the routine main, you will not see the alloc size for the buffer. So you can only get the information from the attribute counted by. Yeah, but counted by, that information can only be seen during runtime. During the compilation time, it's a variable.
We could add that as a feature later on where we could change analysis. The allocation that counted by the first group is always going to be.
Yeah.
That's something that we can.
Yeah, okay.
Will this feature work if the array is not inline? If the array is your example. What is the array example?
You mean the array is not in that structure? Is that another pointer? I think we are considering to extend the counted by attribute to generate pointer later. But at this moment, that counted by attribute only apply to the flexible array member. But that's the next step. We'll try to extend it. Okay. So does that answer your question? Okay. Yeah. So with the current patch, we can support use the counted by attribute to support the dynamic object size for the sub object only. But a further improvement will try to use the counted by attribute for the whole object size, for the dynamic object size. So the reason is, so is the example clear from your, I cannot see, it's very clear. It's clear, right? You can read it? Okay. So the left side, so there are two columns, the left side and the right side. So left side is show why in general, given a structure with a fixed size training array, why we cannot use the size of the type to decide the whole object size. The reason is because the pointer p also is alloc fixed. The pointer p, even though its size of the pointer is a structure fixed, but you cannot guarantee that pointer will point to a single object of that structure because it might point to an array of that structure. So in general, we cannot use the size of that structure to decide the P of that pointer P. So yeah, so yes. So, but for the structure with FAM, it's different because structure with FAM cannot be an element of an array. It only can be a single object. So for a P point to a structure with a FAM structure, you can guarantee the pointer will point a single object. So we can use the type information to decide the whole object size. Then we can use the attribute counted by to decide the whole object size of the structure. Yeah. So this idea currently is not implemented in the GCC, and we will add it later as an improvement. And thanks for Sedish for this idea. And another further improvement is we need to issue warning when the user requirement are violated. So there are two requirements, as I mentioned previously, in the user interface. So one is the user need to initialize the P count before the first reference to the P array. So this is a small example. Yeah, you can see the P array is referenced before the P count is assigned. So even though the size of the P array is only n, but the P array reference is n plus 1, so that's clearly it's outbound access. But since you assign that count after the outbound, then the compiler will not know the bound size during the reference of the P array before that initialization. So the outbound error will not be catched by the compiler. So this is the first requirement and the first warning. And the second requirement is the P array has at least the P count number of elements available all the time. So the example here is show, yeah, we allocate n element for the P array, but we assign n plus size bump as its counter. Then when because n is size, let me see. Then the P array reference n plus 1 should be out of bound. But because the count information, the n plus size bump is bigger than the n plus 1, so the compiler will not report the out of bound error. So that's also violate the requirement. So I hope this two examples is clear to show you why we need these two requirements. Yeah. So then we will add one compilation time and one runtime option, but the name is just we will not decide the name yet for the option. We'll decide later to catch this kind of error during compilation time or runtime. Yeah. So this is future work. Future work will first we will add the counted by attribute for flexible array member first. That's we will make it into GCC 15. Then after that, we'll try to extend the attribute to the general pointers. Yeah. So then we might add some more attributes later if needed. Yeah. So then we will integrate the array bound information for FAM and general pointers into the language syntax and type system. That's also in our discussing during the GCC community. So our final goal is try to add this bound information into the type system and make the C more type safe. Yeah, that's our final goal. But integrate this kind of information into the language syntax is a long way to go. Yeah, so we will try to do it later after we get success with the attribute first. Yeah, so and the last one is the potential to integrate the bound safety proposal from Apple into GCC. So that's maybe discussed later. Yeah, I think Bill.
Hello. Excuse me. So I'm going to give a quick breakdown of where we are with Clang. Basically, I'm going to say a lot of ditto to what GCC is doing because we're trying to make the implementations identical. We're one small step ahead of GCC at the moment, where we're able to do a built-in dynamic object size on the whole array, not just simply like the sub-object, the flexible array. But we do also have the same data dependency issue that we're going to have to address. But we're, once they hammer out the exact solution on GCC, we'll be able to create a very similar solution in Clang. These next slides are just going to go through some of what you can do right now with top of tree. This is a reminder of King's header file slide with some of it slightly redacted. And so for an out of bounds error, such as this, when we're trying to, when you have the sanitizer implemented, which I don't have on that command line, then it will throw a undefined behavior sanitizer error. That in after that is a bit of a bug, but anyway, so. And for obviously just, getting the size of the flexible array member, we're able to calculate the dynamic object size of that so that it correctly brings back 10. To get like the object size of an index into the array so that, whatever is left of that, we can also do that given the pointer to it. And if you go outside of the bounds, then it will return 0, which is perfectly fine and exactly what we want with built-in dynamic object size. And like I said, this is just the one step ahead that we are. It's not super exciting, but we're, if you have a pointer to the entire structure, then we're able to generate the code for you, or that size for you. So, like I mentioned, the data dependency workaround that GCC is currently hammering out, we're going to adopt that, when we can. The future work, and actually, some of the reasons why. Oh, sorry.
Yeah. So on the previous slide,
Is there a microphone? Everybody at home, we're so sorry. I think so.
Cool. I recall on one of the previous slides when King was presenting that the count had to be at least the size of the flexible array member. So does that built-in dynamic object size tell you how much is remaining in the entire array as it was allocated, or up until count?
Up until count.
Okay.
So for, let's see. This one here is what we are talking about, right?
Yeah.
So everything, because we don't have the information from the malloc, the original malloc carried through, it's like ALEC size is the attribute information that can be used. Well, since that's not carried through, past the function boundary, the only thing that we can rely on with the built-in dynamic object size is the count that's specified with that counted by attribute. So yeah, for this, if somebody had modified P at this point and said that count was 120, this would have returned 117 for the size. So, sure. How dare you? So one of the things that we would really love to have happen is to implement some of the features that Apple had created an RFC for. And they've had this working bounds checking or bounds safety stuff for quite a while now, at least over a year, and certainly more. However, kind of like how smog sits on a pile of gold, they haven't yet released it to the public. So this is why King and I have started kind of doing our own implementations of some of this stuff. Here are a few of the listed out here are a few of the attributes and differences that that Apple has created. Like a pointer to a single object, and you can specify the attribute single to it. So if you try and do like pointer arithmetic on such an object, you'll get an error because it's only supposed to be one single object that you've created there. The external bounds annotations like counted by, sized by, which are very similar, and ended by. These are for like if you are passing a raw pointer into a function, you can say this pointer is counted by this other field or this other parameter in this function, and it will act in a very similar way to the counted by that King and I created. And sized by is like counted by, but it will return bytes instead of just the element count. And ended by, as you can imagine, is just like, oh, this is the end of the array. They also have an implementation for internal bounds annotations, and those are fat pointers, but we don't fat shame, so Rubenesque. And they basically, the pointer itself is it's kind of like a small little structure with the begin and end specifically specified within there. And they have bidirectional iterators are indexable, and regular indexable, which is just one direction. Also sentinel delimited arrays, like null terminated and terminated by some other value. And then finally, unsafe indexable, which is just like regular C arrays. But they've already used this internally at Apple, and like we said, we're just kind of chomping at the bit to get it and implement it into our stuff. So yeah, this is this is something that we've wanted. Like when they announced it, everybody was like, "Can we have this yesterday, please?" And so yeah, it's kind of something that we'd really like to have happen. And once the slides go out, you can. This is a link to the RFC, so you can get a lot more information for that. So We think so. I mean, I'm sure that they've come up with, the question was, or the observation was that these all have the same data dependency issues. And we imagine that Apple has addressed them and had run across the same issues, but again, we don't have their code to look at. So it's quite possible that they didn't consider it. And there may still be a data dependency issue there. But it's unknown at this moment. Yeah. So anyway, like I said, it was just going to be a very brief update. And a lot of the stuff had already been done by King. So I'll give it back to King, and so that you can talk a little bit more about some of the other stuff. Oh, I'm sorry, Case instead King.
Yeah, these next two slides are sort of, we've already covered. It's just sort of looking at the bound safety work and giving more context for where it could get used in stuff outside the kernel. Like, kernel doesn't have VLAs at all, so we don't care. But talking about extending this to the pointers as well as the FAMs, so there's a little bit of redundance. And then again, thinking about what work we're going to have to do in the kernel to deal with this, there's quite a bit of effort to adopt the bound safety stuff, because we're going to have to change a lot of proposals or change a lot of the prototypes to match the stuff that's in the proposal. So on we go. So switching back to a little bit out of the like array bounds, but generalized array bounds, there's just a couple of little open issues. So Clang still has to fix dealing with nested structures. So if you have a flexible array member in a structure contained in a structure, some of the internals sort of don't notice that it ends in a flexible array. And this was very recently fixed in GCC, and it's getting fixed in Clang. Dealing with, we talked about value range checking. GCC still emits false positives with -w array bounds. This is mostly an artifact of jump threading and sort of confuses the internals. There is an open bug. King has a proposal on how that could get fixed. And then there's talking about, from a larger perspective, dealing with flexible arrays and unions are technically not allowed by the standard as it stands. So if you had this code, you had a union with a flexible array at the end. In the past, using the GNU extension, you could specify it as a zero-sized array, and it would be treated like a flexible array. But if you actually remove that zero, suddenly your code doesn't compile anymore, because a true flexible array is not allowed to exist in a union. But of course, it can and has, because both compilers can handle this without any problem. It's just, oh, if it's a true flexible array, you're not supposed to be in a union. But this is used in lots of places in the kernel. It's a common problem. Yes.
So do you need this independently, or do you need this? So do you need this feature independently, or do you need it as part of the struct?
As it's traditionally part of the struct. So like it ends with a union.
Going through the thread, it seems that the main concern is that the union should not be zero. Like if you have two.
That may be true, but it doesn't compile. Like
No, I mean, I'm saying that the objection that you have that the using thread should probably not hold for when the union is part of this.
Okay.
We should probably just fix that.
Okay. Yeah, I mean, there's a bunch of cases in the kernel where you have a union where it's basically doing the FAM is being treated as a catch-all. So there's a union of a whole bunch of structures, and above that union is like, this is the type that actually exists here. So all the code picks which structure they want to use, but occasionally they're like, let's just treat it like a byte array. So now there's a FAM in that union, and that's illegal. Like it won't compile. But if you said zero, it builds. and you're fine. So there's an inconsistency here, and it's mostly due to the fact that flexible arrays are like literally one sentence in a footnote of the C standard, and people had to decide how to interpret it. So we just need to explicitly allow this. We can work around this in the kernel right now by wrapping it in a structure, which is just this horrible mess, but don't look, yeah, it's very gross. Yeah. And then trying to cram this quickly into 2 minutes. The next big piece I want to work on compiler-wise is arithmetic overflow protection, and we have this problem of sort of a language confusion between overflow, which is a well-defined thing, and wraparound, which is the 2's complement result of an overflow. And they're different things, but from the kernel perspective, we don't care. It wrapped around. That's usually bad, except when we're expecting it to wrap around. So we actually need to depend on the -f no strict overflows so that the compiler doesn't remove all the impossible things. But we want to find all the places where we're depending on a wraparound so we can explicitly allow them. And then all the other places in the kernel, we can actually trap when there's arithmetic overflow. So there's some discussion ongoing about this, but I'm hoping we can start to make some progress in the next year on this. If people can jump in and help, that would be awesome. I think that's the interest. I see.
Sorry, we're just gonna get feedback with this thing. It's good.
Anyway, any questions, comments? Yes.
Quick comment. The internal she can mention to fix the data dependency issue.
Yeah.
That's gonna fix the inlining issue. That we have.
Oh, good. That's good. Yeah, that's good. There was a bug with inlining, so some of the like alloc size where you perform a malloc and it would you'd actually wrap your malloc in an inline function. So it was like my special malloc as an inline. Suddenly the alloc size information vanished. And it didn't make any sense, but sort of looking at the internals, we're like, okay, I see why, but now we're going to solve a whole bunch of interesting problems with this, which is nice. And we can reuse it for general pointers as well. So that's it. Anything else?
All right, I think we got 1 minute, 30 seconds for questions here. Any parting thoughts?
I've got one. Earlier on, you said shadow stacks on x86 and no one had looked into it. We have. It doesn't work.
In the kernel?
Yes.
Yeah, okay.
Peter and I did a lot of this whilst we were doing the indirect branch tracking.
Okay.
Basically, you can't have it until Fred comes along in CPUs. There are too many corner cases where things Linux has to do to work around hardware bugs means it doesn't work properly.
That was sort of what I was implying. Like it's a terrible mess right now, and it doesn't. Yeah, I should probably strengthen my language in describing that. It does not look possible right now. Because
it's hard.
Yeah.
All right, let's give a round of applause for our speakers. Thanks, everyone.
So it was switched off. Huh? The mic was switched off or what?
Yeah, I think when it hit the chandelier.
And we are.
And then you can just. Okay, folks, tight schedule. We're going to move on here to the next topic. If I can have your attention. Folks, hello. Okay, we're moving on here. Let's go.
Okay, so now we're going to talk about synthesized call frame information for handwritten assembly in GNU Assembler. My name is Endu, and I work at the Linux toolchains team at Oracle. Should I be standing farther away? Or?
No, I think it's.
Okay. So we have dubbed this project as CFI, and you'll get your fair dose of the acronym today. This is synthesizing call frame information, and basically what I want to go over today is some aspects of the implementation, not detail, but the basic idea here is that GAS has some, the implementation that we have carried out in GAS, it has some permissibility criteria. So not all input assembly is acceptable to GAS if you want to synthesize call frame information. So I want to talk about some of those aspects, and I would like to get some feedback here because kernel is a use case. And so which of the, as I talk through those, I would like some feedback on which of those constraints are very limiting and so on for the kernel, and what can be done to make this offering more useful in general for the kernel and the user space as well. So this is what we are doing in this project, right? So we write inline assembly, and we combine it with the associated CFI directives, which indicate how is it that the stack trace or the stack unwind information for this assembly is, right? So we are in a place where we write both inline assembly and CFI directives, and we want to move to a space where so we want to move to a space where for many use cases, you can just write the input assembly and GAS carries out what is needed to generate these CFIs automatically. And the reason we want to do that is the obvious one, that, writing CFI directives needs a notch more expertise. And sometimes it so happens that even if when you do write CFI directives, there is a bug in it, or sometimes they are not included in the assembly. Either of these will affect the end result, as in there may be bad outcomes at a bad time. You may get a bad stack trace, or if you were unwinding using this information, there could be some state corruption, right? So so this is the mission statement. We do want to target both handwritten assembly and inline assembly. And so what we want to do is synthesize call frame information. And there is fine print, right? So when you say call frame information, you basically want to do some stack, you want to generate some stack unwind information. So what you're saying is we want to synthesize these CFIs, and then this basically means that you want to generate all the information that is necessary to recover your CFA, the canonical frame address, and callee save registers. So there is an implicit assumption here that when you are using a CFI, your code is ABI conformant, right? There's some calling standards that you're following, and which is what the implementation in GAS also relies. So you can use a CFI for ABI conformant code, but not for the non-ABI conformant code base. So let's get the first big elephant out. Can you generate all CFI directives? Short answer is no. There's going to be some of these CFI directives which the GAS cannot synthesize, right? So CFI signal frame, these are the examples, right? Well, this is the set, sorry, not example. This is a set, and you do need the user to indicate whether a particular piece of inline assembly is actually a signal frame. CFI sections is another directive that a user will have to say whether the stack unwind information or the stack trace information needs to be generated in a specific section. CFI label is another one. So for these, at least the user is the only entity that can provide it. GAS cannot synthesize it. Now, even if these were left out, can you synthesize CFI for all input assembly? And as we will see, the short answer is no. There are some constraints that have to be satisfied, but it is doable, and that's what I want to gauge how useful is this for the kernel. So at this time, this is work in progress. Well, we have patches. We have tested it on x86. Limited set of input, yes. Currently, this is what works currently is basically x86, and there is this new command line option SCFI all. Adding support for SCFI inline is on the roadmap, and also adding support for AR64 is on the roadmap. So currently SCFI all for x86, what it will do is it will try to synthesize CFI directives. If the user assembly does contain some CFI directives, like if you have input assembly which already had CFI start proc, defined CFA, whatnot, those will be ignored by GAS. It'll try to synthesize CFI for you, but this set will not be ignored. GAS will try to entertain them. So yes, this is the bulk of what I wanted to talk about. So basically, as I was hinting, there is some permissibility criteria here. GAS cannot synthesize for all input assembly. And I want to go over some of those things that I call as constraints and get some impression of how limiting this is for the kernel and maybe other code bases. This is a brief trailer. There is fine print, but I want to go over it just to give you an idea of what's coming next. SCFI is only for ABI conformant code. And since you are dealing with SCFI, as in you're wanting to generate you're wanting to synthesize CFI, there is an implicit assumption that you are interested in asynchronous stack unwinding. You are aware that you will write the code such that at each PC you are interested in stack walking and stack unwinding. So we'll get to the fine print, but and the third one is the CFA. The CFA must be registered SP or FP based, as in well, maybe let's talk about this in the next few slides. CFA based register, either if it is SP or FP based, it has to be traceable at all times. Let's talk about it next. And the last one is that if your code does have indirect branches or jump tables, something that does not allow GAS to create a control flow graph, GAS will bail out, giving you a warning, that this control flow is not something I understand. I'm not going to give you any SCFI for it. And we'll see why. So now I'm going to talk about those, the constraints, so to speak. So first thing that the GAS has to do is figure out what is the start of a particular function for which you desire CFI. So the first requirement that it says is, can you mark the input assembly for me? So what you have to do is say a dot type and name of the function and so on. So if you were writing a single ASM file, it does not mandate you. So ending it with a size is recommended in that cases. But if you were multiplexing different sections, so for example, you started writing a text section and then you decided to write some code part of your function in another section, you should end. This will be mandatory on GAS. The implementation will be such that you have to indicate to GAS where is it that this function has ended using a side directive. But if it's for a single function, closing with dot size will be recommended. For inline assembly, let's skip for now. Let's focus, I think, for today just on the input, the .s files. The second thing that GAS will enforce for SCFI is that control flow, right? So internally in GAS, it tries to interpret instructions and then carry forward the CFI from a basic block to the next. Now, if it's and as it does it, it tries to validate that if there are two different control flows. So for example, for the basic block D, there are two different control flows reaching it. It tries to validate that is the CFI state reaching D from ABD is the same as ACD. So it tries to validate at each incoming edge of a basic block, does it make sense? Is the state consistent across what I've seen so far? So which is why it needs to generate that CFG. And if in the beginning of this pass, it says that there are these indirect branches or so on, and I cannot create a CFG, I'm going to bail out. So GAS gives you a warning at this time. It says untraceable control flow, skipping SCFI, right? So this is a second requirement. If you have functions which have indirect branches and so on, SCFI is not useful for it. Now we are switching gears and we talk about, more on the lines of how is it that the input assembly should look like? Now, as I was hinting earlier, there is a notion that SCFI is for ABI or ABI conformant code, so you should have followed the calling conventions. So internally in GAS, what this means is that GAS is going to. Mhm.
I just had a quick question. I'm assuming that we ignore the syscall entry point, right? Because all users are going to be ABI conforming and following PCS, but as soon as you get to the syscall point, you don't follow ABI or PCS at all.
Yeah.
Sometimes we have to get 5 or 6 registers or 5 or 6 arguments into register, enter the kernel, and then things start following PCS again. So do we just skip? Are we saying at this point? I'm just trying to make sure that for the input asking convention, are we just skipping the entry points? I mean, Go has handwritten assembly against the kernel, so does C, Go, so does muscle, so does a bunch of stuff. So do we skip that
Part?
Yes.
Okay, perfect.
Yes.
Because the stack pointer is going to be consistent.
Yeah, but the problem will be that the syscall, everything in the syscall will be different. The registers and everything else will be totally clobbered. We move things around, we reorganize stuff, and then we call into the kernel. And there's also lightweight syscalls that follow alternative PCS into the kernel as well. And that's for, I think, 32-bit ARM and 32-bit PA.
So what cannot be done is GAS cannot warn you.
So I just want to say one thing. So far, you've described this as a per file attribute. We have mixtures of functions in the same file where some of them are ABI conformant, procedure call standard compliant, and others are not. So this would probably need to be a per function attribute, that whether or not we do this.
Yeah. Yeah, so what I was saying earlier was that, yes, SCFI cannot be used for it, but the challenge here is also ideally, it will be good if you could warn the user somehow, but that's just not possible because of the nature of things as an, so GAS will try to, GAS has the reason how all of this is weaved in is basically GAS has the idea about what this ABI is and hence what the callee save registers are. So it tries to figure out these are being stashed to stack and so on. But if you don't, it won't warn you before you do that, before you smash it away without saving. So yes, so continuing on the ABI and calling convention side, GAS will try to, GAS has a notion of what are the callee saved registers. So it'll try to figure out first, where are the saves and where are the restores. And and it does try to protect you to some extent on asymmetric saves and restores. So if you saved the callee saved registers and restoring in maybe in different order and so on, it'll try to cross check what is the offset that you are saving, that you had saved this to, and is the offset at restore the same, and it'll try to warn you if this is asymmetrical. The third one is balanced stack at return. This hasn't been implemented, but it could be done in GAS, as in it could warn you if at return the stack pointer is not the same as expected. So how is this a restriction? Well, it's a restriction in the sense that if you write unsafe assembly, SCFI will try to warn you in many of those cases, but there is no guarantee, I think, for at least the symmetric saves and restores that you will get a warning in all cases, because it is a little bit complicated for GAS to figure out sometimes that this restore is at the same address as save. The last set of restrictions that are basically coming in are because of asynchronous stack unwinding. So because you're using SCFI, the assumption here is you are interested in asynchronous stack unwinding and you must have written the code accordingly. So let's talk about that a little bit more. So dwarf standard at least says that CFA, your canonical frame address, can be one of these two types. You have a register, and from that register at a specific offset, you know where the CFA is. Or dwarf may also allow you to recover CFA using some dwarf expression. Now in GAS, there is no way you can synthesize a dwarf expression. So the assumption here is that you must have some code where this is easily, GAS can easily figure it out, right? So what this means is that, so in in your functions, you're most likely doing one of the two, of course, static stack allocation or dynamic. So for static stack allocation, this is not a problem because you were anyway using register SP and you were anyway not doing it in an untraceable way. Untraceable just means that you got your stack pointer and you're not doing something like adding a register to it, and you don't know at a particular point in your program where is the stack pointer, right? So in static stack allocation, you will most likely have it traceable. This is not an issue. And for dynamic stack allocation, though, what we would like the user to do is switch to FP. Most users typically do that, except, well, you may use some register to, to stash your stack pointer in. What GAS and SCFI implementation is asking is that you use frame pointer and nothing else. So switching to any other callie saved register is not supported. And this is mainly because if GAS, the implementation becomes bulkier, it's much more simpler to just constrain it, saying that, can you please use our register FP for saving away your stack pointer if you're doing dynamic stack allocation. So typically what you would do is, you'll save away your stack pointer and then do your dynamic stack allocation, restore, and this is a typical template that GAS would expect. But if it sees that SP is being stashed away to some other register, it'll complain that this is not supported. So which also consequently means that DRAP is not supported. Now DRAP is the dynamic realigned argument pointer. GCC tends to generate it in some specific cases. I still have to, get my grip on it. In what cases is DRAP really coming out? But it is not supported currently. It is a very specific pattern, though. If you are using DRAP patterns in your handwritten assembly, we could somehow accommodate it because it's a specific pattern. But I think first thing that I want to do here is at least first go and get a full grip on it. So essentially what all of this is coming out to is that your CFA has to be register SP or FP based. Nothing else is supported. Okay, so at this time, I think I've covered most of these, what I called as eligibility criteria. And this does limit, so we started out with this mission statement that we want to synthesize CFI for input assembly, but we do see that GAS cannot do it for all input assembly. There are these set of permissibility criteria. How useful is it for the kernel? I haven't had the time yet to go and look at or try it on the kernel input assembly, but I would like to get it at some point. And what else can we do to make it more useful for the kernel? I know there are some some patterns that were brought to notice, but I haven't looked at it. Basically, if the kernel is doing things like alternatives, how does this fit in? I still have to close up on those things, but any inputs or questions?
I was going to say, in addition to alternatives where you can patch in branches and so on, we also have exceptional control flow through the X table mechanism. So things like U-access, where what looks like a load or a store instruction will actually effectively be a branch to an exception handler elsewhere in the assembly. And GAS will have absolutely no visibility of that. In those cases, we do go and create an entry in a different section as well. So push section, drop some entries in there, pop section and so on. So we've got a lot of practical cases like that. That will be a lot of inline assembly does that sort of thing, because that's why we're using inline assembly in the first place. I think we've got many cases where we do weird control flow all over the place. And as I mentioned, mixtures of functions which are PCS compliant and other functions which are not PCS compliant. I really think if this is going to be a thing, it needs to be a per function opt-in explicitly rather than a global thing on the file. Because then we can at least say, I know that this is a simple control flow function, just do it for me. And then we're not surprised by it missing something else. Right. And sorry, one last thing, then I'll hand over to you. And I think on ARM64 in general, our opinion has been we don't want to reverse control flow at all if avoidable. So we really only want this for simple functions. That's would be like library functions like memcopy and that sort of thing. And I think for everything else, we would be largely happy to write explicit annotations. And I think that would be our preference because we just don't want to be surprised by the tool doing something automatically behind our back that we're not expecting.
All right, so on x86, our goal, because of live patching and the ORC unwinder, we have OBJ tool, which is already doing a lot of this control flow graph reverse engineering. So we don't have any gaps in the entire kernel as far as unwinding metadata. So at least that's our current status, is there's no gaps. And the way we did that was we have these unwind hints. So if like we already have what's similar to what you have, where if you analyze a function and it follows ABI, that's pretty straightforward. But then all the other, there's quite a bit of assembly code in the kernel that doesn't follow ABI. So in order to handle that, we have these unwind hints, which are analogous to CFI commands. And so we just follow those. We still understand those and follow those and follow the control flow graph from the hints as well. So doing that, we have like full coverage of all the assembly. So if the goal were to have full coverage even outside of function of ABI, functions, it's possible. You would just have to read, instead of ignoring the CFI hints, you'd have to read those and incorporate those into your control flow graph.
Also, for one thing that I've been wondering is that all of this is more than what the kernel and OBJ tool generally provides, right? It's just stack walking. This goes to the extent of stack unwinding. So there are more guarantees in place that it asks. So if it's just stack walking, then it's just the SP and FP that you put your rules on. So ABI conformance in this case, ABI conformance is, like a spectrum of different decision points. For just stack walking, it's a lesser restriction than stack unwind. SCFI currently is in the stack unwind category. But if we relax it somehow to just generate, say, stack walking information, because what this is generating is all the complete dwarf CFI. The complete dwarf CFI is for stack unwind. A subset of dwarf CFI is what you need for stack tracing. Currently, you don't have that flexibility in GAS either. SCFI is just stack unwind complete. I did wonder if that could maybe solve some of these, non-ABI conform. You could accept some of those non-ABI conformant code as well.
Covers additional registers, not just the stack pointer and frame pointer?
Yes.
Okay. So from a consumer point of view, I would love for something like this to just get rid of alternate formats like ORC. But that's so for that, like, I guess again from like the consumer point of view, it'd be great to have full coverage, and have falling back to a stack walking only mode for functions where you can't figure out the rest of the registers is still way better than just not having anything.
When it comes to the, I mean, we thought that doing this, like to reverse engineer the call frame information and also the control flow graph at the assembly time, basically some advantage that they may have, compared to actually doing the same thing from the object files, is that when you work with the object files, you have to actually handle everything, right, including compiler-generated code. And that can get tricky. And so basically, with this approach, you can still use the call frame info generated by the C compiler for the compiled parts. And then you can get the assembler to reverse engineer the rest of it for you, right? Like the handwritten assembly or inline assembly. And for that, of course, you have to keep the CFI information generated from GCC and incorporate it into yours.
Yeah, so one thing I'd urge some caution on that is that, for example, in ARM64, we've gained new branch instructions and new control flow instructions in the last year. So if we're relying on the assembler to understand those instructions in order to actually regenerate this control flow, we can't add those new instructions in the kernel until we upgrade to an assembler that knows that. And today, that's not what we do. We go and hand assemble the opcodes for new instructions so that we can work with old assemblers. So, sorry. So relying on the assembler to understand the semantics of the bit encodings is not going to be workable unless we provide additional restrictions that you have to upgrade your toolchain.
If it incorporated the CFI, you could also include.
If it incorporated the CFI as part of the assembler's control flow graph, then you could insert the CFI along with your manual instruction.
Yes, I think from my perspective, the best thing here is going to be a mixture of this and manual assembly, which is why I said earlier that I think we really want explicit opt-in for this for the simple cases, because then yeah, I'm perfectly happy to use this for things like memcopy and whatever if that works and we can rely on a tool chain that is up to date and understands the basic control flow we do there. But I don't really want to rely on it going forwards for absolutely everything, because I know that we're going to have new instructions that the assembler doesn't understand. I know that we're going to do weird new control flow that we don't do today because we have plans to do certain things, and there are things on the cards where we will just come up with new things that this doesn't understand. I don't want to be hamstrung by that. And I think further, one of the reasons from R64 we said we didn't want like reverse engineer control flow with optool for the kernel was that the agent generating the thing, the agent generating the code, the agent actually generating control flow information were different. I would be more happy with using optool to reverse engineer handwritten assembly control flow, because we're in control of both parts. We can upgrade obstool to match our expectations as kernel developers. It's very difficult for us to go and update the assembler to match our expectations, because there's just an impedance mismatch. They're being different projects.
And what if you could configure the assembler? Because the generic instructions that this is actually implementing is not that many of them. And what if, if you could actually tell the assembler, so this binary pattern is this new instruction, and translate it into this
How
generic
is that any different
instruction
from just manually adding the annotations
as
or
a
using optional to do that?
Sort of a configuration file, yeah.
That seems very fragile to me.
How?
Sorry, but I think there's a lot of detail that we can't really cover right now on what was that configuration file look like? How is it interpreting the bit?
Oh, well, yeah, but how is it fragile? That's what I don't get.
Sorry,
the approach, how is the approach fragile? In the sense that you say, okay, this particular instruction is actually saving the value of this register into this. So,
Okay, and if I've got a branch instruction with 26-bit immediate, which has a weird scaling factor for that immediate, where like small values are linear and larger values and have jumps and that sort of thing.
Okay, so it's the complexity of the encoding,
yeah.
right? Okay.
So there's that, and the semantic could be complex, and I don't know how you would express that in a simple way, which is why I'd prefer to generate that myself, whether that's manually adding annotations or having something like optool that I'm in control of as a kernel developer to do that. So I think having that in the same place is the important part. And it's not that the technology here is wrong, it's structurally difficult because one part's in the assembler and one part's in the kernel side, right?
Yeah. Yeah, it has to be, the support has to be in the toolchain for it to be uptaken. That's true. That comes with the offering, yeah.
As well, that's in an extension coming along, hopefully sooner rather than later. One thing you said earlier about the case where turning this on would ignore existing annotations. Why is that? Because sure, in the case that you have existing annotations and there is a mismatch, surely you can warn about it. But in the case that some bits are handwritten, generally that would be preferable to ignoring it and figuring it out yourself.
You could go that way too. The reason it's ignored is because, so in a way, when you call the assembler with SCFI, you do intend The intention for that argument is to synthesize. You could provide another argument where you say, I have it, don't ignore it, try to validate it. But we just didn't consider it as the first option to go to. But if that's useful, it could be considered. But the catch here will remain that this should not be used for compiler generated code. It should be used for, handwritten assembly. And the reason being that compiler generated code looks, well, first, you don't need that. And second, there is more complexity for sure.
There are definitely cases where it's going to need manual annotations. And if this is going to be useful, the manual annotations need to be honored as given. You look at things like the speculative mitigations we've got, and we have some horrendous nonsense in there in terms of control flow and instruction encodings. And there's no hope that an automatic tool can understand that. Whereas in that case where we provide manual annotations because, well, we know better than the CPUs in some cases, that will need, if you want this to work, there are cases where you will need to accept manual annotations, and you need to have a way of making that easy to do.
The manual annotations are for what exactly in this case? They are saying they are indicating CFI for what are these manual annotations?
Well, I don't think we have any at the moment because it's all obj tool, but
there's unwind hints. Unwind hints, which are annotations. They're analogous to CFI annotations. And yeah, we have those quite a bit, but that's because we have a goal of full coverage, and you're not necessarily going for that.
Yes,
here.
yes, and that must be, those unwind hints must be for the cases where it's not ABI conformant, or so to speak, right? Something that, so those cases where, for example, the stack pointer is, the CFA's base register is something else. So those specific cases, right? But for the standard ABI conformant cases, you do not need any unwind hints. Correct?
I think that's correct.
Yes.
Otherwise, it's not ABI conformant.
Right, right.
So let's take, for example, like a very basic case of like 32-bit mem copy on x86 out-of-line assembler. Do we know, does that have manually annotated like CFI directives in that assembler? Does it have so the answer is no for the recording. Like people externally, sorry to get another mic, but do we have unwind hints in those? No. Okay, no as well for that. So it sounds like maybe for like a simple case like that, that's maybe a good start for something like this, is if it's just an assembler flag, you can say like, we don't trust the person writing the assembly to get it even right here. Maybe we could auto-generate it.
Yeah, sorry, that was what I was trying to say earlier about having an explicit opt-in per function. Because because we, like in the kernel, we got the simfunc start, simfunc end. If I have a thing where I can say, this is a simple function, I know I'm not doing anything special with control flow and following certain rules. But I'll give it to you in a second. For those cases, yeah, sure, that would be fine, as long as we don't have the other issues I mentioned earlier about adding new instructions and whatever. For more complex cases, we definitely do weird things, even in things that we annotate with simfunc start, simfunc end, because it's like a bit in the middle where we have unusual control flow. And I really don't want a tool that automatically does this thing for an entire file without an explicit opt-in per function, because otherwise I just cannot turn it on.
So on x86, we have a requirement that if you have simfunc start, simfunc end, which gives the elf file or function annotation to the function, then you have to be standard. Basically, don't do anything funny. It's just kind of the standard that we have.
Yeah, sorry, and I think on ARM64 at the moment, because we don't have absolutely everything, our only requirement for simfunc start, simfunc end is that you're using a link register at the function call boundaries, and you're using a frame pointer at when you're called into something else. So, but in the middle of those two sections, we have no real structural requirement that you're not doing anything weird. And so if you've got things like X table entries, that's fine to use in a simfunc start, simfunc end thing, and that would confuse a tool like this because registers are suddenly changed behind your back by something that happened behind the scenes in an exception handler, right? And so there's a range of possibilities for different. Well, it would affect the unwind case though, because registers have suddenly changed, and so things have moved between registers without the assembler's knowledge, right?
Sorry, let me grab another mic for you guys. I think
Yeah.
there's two. Is there another one over here somewhere?
I think this was the one from over here, so I think just
Did we lose one? I guess there's only one. Sorry.
no, just got the.
Oh, there it is.
So, hello. So for the exception case, are you talking about the changed registers? Is that inside the exception or after you return?
Yes. So in the exception case for like U-access, we try and do a load of user space address.
Yeah.
And then we take, because it faults, we take an exception. And in the exception handler, we will mess around with a bunch of registers. We'll change a value in one. We can shuffle things around. So if you're using this for unwinding and trying to say, here's where this value was, that has changed behind your back. No, and there is no visibility of that in the source code at all. If you're using it, sorry, unwinding in the sense that was mentioned earlier of getting all of the information out.
Right, but the stack size is still the same in the function that.
Yeah. So for just getting caller information and doing a stack trace out, yeah, it will be fine. But if we were trying to use this for unwinding for the more complex unwinding cases, that would be insufficient. And there are other cases where we do other unusual things today where things will change. But I think the key thing is, at the moment, we have an idea of this is procedure call standard compliant. Actually, there are a variety of procedure call standards that we might be in use in different places where we want to annotate them differently. And effectively on x86 with the different return type return mitigations, you're effectively got a runtime choice between a few different procedure call standards that gets patched in at boot.
Yeah, right.
Sure.
So back to the new instructions. So I guess that if you add new instructions in ARM64 and you don't want to bump the requirement on the assembler, I guess that you are encoding your instructions using data directives, right? Somehow in the handwritten assembly.
Yeah, I'm using inst directives, and it's a standard thing. Like we've done that. In the past.
Yeah. So do you have the any slides or something where you can see the G instructions intermixed with the normal x86 assembly? Well, so basically what the assembler is doing for this is that in the particular target in gas in the assembler, certain instructions get translated into some sort of generic internal instruction, which are super simple, right? We call them GINs for gas instructions. And if we added support, so you could say that .inst, you encode your fancy new ARM64 instruction, and then if we will add a directive, so you could actually write the equivalent G generic instructions for that. You will not have to deal with the encoding at all.
Yeah, so I think maybe going forwards, but practically we have to support existing tool chains which don't have this. We have to have one solution for those, which is to handle assemble things using inst. So I would much rather explicitly have annotations that I have to add for whether they're CFI directives, whether they're unwind hints that we munge into something else, whatever. I'd rather do that because then it works with the current tool chains and works going forwards. I'm happy to do things that work better going forwards, but I don't want to rely solely on new toolchain functionality where we might get caught out by the semantic is not currently expressible in that generic thing, and that needs to evolve in future in order for us to be able to express it. And that's
yeah, okay.
So I was kind of curious about. So Mark had this, request about functionality, like being able to turn this on or off per function basis. Do you have any assembler directives in here to be able to say, like, I want this function to have inferred CFI versus I don't want this function to have inferred CFI? Because that might be useful maybe to opt in or out more flexibly. And I think like having a compiler have function attributes is nice because you can then opt out or opt in. And then the compiler command line flags essentially just add this function attribute to every function or not. Makes it easy. One thing that might be helpful too for kernel developers trying to write assembly and getting their CFI directives wrong is like, it sounds like this tooling is in the assembler, excuse me, to when it's generating the object file to generate the correct like data representation for the CFI. It might be nice to be able to feed the assembler like a .s file and say like, can you tell me how I should write my CFI files? And then I can manually go and put those back in sources. Like if this is trying to reconstruct control flow of the assembler, and generate the CFI directives, like, can it just spit them out to std error and say, like, maybe you want to put these in manually, and then we can worry about putting them in the right place or not when we have support?
I mean, in a way, the flow exists, but there is a little bit of work needed there in the sense that once you have generated the CFI, you can emit them in the EH frame section, read it up, and then reverse engineer from there what CFI is needed. But verbatim, no, they are not dumped out right now. Yeah.
So, kind of bubbling up the conversation a bit once more, it seems from the assembler's perspective, it's probably a more useful thing to have this as an assembler validation feature, which then auto-generates CFI for functions that don't have CFI. So that way you can use whatever CFI is available and not tinker with it, but at the same time validate it and probably throw out warnings wherever you find bugs. And then in functions that don't have CFI, you just like put it in there.
Yeah.
And that also would probably be a more easily acceptable solution for all existing like assembly implementations. And I'm looking not just at the kernel, but at glibc as well for that purpose.
I think Will Deacon is making that point on chat right now. For our audience here, I see Will making that point that it might be nice for GAS to validate handwritten CFI directives.
It would be like the beginning of assembler validation. Semantic validation, not just.
So one use case that I have in mind, maybe it doesn't apply well to kernel, but for user space, is JIT code. If you want to emit CFI directive for code that's been generated at runtime. Now, it seems to me that this tool is integrated in Binutil in GAS for static generations. What about dynamic generation of CFI directive?
Not sure I understand it perfectly. For jittered code, why is the problem?
Unwind out of the JIT code.
Right.
Yeah, exactly.
Right. But why is the problem any different? Like it is still the same problem that given some input assembly, you want to synthesize.
Yeah,
CFI
it's just that
afresh
the
for
tool
it.
right now is static, right? It's part of tool chain and
Right.
it's not part of dynamic at the runtime. So having something in the runtime that I can include and say, okay, this byte code now it's been generated to native assembly. I want you to generate directive for me so I can have the S frame to do the unwinding.
That would be the response.
Yeah, to call that, but it's the responsibility to put that out of Binutil and put it as a library to be used.
Usually, Binutil is not the
Yeah.
Yeah, but we don't have an assembler in a library in Binutil.
Okay.
Yeah.
It's up for us.
Okay.
Yeah. Yeah, it's very tied to GAS and Binutil's workings. It's not something easily exportable at this time.
We got 5 more minutes for questions, just as I check.
Based on some of Mark's comments, I wonder if this would be more useful for the kernel perspective with inline assembly, because the ARM64 people are very much against OBJ tool reverse engineering the control flow graph of GCC, compiled files. Whereas you seem more amenable to have an OBJ tool with assembly files, right?
Yes, I think, just to be clear, personally, my opinion is perhaps different from Will's and Catalan's, who are the ARM64 maintainers. I just want to call that out ahead of time so I don't say anything that they disagree with. But yeah, in general, we didn't want Obstacle to reverse engineer compiler generated control flow because they are distinct agents and they evolve differently and things change over time and that sort of thing. So for the same reason, I'm not keen on reverse engineering handwritten assembly in the assembler because they're two different things from actually different time. But I'm more happy with having something like Obstacle in the kernel tree, which is owned by the same people writing the inline assembly, doing that sort of reverse engineering. I also think that for most inline assembly, the control flow is the control flow is going to fall into two buckets. Either it's going to be really simple, where you're trying to target like 1, 2, 3 instruction sequence that's not doing anything with control flow at all. It's just straight line, which is fine. So I'm not sure it's the vastly common case, but sorry, what I was going to get to is that there are two big cases. That's one of them, and probably in terms of like number of instances in the source code, that's the common case. But in terms of number that get generated, I think X table style, we take an exception and do some things and come back and go to a different place. So there's just some implicit control flow that's missing. I suspect that's actually more common by terms of instances in the binary, because like get user is everywhere. And for those cases, I think we're going to have to have manual annotations anyway. So I'm not sure where the boundary falls on.
Even if you could put CFI in the. Even then, you could put CFI in the inline ASM to. Yeah.
I think just having an ability, whether it's a macro that we have, like in the kernel source tree, or it's a tool, whatever, where we just say this is a simple case, just make it straight line for me. That would be nice. I don't know if that requires external tooling at the kernel source tree or additional tooling. If that's something we can just do with existing directives. And that, I think, would cover the common cases, which I think we're both agreeing on.
So for the inline assembly case as well, is there a need to provide something like an opt-in or opt-in, opt-out? Are there cases where inline assembly may be doing fancier things?
Yes, there is a mixture for inline assembly.
So then this has to be an additional CFI directive.
Yeah, so I'm saying, I think the key thing I'm saying is we want something explicit, whether it's saying this is simple, just figure it out, or I'm doing something unusual, I have to go and write every single thing. But it's a nice to have that for the simple case, we could just have a single thing that says, this is simple, straight line, just do the right thing. And I don't have to add an annotation between every instruction, for example.
It's worth saying that in things like alternatives, we do have cases where one side of an alternative is straight line and the other side of the alternative is a call. That causes a huge number of problems.
Yeah, so and static calls, static branches, obviously a similar thing. ARM64 has alternative branches, which are like static branches, but done through alternatives for reasons. We don't have function calls today in alternatives, but we are likely to have something like that in future. So we definitely have cases where like the assembly you see in place is going to get patched with something that looks completely different, have different control flow and different manipulation of registers.
But a call instruction doesn't affect the callee's stack.
On ARM64, it will clobber the link register. So if you're using the frame pointer to do the unwind, that's fine, but I believe effectively you'll have to say that the link register is clobbered. But if your unwinder believes that the frame pointer information and the link register information are equivalent, that would be wrong. So it may work out, but there are additional things to consider.
Thank you. We have a break now, 10 minutes.
I don't see how this works without having just validating the CFI that you have and then letting you add your own CFI annotations.
And the validation has to be altered as well.
Yeah.
You don't
Right. So on a per function basis, you should be able to say this function is totally
something is. No, somebody said. Okay.
Alexi says he can hear you.
Okay, perfect.
Cool. All right. Yeah.
We start.
Go ahead.
Okay, hi. I'm Matthias. I'm from the Android systems team based in London. And yeah, this is actually a joint talk with Giuliano, but Giuliano is not here today, but he's on chat. And he is very responsive to any questions that you might have in chat. And arguably, he's also much more proficient on some of the things I'm talking about. So we are talking yet another time about ABI monitoring. ABI monitoring the kernel and a bit beyond. So what are we doing actually? We are the Android systems team at Google, and we care about the Linux kernel and Android. We care about a generic kernel image, means a single binary for all the devices, reducing fragmentation of kernels. We also care about a bunch of system libraries, components, and lower level stuff that I'm not going into too much detail right now. And we have a growing tooling team that cares about stability of the artifact that we are producing, that we are releasing, like the kernel itself. If you are wanting to guarantee anything that is related to API stability or general stability for that matter, for production devices, runs of billions of devices, we should really do hard, or really should do a good job to keep a stable tool chain and everything. So why do we care about APIs? We, as opposed to what the kernel does upstream, we actually try to guarantee some API and API stability between the kernel and the modules, which is not something that the kernel upstream wants, and also not something that we want to try to achieve. But within boundaries, like same compiler, same configuration, same LTS, there is some stability guarantee that you can give within releases, such that the generic kernel image, like VM Linux for that matter, can be exchanged independently of vendor modules, just based on the API contract. We also do user space monitoring these days, increasingly in AOSP for Android libraries, like improving their like stability for APIs on the NDK. That's fairly recent and soon to be properly landed. And yeah, as the mission line at the bottom says, we want to capture API surfaces, or we want to capture breakages of them and detect changes at build time, such that they not become an issue at runtime. So the line between API and API is a bit blurry. Often things you can detect from an API change that is relevant, that leaks into what you would traditionally call API. I think most of the people in this room know what an API refers to, and that it remains blurry. So I just skip over this slide and just talk about what is the actual process behind often. Traditionally, if you do things at build time, you build, first of all, a binary. These days it comes with usually with dwarf type information and ELF, for example, symbol tables. And you extract, you have a baseline binary, you have a candidate binary, like for example, with the proposed patch, you extract type information or symbol and type information and get to a representation, and then you compare them. Fairly simple process, but the difficulties in the detail. What do you extract from? Dwarf is one input. More recently, CTF is an input. It's an effort that we are looking at very closely. BTF as another input that we experimented with, and which is basically the motivation for the whole project that we are starting.
Obviously, it's not as easy as just extract type information. Dwarf is special in many ways, and particularly not made for monitoring ABIs. CTF has some sort of solution for that, or like goes a long way on making it much more suitable for that case. Yet we are not having access to CTF so easily because we are a Clang we have a Clang-based build that does not natively produce CTF, as for example the GCC does. As for comparison and reporting, it's mostly comparing them and reporting any differences, which seems again trivial, or at least not that difficult, but it's surprisingly hard to get actionable feedback out of a report that the developer can actually make use of and understand what kind of code change subtly introduced an ABI difference. A big acknowledgement, of course, to libabigail, which we used in the very beginning, and it is still the de facto monitoring tool for anybody doing API monitoring for distributions, for kernels, obviously open source, actively maintained, almost daily changes go in. It has a broad compiler language and packaging support, and it's largely available in distributions. We used ABIDW, which is the extraction tool, until Android 13, and we used the diffing tool that comes with it until Android 12. Why we are not using it anymore and what the motivation is there will come next, but it doesn't say that the tools are not suitable. They are still suitable, but we at some point started experimenting with other things and found alternative approaches that, particularly for the use case that we have, worked quite well. And libabigail does more. It can like literally download Fedora or Red Hat packages, unpack them, compare complete ABIs, things that the tooling that we're working on might or might never really support, or support in very different ways. So like we don't make any promises, and we are not also like pursuing the way of comparing whole distributions at this point, but it doesn't mean we couldn't in the future. Okay, how do we get to like why do we something new? Why do we do something new? It all started with I think it was a Facebook microblog site that spoke about an algorithm to take dwarf using effectively PA hole to create a BTF type information, and it was kind of showing off that 124 MB dwarf relevant could be compressed, or like could be represented in 1.5 MB BTF, and it was at this time, because we can transform dwarf via PA hole to BTF. It was not limited for us to any tool chain, so we could actually use it. So we postulated an intern project to say how maybe we can use BTF in the long run, because you can embed it in the production binary even. So you can do ABI monitoring on the production binary, where dwarf often is stripped off because of its size. And BTF had some properties that are like the way it was structured and the way PA hole already deduplicated types, and it was quite suitable to ingest. So we started and try to understand how can we use the BTF format, how can we represent it internally, and one led to the other. Like, okay, we have a BTF reader and we have an internal representation that is fairly close to what BTF represents itself as a binary format. And there was like, okay, how hard can it be to, based on that, how hard can it be to create a comparison algorithm? Why is comparison of ABIs inherently hard? And so within this couple of months of intern project, we actually came fairly far, and from nothing to a BTF reader that could do some preliminary comparisons even of the kernel. And we were surprised how well this whole format like reads, represents, and how well it can be used for comparisons as well. But then we realized, okay, there are more problems to comparison. Cycles, for example. This is clearly not a DAG. This is usually a very complicated graph with cycles. And so we wanted to understand, like, how can we do comparison algorithms that are actually sustainable in the long run, like can deal with really large graphs, really complicated graphs. How can we possibly create an algorithm that can be extended for other languages? Like at the moment, we started with BTF, and BTF only supports C. It's like, how can we make a model that possibly can support C++ in the future, other languages? How can we effectively create an algorithm that handles cycles? And how can we avoid repeated comparisons? How can we minimize the number of comparisons that we actually have to do? And so this is the huge credit to Giuliano, who actually did all this deep research and understood, and I think to this day much better understands how SCC internally really works. So we came up with a comparison graph SCC model, like strongly connected components model. And so in this model, we describe a graph with SCCs, and within an SCC, if there's any change, it implies any other node has also a change. And based on that algorithm, we created a little library. So I'm not going into detail on SCC works. There's a huge document that describes the details, and I think there's room for another hour of talk at least on how to explain how that particularly works. But we could actually create a library that, in the end of months of research, is like a couple hundred lines plus tests that you could facilitate in a tool like the BTF reader and the BTF diff tool. To do comparisons based on SCCs, like cycle-aware comparisons, with memorization and and basically recursive comparisons. We use the path-based strong component algorithm. I think there's a Wikipedia link if you want to click. The slides are, by the way, up, so you can actually open them and click these links. And the SCC Finder is a library within the tooling that encapsulates all this logic, so that the actual main code doesn't really have to deal with that. So, for example, why are there cycles? For example, you have like something like a linked list or like a self-referencing data type, and you see the cycle in the data structure immediately. And if you put strongly connected components on them, you can see, okay, if something within this realm of struct n changes, and everything basically changes. But if you like step down into foo, this is an entirely different area of comparisons. But you only need to do the stepping down into foo and the other component ones. Okay, then we had BTF diff, and then we said, how hard can it be to actually generalize this model a bit? So we have a graph structure. We have algorithms that can diff. So we refactored the code a bit, made it separately. We have a separate reader. We had like that reads into graph structures. We refactored our monitoring or reporting tool a bit to give different options for developers on how to report actually changes. Some more verbose, some more actionable. And at that point, we realized that the actual BTF reader is just a couple hundred of lines. So again, we thought, how hard can it be to write an XML reader for the libabigail format? And it turned out using libxml, and we are actually able to read the C, libabigail XML that is produced by C code, or like based on C code, fairly quickly. So then a couple hundred lines later, and okay, it was a bit more work, but it was not based on the code that we had and the refactorings that we did. It wasn't too hard to create that. And for a long time, ABIDW as an extraction mechanism that still has the whole dwarf reader logic and everything in, and stgdiff as a comparison logic as a comparison tool was our tool chain. And then we actually like the whole project is open source. It has been from the very beginning. Even though we do changes internally and we mirror them like a couple of days later, that's just because we can use them in a much richer testing context when we do the actual changes. But it's the whole project is hosted in AOSP and Apache 2 plus LLVM licensed. Pretty much following what libabigail does. And we also open for contributions through that way. It can be built with CMake, and there are some pre-builds available that get away with the binary dependencies that this might have. So we have few dependencies that we rely on. So, but if you want to just try it out with the binaries and don't want to install any libraries to build it from sources, then there are some pre-builds that just work against most libcs. We use it in the Android toolchain, so it runs as part of the Android kernel build on many people's machines already. So that's so as an example for the reporting. So this is a very trivial change. Just has a kind of a chained, like chained structures or structs, and we are changing a data type. And so this was the very first version of our of like how we can represent a difference. And nowadays we call it like plain. It's like reporting everything. This is caused by this, is caused by this, is caused by this, is caused by. And it can be quite hard to understand what is the like what happens here. So based on how the graph is represented, we can also use these kind of elements of the graph to bring like especially also of the diff graph to chop up the actual details. So that already looks much better. Say, okay, like there are individual changes that depend on other changes, but we can still not really see the root cause here that causes the change, like the propagated changes. And then we have small, which tries to focus on just the actual change that propagates other changes to other structs. So this would be what our default ABI monitoring actually also prints when you do Android kernel builds and do ABI monitoring on the whole kernel. So you also use the small format, basically saying this struct, this member, this data type, that's what causes this. And that's and if the use case is a stability monitoring and you expect no changes, then the small format is the one that gives the quickest insight on what is actually causing an ABI change. Because at the same time, you're also doing a code change that introduces it. Then we had another intern project. I said, how hard can it be to also support the full C++ type system? And obviously that was much harder. And first of all, we wanted to model the C++ model that we get from libabigail. To be able to ingest libabigail XML, and so we can still rely on an ABIDW. And we did some design decisions there and how to represent certain specifiers and like how to deal with particular elements of the language, and sometimes went back and forth, and really also felt like. At some point, I hear me saying, libabigail is at some point opinionated. And then I said, let's try not to be opinionated, because sometimes we have different opinions. But then you see, if you look at it, yeah, we ran into similar things, obviously, and try to think hard about solutions. At some point, we came up with very similar solutions. At some point, we tried to model things differently, as you can next see in some demos. But again, it comes to a huge acknowledgement of the pre-work that LibEpica did at this time and how it influenced our work very richly. Another thing that we worked on is like we do a tooling that does ABI stability, and as such, we want to say we have a representation of our ABI, and if we compare, and at some point we want to say this is our representation, and nobody is allowed to break it, and so we want to just check it in the source control, and in order to compare it, we needed to be like, even to evolve it. For example, additions to our ABI, to the kernel ABI, are okay. So we allow additional types to be in, we allow additional symbols to be in. So this evolvement needs to be accommodated when we look at the native format. So it needs to be version control friendly, it needs to be text, and we need to have a format that where minimal changes cause minimal representation changes. And that's, I think it was one of the hardest problems in this whole journey, to actually come up with a format that satisfies that. And in particular, we have process of updating ABIs concurrently. So we also try to make it rebase friendly, so you can actually rebase ABI representations. And I think besides some occasions, it actually works quite well. And then the classic things, if you design something new, it should be fast. And it should be easy to debug and easy to extend for, again, other languages, other language models. And we came up with the proto-BoF or protocol buffer definition that, yeah, in the very beginning, I was always referring to like 3N from database models, saying, okay, we have different types, different entities that refer via like cross-referencing, so that we can, change entities without necessarily invalidating cross-references. And with that in mind, and like really using protocol buffer as a way to represent individual entities and their cross-references, we came actually to a format that would satisfy this version control friendliness and also stability over time. So if you recompile, you don't want to have another format. If something moves in the code, even just line changes, you wouldn't want to have another representation if it has the same ABI. And we also try to keep output stable. So anything that is cross-referencing is based on the actual input. So if there's no change in name or offsets or anything, then the ID should be the same that you use for cross-referencing. Yeah, so we have some. We again use the graph structure to create stable IDs for cross-referencing. And last but not least, we version, because at some point we do design decisions that we regret and we change and we bump up the version. Here's an example for the code that we saw earlier. And you can see like this, like it's chopped up in entities. If you start from the right, there's an interface that has a symbol. The symbol, the ELF symbol, can you see my mouse actually? No. Oh, okay. On the top right, the ELF symbol has a type that it refers to, and then you can see the type is here, that has a definition with another member where it refers to another type, to a member, and members are also entities, and members have types, and they could be, for example, this one is defined here as another struct, has another type. So there's like the whole, you can smell the graph in this. I actually had a slide where there were arrows pointing from cross references, where it was a huge mess even for this little example. So I did not, but you can see where this comes from. And if you are changing a single thing, for example, a member, then you would see where only only the locations where actually it matters to change. We would change the format. So over time, we have very small changes. Yeah, and then when we had all this, we had the native format, we had the diff, we had more tooling. We actually had a tool that could do ABI extraction by just adding dwarf support. So at some point we came to the point that we could read BTF, we could read XML, we could read ELF and dwarf, and our STG format. We have some experiments with CTF as well, and I'm pretty sure it's not particularly more difficult than implementing it, for example, for like BTF, because they follow similar structure. Then we have ways of filtering symbols, and most importantly, when we look at how we use ABI monitoring, we often have multiple inputs for type information. For example, the kernel and some modules that have a combined ABI. So we need to incorporate type information that comes from a module or several modules and VM Linux itself. And again, we made use of the graph data structure that we have to effectively deduplicate and unify types, and also remove things that are in dwarf, but that we are not referring to. For example, think of a symbol filter that says there are 100,000 symbols in here. I'm only interested in one, but dwarf gives me all this type information, but I'm only interested in one is like what is referenced to. And by looking at the graph structure and just like holding that one symbol up, you can see how pruning is quite an effective operation on such a graph. And so we can do filtering quite quickly and create then exactly the size of and amount of type information in our native format. I jumped the gun with the dwarf reader. I don't know why these slides slipped, swapped. So at some point we could read the dwarf of a Clang compiled Linux kernel with ksymtop support and CRCs, which is mod versions in another instance, and support dwarf 4 and 5, and we are adding C++ and also GCC support incrementally. GCC is generally supported. There are some kinks here and there, similar to how Clang has some weird behavior of how it represents certain things in dwarf type information. Again, it's not meant for ABI monitoring; it's rather for debugging. So you have to deal with whatever we get. But the more later versions we see from GCC and Clang, they tend to agree more, and also the differences are often just in like naming types. You know, some compiler decide to encode the name as unsigned and some as unsigned int, and so we see this as a string difference. We try not to normalize, but we are thinking about doing that to actually have test cases that work across GCC and Clang. If you can say it's the same type. We do for all these combinations, we do type unification, normalization, and can do graph rewriting. Sure. Oh, yeah. Oh, sorry.
One of the things I ran into when I tried to do dwarf deduplication was that in different compilation units, different types can look different based on which types in that compilation unit are incomplete or not. So you can have struct foo with a pointer to struct bar, and if you included the header for struct bar, you'll get the full definition of struct bar. If you didn't include the header for struct bar, then you just have an incomplete type for it. Have you guys run into that? How did you deal with that?
I would say we have run into this discussion over a couple of months until we came to it's not easy. Like, what is, like, how do we deduplicate types? You know, we have forward declarations. Is this the same as the other one? Under C, where there's no ODR, in C++, it maybe works. Okay, same name, same type, but you know, we still want to be nice to users. Then we have just legitimately incomplete defined types. For example, in C++, there might be incomplete instantiated templates. We came up with solutions for that. I cannot claim that I know exactly the details, and I think I will be swimming on ice here a bit. But Giuliano is very much picking up on this right now, I'm pretty sure, and he'll put all the pointers in. That I was participating in the discussion, but I'm not as detailed on the solution as Giuliano could be.
Okay, I'm at least glad that you guys ran into it as well.
Yeah.
Question?
Matthias, do you want to say a couple of words about unification?
Oh yeah, please go ahead, Giuliano. That was the ooh.
Yeah, so this is the type unification that was briefly mentioned on the previous slide. Essentially, what we do is look for name types that have to be the same type according to some criteria. And then whenever in the graph we see a forward declaration and a full definition, we unify them and then essentially rewrite the graph so that the forward declaration is replaced with the full definition. But we only do it where we're forced to, and it's a recursive cycle-aware algorithm, which has its own complexities, and it's preceded by hashing similar, I think, to the sort of hashing that is done within libctf during its deduplication, so that we don't end up comparing every node with every other node. But yes, it's a very significant part of the solution to end up with smaller graphs at the end of the day.
Thanks, Giuliano. So
I'll make a note. I've asked our folks that participate in dwarf standardization, like dwarf 6, can we have some help deduplicating type information? Not only for C not having ODR, but also like LTO exacerbates this problem even worse.
So I will move a bit because in the interest of time, I might have a demo and I want to also make up some type. Yeah. So some of the things that we can do with such a graph are algorithms that we can just like put on top of them. For example, think of actually writing the native format as just a graph algorithm where you basically say here's your algorithm and here's how you handle certain nodes. Go and do your DFS to the graph and emit whatever is on the way. So by enabling almost arbitrary algorithms that just have to implement interfaces, we get like we suddenly get a lot of functionality. For example, writing native formats or rewriting graphs, or even just computing names that look like C out of type information. These kind of things are all encapsulated in like the SSC finder and components to actually apply algorithms to the entire graph cycle aware. This is a bit of a use case, but I try to run through a demo in a second. Some numbers of performance. We have the approach of consuming all the dwarf there is. As opposed to, for example, LibAbigail, where there's more incremental looking after the dice that are actually needed. That's kind of a trade-off decision we did. But we can currently, consume 18 million dice in like 18 seconds and produce 12 million SDG nodes. And then with deduplication and unification, we can actually reduce this to just 45,000 SDG nodes. And then when it comes to reading and writing, this all becomes like a sub-second operation when we think of actually SDG nodes, writing and reading. Quick demo. Okay, let's see how this works. So this is like technically you can follow along. So this is just like the project cloned from upstream. And going there, building it quickly so you can see that that's just like a CMake build, doing things. And yeah, in the end, we end up with like binaries like, SDG diff, SDG info, which is somewhat deprecated in SDG. For this demo itself, I will use a pre-build that is on my path, just to rely on it a bit. But what we recently also published that might be of interest for other people to inspect how SDG actually works is our test suite. The test suite is not yet in a shape that you can just say make test. We're working on that, but it's especially tricky if you have different compilers and we are not able to handle this properly. We know it works well for Clang to just compare expectations against what is there, but you can still see what, for example, is like how SDG files look for certain C files if you compile them with Clang. So, for example, here's a simple C file from the SCC. Here's a simple C file that is looking oddly familiar to what we already saw on the slides before. And if I, for example, just like compile that, simple, yeah, and then I go there and extract ABI. At some point, we might actually auto-detect the types. Okay, and then we print it. You can see this is just like directly the extraction, similar to what we saw earlier. And now we can see that this what we just created. Sorry, what did I do? Sorry, I just spilled it on the terminal. I can also put it in a file, and this is textually exactly the same as the one from the test suite. So I can do simple. That's a color scheme is not friendly to me, but I would just swap these two members here, for example, and I compile the whole thing again. I extract the representation, and now I can use SDG diff and compare this SDG file against the expected one that we just basically the same comparison. So if I'm not doing anything, it just gives me a return code. That's kind of intended, but sometimes misleading. But I can also completely spill it on the command line or on the file. And you can see here now, like this is quite messy, but it gives all the detailed information on how the change came into, like, how the change actually came along. But then we have the formats, one of them being the short format that literally just says exactly inline what happened here. Offsets changed for this particular member. And then there's the small that has a very similar output, but focuses on different things, saying here that the actual offset changed from that to that, taking a bit more into account. Now there's another, I still have some time. Okay.
Can you show the protobuf text diff?
From the diff? Or
Yeah.
There's no diff from the protobuf,
Well,
but there's just like
diff, right?
I can do the diff. Yeah, that's right. I can do the simple. Oh, sorry. Diff simple SDG against the expected simple. That's what you want, right?
Yeah.
You can see, like in this case, this member particular changed the offset value, and that also called because we could technically reuse members across entirely different data structures. The stable ID changed, and then the reference down in the actual struct union type also changed to just the members. But that's about it what changed here in this case. No, it's actually not coincidental. There's some seeding in there. Yeah. But maybe let's skip some part.
All right, probably got 2 minutes left for questions.
Okay.
Any questions from the audience?
While I'm doing this, I'm just like also processing VM Linux here.
So one thing that you said, you have a symbol filter, and this kind of
Mhm.
ties into what you were saying about opaque types. If I'm a user space library, I've got a whole bunch of opaque types that are my interface, right? If I'm libgl, the GL context is going to change its representation, but it's behind an opaque pointer that the consumer can never tell. Do you have a type filter for that as well? Could you say all objects of this type, I don't care about their changes, I don't care about anything downstream from them?
So when it comes to how compilers actually encode the type information from that, it really depends on whether the type information for that opaque pointer is actually available. So if you think of like foo star being your interface, and if it's forward declared, the compiler will likely not have any information about that.
Well, so
but if you look at the entire, for example, if you look at the entire kernel, and the compilation unit might omit that type information, you can actually recover it from somewhere else, and we are currently doing this. So the type information, if it's available at some point, we try to like feed it into that type. So even if the change is opaque, then it could be that this gets flagged as an ABI change. And this is intentional because we want to rather be conservative. But we have like recently explored like 3 approaches of how to actually filter this out. One of them is quite obvious to understand. If you say, okay, if it's defined in a header file, you include the type. If it's defined in a source file, like a C file, you don't include the type. That seems to be a quite effective way, because usually you would like fully specify the type in a header file,
right?
And the definition only that if it's private, and you want to keep it private in the source file. There are other ways of like discovering this. Like there are at least 2 more ways of being a bit more specific on understanding how opaque types can be still enriched with type information. But this is kind of what we're working on.
Would that be something a compiler attribute might help with? If I had a type attribute on the declaration that says this is intended to be an opaque type, could you please note it in the dwarf so that I can pick this up from my tools downstream?
Yes, I mean anything that helps to enrich dwarf or feed into something we can read from the binary, that's possible. Yeah. Get in touch with me, please. I like that idea.
All right, I think we're at time.
Mhm.
So round of applause, everyone. Thanks for
Okay. I have to disconnect myself. Let me quickly do that. Just.
Is this your phone? You can go ahead and introduce yourself. Yeah, sure.
Should I expand this?
They'll do that in the back of the room.
Yeah, sure.
I'll ask them to do that.
So I'm Sincere, and I'm working on speeding up kernel builds with automated header refactoring. So build times are held back significantly by lexing and parsing needless tokens. So when you import something that's unnecessary, you're slowing down your build time, and headers tend to grow over time. So this can become problematic very easily. So one of the goals we want to do is we want to make it easier to refactor headers, because for something like the Linux kernel that's moving fast, it's really painful to just remove a header. because someone else might write some code that depends on it. And there's also a lot of tooling that's missing, and we want to sort of fill in that gap. So if you see this is sort of a diagnosis of what's taking up the most time, right? You'll see most of the time is spent lexing and parsing. And there's a little bit of semantic analysis and code generation here, but most of the time is just dominated by the lexer and parser. And this is sort of an issue, right? So when we pre-process the files, they become hundreds of times larger. And that means we'll have millions of extra lines to parse, which is not really great. And it puts a lot of load on the lexer and parser, and it also like bleeds into the other parts of the compilation pipeline. And it leads to bigger compiler IR and a lot of other stuff. So the compiler front end doesn't like sufficiently address the pre-processing bloat. So we want to sort of prevent it from ever like reaching that stage by removing some headers or refactoring some headers. So the motivation for this is Ingo Molnar has been reworking the headers of the Linux kernel to build faster. And in some configurations for specific x86 builds, he's gone 50 to 80% improvements in build times, which is great. The problem is that the status of these commits are sort of up in the air, and it's unclear like how to automate this. So we want to step in and sort of help with that, and that's what this project is going to do, because we wanted to like, this is a one-off series of changes, and we want this to stop being a problem like permanently. So what are the additional benefits just beyond build times? There's also a reduction in times to bisect and a reduction in times to perform reductions, right? So the tool we're using is called Include What You Use. It's a tool traditionally used for C++, but we're using this on the kernel. So it can make indirect includes direct, and it can also remove dead includes. So because the Linux kernel is pretty large and organized, it's relatively easy to use it on the kernel. And there are some problems with Include What You Use, though. The problems lie in the fact that not all headers are not all headers work with all configurations, and the Include What You Use defaults are sort of like prohibitive, sort of like prevent us from using it out of the box for the Linux kernel. So we have to work around it. So some problems with Include What You Use, type defs like in 64T, they're commonly defined in standard int, and the Linux kernel doesn't have a standard int. So when we use Include What You Use, it recommends that we include a header that doesn't exist, and that's problematic. And the reason for that is that it has defaults, and these defaults can be changed. So that's something we need to do when using Include What You Use. So these are accelerator tables, and they just map commonly used symbols like in 64T to standard int.h. So we can actually fix this and make our own Include What You Use faster by mapping in 64T to types.h instead. And yeah, so beyond that, there's another problem where if you use a -i, which the kernel uses very frequently, it converts angle brackets to quotation marks, which is just a stylistic change that's not very good. So one of the problems we run into is ASM versus ASM generic. When we convert all includes, all indirect includes to direct includes, that means we pull in ASM generics. And generally, you can have ASM generic string 64T, which is like, it won't work with ARM, for example. So instead, what we can do is we can tell Include What You Use. If you're going to pull in this header, don't. Just pull in this secondary header instead. So if string pulls in string 64.t, we'll just say, just pull in string and stop at that. And this can be sort of done programmatically if we use kbuild or arch kbuild. And this is something we're still experimenting with. So another problem with include what you use is macros. Include what you use is notoriously pretty bad with macros. And it doesn't know when macros are called, so it sometimes just rips them out entirely. That's not great because the Linux kernel uses macros all the time. And another problem is sometimes the kernel declares duplicate headers. That is intentional, and it gets removed by include what you use. This is called an X macro. And dealing with these sort of requires some manual effort, but it can be assisted in one way, which is including include what you use pragmas. This is what is traditionally used. Maybe we don't want to use this in the kernel though, so that's we've come up with ways to avoid that. And another thing is token pasting identifiers makes analysis tricky. So how are we going to deal with the fact that it sometimes just rips out macros and it deduplicates headers? Well, just as they have inclusion tables, they also have symbol tables. So the purpose of the symbol table is to say, if you have this specific symbol, you're going to call this specific header. And this has made it so that whenever we see a macro, it doesn't rip it out entirely. And that's great because it allows us to sort of fix more files. Because if we didn't have this, we would sort of have to just skip over files that have macros because more often than not, they just get removed entirely. The problem with this is that it's slightly time consuming to create and they need to be kept in sync with the kernel version. For example, if you move something out of a symbol table or if you move something out of a header or have it multiple times, it could be problematic. So that is a concern with this. But some statistics, because we have run this and it has worked for the most part. So for string.o, for example, libstring.o, when we pre-process it without our header changes, it has 24,000 lines of code. And after pre-processing it, it has 5,000 lines of code.
Sorry, that's after running include what you use.
Oh yeah, after running include what you use and then pre-processing it, it has 78% less stuff. So before include what you use, build time is 0.36 seconds. After include what you use, it's 0.12 seconds. And this is like a very significant speed up. This is like a pretty large speed up compared to some other files. Some other files will cut down by smaller amounts, but this is still a significant speed up. And when using an automated include what you use script, what we found is it didn't change anything except for a warn on, which was it just said there was a warning on this line number. The line number just changed because there were fewer headers, so the line moved up. So our progress so far, these numbers are for a machine with 128 cores and an x86 def config. The def config all build takes roughly 72.3 seconds. After changes to around 220 files, we only looked at 300 and we managed to change to 20 automatically. We managed to get down to exactly 69 seconds. And there's 2,700 files. So we've looked at roughly 1/9 of it. So there's definitely a lot more of a speed up to be obtained. And this is also only for one configuration. So there's still a lot of stuff to remove. And overall, we've removed over 1 million lines of code from pre-processing. So another thing we've looked into is pre-compiled headers. So these can speed up build times and they're used pretty frequently in C++. And what we want to do is we want to use this on the most frequently included headers. So some candidates are compiler types.h, kconfig.h, and compiler version.h. These are used all the time, and these are forcibly injected into every translation unit using a -include if you analyze compile commands.json. So yeah, problem we run into sort of when including PCH, precompiled headers, is it's sensitive to the flags It's very sensitive to the flags, and there are often headers that are used in both the host utilities and the target machine. So what happens is you're going to have to delete the header or create two versions of the precompiled header, because once you create it once, you're going to have to recompile the host utilities, or you're going to have the next time you build, you're going to have to rebuild the host utilities. So that is a concern. So we're currently seeing if it's worth doing and what the potential speedups would be. And as for future research, we're trying to automatically break up headers, because before we were changing the include list of C files, which is good, and it can provide changes, and it has provided changes, but the origin of the issues are really in the headers. Let's imagine everything was in just one giant header. That would be pretty problematic, right? There's no way to change that easily with include what you use. So we can fix this with sort of static analysis, and sort of given an identifier, what are the uses, right? So what we have done is we can, for a specific header, we can construct a fully connected graph, and the weights in between two nodes would be how frequently they appear in the same file across configuration. And from this, we can use a graph partitioning algorithm. Here we used hierarchical agglomeration. So we can just essentially break the fully connected graph into two parts. Here you can see that most of the tokens that we put into the green side are integers. So this might suggest that we want to break up types.h into a standard int.h as well. And Nick can handle this.
Sure. Yeah, so there's some other things beyond just automated header refactoring around kind of trying to speed up the build further. So right now, Tanzir is doing research into seeing, like, can we apply include what you use to make indirect includes direct and dead includes removed? Can we use precompiled headers, either for frequently reused headers or headers that get included often? And then finally, how can we decide where to split headers? So from there, the additional things that we kind of need. So we have some tooling for LLVM that lets us, like, given a compiler IR file and a symbol that's usually a function, it will extract. So if you have compiler IR that's like a million lines of code, and you say, I just want this function definition, pull this out, please. It can pull out just that function definition for you. And then you can say, like, recursively pull out the definitions of the things it calls. We don't have anything like that for C, and that would be nice, because when I decide, like, we have some policy first of where we're going to make, like, split header. We don't have any tooling to say, like, given this .h file, create a second .h file for me and copy over the definition. Like that would be nice to try to automate some stuff. And then some other things going on. There's a lot of work going on right now in the K-build tree around mod post and improving build times, because that's a pretty large serialization step in the build. And so, for instance, there was like a commit within the latest release. I think that just got merged into 6.7, but it actually shaves minutes off of all yes config builds. I think there's more to be done there, because I still think it's single threaded, and I think maybe we can start to add some parallelism to mod post. I don't know. But really kind of the feedback we're looking from folks here at Plumbers today is, what else do we need to build? And so, like, a common thing that we've had as well is, or heard from kernel developers, is that we have some issues with some headers, or some types, I guess, where in order to reference the type properly, like, this header needs, like, 2 headers need to be included in a certain order, or vice versa, kind of thing. So we're kind of curious what other thoughts folks have, because I don't think this problem is very specific to the kernel, but in general, C doesn't have a whole lot of tooling for this. Maybe I'm unaware of something, though, but do folks have ideas?
So I build the perf tool a lot, and an obscure thing in the perf tool is that we have the include Linux stuff is copied into the tools directory, as is the UAPI stuff. But the Linux stuff comes first on the -i things before the UAPI one. So what that means is that Linux types.h has got priority over the UAPI types.h, which is kind of weird for a user mode program. And we run into all kinds of conflicts because, you know, you include like something from the Linux types.h, and then you include stdio.h, which somewhere down there gets into an ASM generic types.h. Why is everything called types.h? So we have core.c and types.h. We have two file names, and we'll use them everywhere. But yeah, it's. I feel like sometimes we're our own worst enemy, and kind of like by naming every file the same name, it's like, but why? But
Was there a request in there, Ian?
yeah, can we rename things and not call everything types.h?
Yeah, so I think like part of the issue with renaming stuff is just like you can be certain that at this point in time for my tree right now it builds, and then someone's pull request beats you to Linus where they depend on the thing that you just renamed, and oops, and that's going to be tricky no matter what for this problem.
So from my understanding here of include what you use, it's automatically telling you what to include and so on. I think one of the big problems I've looked at, because reviewing Ingo's thing that was mentioned before, is that we have a few places that are just super connected nodes like kernel.h and shed.h, just including tons, it has tons of fan out, fan in, and it's used everywhere, so there's tons of fan out. So having some tooling to analyze that fan in and fan out would be really helpful for saying, actually, this header gets included everywhere, or it's including everything, regardless of how you want to partition it. Knowing what that scaling factor is on either side gives you a good idea of if we cut that, what the benefit would be. So that would be really nice.
Yeah, so one of the things we did was, so we have hierarchical agglomeration. So basically what it does is it goes to a specific header and it checks basically what's the impact of each token, right? So if it's included everywhere, we're going to see that in this.
Sure, I'm just asking for a different granularity.
I can distinguish. So I think just expanding on Mark's point, so like this is taking a look at one.h file at a time and deciding like, okay, but Mark's question is, how do you identify which .h file do you look at first? And so Arnd has shown tooling where he's able to generate graphs of that fan in, fan out. And so I think that's something where we can look at to see how strongly connected is this node. Okay, now that we've identified which .h file we're going to start with, breaking up, then you move on to this, which decides how do I split it. And you basically this technique is using correlation between of all the symbols in the header, who's using them.
Sure, I guess from my perspective, I'm not sure this is that this is necessarily the level of detail we actually want to analyze this with, because you can certainly do analysis with this, but for most things, the fan out and the fan in, I think, are going to dominate. And also, like one of the big reasons we have unnecessary fan in and fan out is headers that mix like structure definitions and code, because that's the big problem with kernel.h and shed.h. Right, shed.h pulls in absolutely everything because it needs to put a bunch of structures in task struct. And while including all of those headers for those like struct that it's embedding, it also goes and pulls in function definitions. That ends up pulling in other files and so on. Whereas like if we have static, whereas if we had, for example, an idiom where we said when you have a foo types.h and a foo.h, and your foo types.h should have the bare minimum includes necessary to put this structure in something. Actually, I suspect that would have a big benefit, and I wouldn't necessarily get all the benefit of what Ingo has in his tree, but I suspect it would get a quite substantial portion of that quite easily. And then if we had the ability to analyze the fan in and fan out, it would make it much easier to say, we should definitely do that to this thing over here. And I suspect we get very close very quickly without having to go into this level of fine granularity. And therefore, that would be an easier thing to tell people to do.
Other points, Andrew?
Mainly as the thing is that the function declarations themselves are fine. It's the static inlines that have full code in them that are far more expensive. They're also the ones that tend to make it quite complicated to refactor headers because they're just regular bits of C. You've got to have the internals of the structures and all the functions done ahead of that. So even splitting static inlines out into somewhere else
would figuring out how to move those sideways again would make a lot of flexibility improvements.
Is forward declaration evil in this worldview?
I don't think so. I think there's an option to allow forward declaration and to not allow forward declaration. We've turned on the option that allows forward declaration because we don't want to like fundamentally change too many people's code. So yeah.
Guessing the previous talk on ABI analysis had a point on opaque types. Maybe they would frown upon it. Unclear yet. Haven't sent patches yet. So until we do and someone says, no, I don't like this, then we'll maybe be forced to have that discussion, but we haven't been forced to have that discussion quite yet, I think. Sure.
Is there any talk to adding any of these checks in mainline kernel? I mean, you don't necessarily need to add like your full tooling, but you know, something that maintainers or someone who's writing more code can say, oh, you know, there's some low-hanging fruit that we can take care of before pushing.
Yeah, so the end goal would be to have this maybe not in mainline or maybe even in mainline, but we want this to be a tool that not just us, but other developers can use to sort of analyze this and on their own and prevent any problems. Yeah.
Right.
Covered by something you said earlier, but in a few places we have like definitions in one header, and there are comments at the top saying, absolutely do not include this header, include this other header that wraps it.
Yeah.
Do we have the right annotations to be able to handle that with this tool?
Yeah, so they're basically the way we can deal with this. I ran into this a few times. So the way you can deal with this is using the inclusion tables and saying, if you're about to include this one, stop and include the other thing instead. That has worked for the most part. So we haven't run into that issue. Yeah.
Cool. Okay, if that's no more questions, I don't want to block hungry folks heading to lunch. So let's give Tanzira a round of applause. All right, thanks everyone. We'll be back here after lunch. Does anyone know what time that is precisely? 2:30. All right, we'll be back here at 2:30. Cool. Jump in. Yeah.
It might be actually also super fun to play with it.
Yeah. I mean, just even seeing this graph for the first time, I was like, that's looking a lot like stood in to me, you know, and then these are like kernel specific, whatever. But like, you know, very clearly you start to see like, you know, how should I split my header?
But are you actually splitting them?
No, this doesn't split yet. This tells you how to split.
Yeah, but you plan to split.
Yeah, we plan to split.
How do you plan to handle like those mid-file includes which are actually necessary to come from particular places?
Yeah, so we've seen that before, and
Yeah. I mean, I think like this, the C preprocessor is its own worst enemy, right? Of like, you know, you can pound to find something, and then the whole rest of the file is interpreted differently, right? And like that kind of stuff is going to be tricky.
Hey,
what's Oh yeah, so is that oh no, this splits into groups. So this is all.
They probably need to reparse the TV because they probably I changed it at like 8 o'clock this morning. What is the So they just need to reload the page. But
so these two are all every single time because it's 0 away. Is that what that means? Yeah. So like all of these, every single thing. So if I'm using unsigned chart, like I'm always using unsigned. Okay.
Because we are not here. There's
some level of granularity here.
So what is the place?
And why is there such a clear distinction between
Like unit factor, like these are some common practices. Or even, yeah, some of these are, yeah, like, oh, they're one-offs. But some of these are very.
How to interpret the tea leaves, we haven't fully thought through yet. It's more of like, get it to spit out the map, right? Because you're doing a correlation. Like, given this symbol and its users, how correlated is it with users of this symbol? And if they're highly correlated, they're gonna be close together. If you have, if there's no correlation or low correlation, they're gonna be far apart. So the reason are less correlated is because most of these are like, that's probably like also and even the Bulls conference, if you would just not really swim like that.
I think that sounds good. And then did you have to cut the test bed?
No, that's just like how many.
As far as.
Oh, no, but I think
you
got bigger ones.
So for text I, that's what the cap you can make. This is very, it almost looks like, oh, that's a header, so that's a header. Have you ran this on other files? I think that's the same.
Yeah. So this is.
The mid-fight so I'm little John Punk now at one because I want to go for the. You got fun? Oh, so they are not expecting for lunch at one? So I said, okay, so I'm missing John Hong at 1, but I want to be done with that at 1:30. So maybe we can meet at 1:30. Huh? Okay, so
After every step, there was like definitely balls.
When I'm working on Python projects, I don't know what else, like Pyrite or something, or MyPy, it'll get top unused header. And I'm not sure what the setup is for kernel development. I think I use plain D, and I don't think it tells me if I have that header. And I know a lot of kernel developers just raw dog Emacs with Vim. They don't have any tree set or anything that can static analyze their. So there's a good portion of this battle to be won just with like static analysis. Like this, Like, there might be just dead headers.
Yeah,
You don't even need to refactor them, just get rid of the dead ones.
Yeah, no, that's done automatically.
Yeah, yeah, exactly. Clean these about, it's probably a clean format hook that can automate that.
We should never
Like a pre-commit hook or a pre-check patch, whatever it is.
So we put a number.
Yes.
There's a lot of wins to it.
Yeah, so,
Trying to.
we use automatic power to and stuff, so that's not too much of a worry. So even if you don't want to accept any of the other changes, remove the dead zones.
So have you, I saw you went from 73 to about 69. That was with, is that with addition, like, refactoring indirect or direct headers?
Just repeat.
So my next follow-up question is, have you tried a strictly negative diff, where the next set is just pure negative, only removals? And then what sort of benefit do you get, and is it approaching the full benefit?
I have not.
So I bet there's a good percentage of just straight dead headers. That
Yeah, there might.
if I'm making a driver, I just copy and paste the template, and I have some dead headers already. So.
Yes, see, I suggested that as an option, but apparently certain.
Yeah, we were gonna talk to you about the same thing.
We wanna start watching our developers.
So the introduction for a year, and a number of million guests, and so on, so added shit. I know,
To remove the headers.
it's also wrong, and I appreciate that.
Run on your code base,
So, to be fair, I
on
think.
submitting patches that like.
Yeah, so we have, included use, we run it on whatever .c file or maybe .h file that we want to add a new fix, and then it suggests changes. And based on those changes, the testing, and then if they look good after a million tests, we'll submit them. That's generally how we do it. If you have code without a lot of configurations, you don't need to test it all that many times because you can just test it once. The reason we test it once is because some configurations.
You know, it hurts on that.
So something that we could potentially integrate into our like, CI workflow.
Yeah, that's something I think Google already has. Justin could probably tell you more.
So.
Yeah, we have like good static analysis tools like in our editors that will tell you this header is dead already, or perhaps there's a better header to be using here. But as far as like when we submit to source control, we also run some jobs that do more than just static analysis. It'll run a version of include what you use. I think it's called Clang headers or something. I think it's called Clang dash headers is what our binary is called. I'm not sure what the open source version would be called. But so there is some benefits we had just by doing pre and post commit hooks to refactor your headers as far as build times is concerned. But yeah, it depends how big code bases you're dealing with.
Yeah, I mean, often we'll have like, we have, you know, a few external modules, and we'll run an individual build on them, but it'd be good to, you know, statically analyze their modules.
My mind would be.
Yeah, even just the basic, like you can, you get to start documenting what's too conservative and just filling all the output needs to study.
In order to get at the.
It's also hard with dependencies. Currently include what uses and like shipped in tree or anything.
Yeah, so
so if you put it to check patch and then you have to tell them, hey, like, install this, build this.
Did you see that it's documented? So you can have like scripts
Whatever. So if the onus is on the developer to say, hey, clean up your headers before you put this in tree, like into mainline, you want to reduce hurdles. You don't want to say, install include what you use, configure it, and then run it, and then check it, and build test it, and all this. You want as much as you automate it so that you get adoption of the pipeline. So that's the hardest part. I think for the kernel, and this is something like 10 is dealing with, is like, there's all these great ideas and there's big wins here, but how are you gonna get people to actually take these wins and use them? You can't just split this header in half because type.h, there's a billion people using size t. What, you're gonna make that a new header, types 2.h, and then everyone has to include that, and then your patch is 10 million lines. It's like, it's impossible.
So when I saw it, like when I was Making this was.
Yeah, so
we're
we're-
put the types.h shell, nothing in it, and we had two headers inside.
Another thing I was thinking of is, do this at build, split the headers,
You actually.
and don't commit it to tree. So it's an ad hoc split. I mean,
Would that save any time in the
I don't
lexing
know
and
if I-
parsing
I don't-
directly?
You have you snoops on that.
yeah, so before you build, you split this into two. And you only use half.
But I guess how much work does it improve your build time to do that versus just doing it?
Hey, you nerds want to get lunch? No. All right, I got pizza already.
Yeah, we gotta
I
go
was
find-
Yeah.
Where you going? I don't know. Is pizza place 50 right now?
Never actually.
Yeah.
It's never unboxing. The other side is just live itself in the guest and do it. Then that's when you buy them.
So one other thing I was supposed to do is, the cookies thing, well, I'm pretty sure there are a lot of number of lines, so you can register something, and there's never a corresponding unregistered one. Yes.
That's the soft reset, and that is all you have. And so that's another cluster function. Soft reset is an even bigger cluster bug because on one type of guest, it resets within the same DOM ID, and in others, it changes to a new DOM ID. Because PV and HVM are completely different. Yeah, the problem is when how you repeat it is don't remember what happened. If you sub-reset a PV guest, it should. Yes. Should we, yes, head in a lunch with direction. But yes, so there genuinely aren't cases. There genuinely aren't ways of doing that. Again, because
Esta placa, digo.
Oh, we got you now.
Check, check, check. One. Check, check, check. Two. Check, check, check in bank. Check, check, check. Cool. All right. One last check for all mankind. We sound good. Got to turn you down a lot. All right. Way better. Way better. Check 3, 4, 5, 6, 7, 8, 9, 10. Go. Oh.
Put this up here. All right, cool.
Can you unmute channel 1? Check, 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 check. That sounded absolutely painful. Good afternoon, ladies and gentlemen. Welcome to a very quick sound check that'll probably take about 10 seconds. I just want to make sure that I sound good. I love my voice. Thanks for listening. You rock. Y'all have fun out here.
John, how are you doing?
Okay, Jose, how about you?
Good. Round two of compiling for verifying targets.
Yeah.
It will be a little bit repetitive for you, I'm afraid, but
Well, I was assuming you solved the whole problem in the last one.
which problem?
Compiling for verifying.
Yeah, it's done.
Yeah, exactly.
It's done, yeah. But the source level annotations, I updated it.
Okay.
With the new idea. That only for that the LWB article was useful.
Oh, well, good.
Yeah. Wow. Is the BBB still up?
Is what so?
The big blue button.
Yeah, yeah.
Okay.
Yeah, we're all back here.
Cool. Yeah. I think it's used for many different things. I guess written packets, like deciding what packets should pass or not, or where it should go or not. And there are other subsystems that are actually used.
Okay.
Or wanted to use.
But right now, there's no high-level language for it.
High-level language?
Yeah.
Yeah, you can use C or.
You see to write
Yeah.
for the
Yeah.
BPF. But as you mentioned, there's some special rules.
Oh, yeah, many.
But that.
You will see now.
Oh.
Yeah.
But that rules is not in the language.
It's not, they are not, or not yet.
Not yet. They're only in the verifier.
Right.
So the verifier will apply additional rule to verify the C language.
Not the C language, the verifier verifies the compiler.
That's an assembly.
Which is assembly.
The assembly. Oh, it's
No,
verified in the assembly level.
That's the difficulty.
Oh, okay. Then you don't know, when you write the C code, you don't know.
If it's gonna be verifiable,
Ah.
so they are provided.
So you are trying to
You just
do
follow me.
the
We
rule
need
back.
to know distance, so not to make the whole thing practical.
Yes,
Like
yeah,
in real life.
Hey, hi. Maybe I should go, I have like an extra battery that was like for my laptop, I wanted to forget it. There's no power there, is there?
But I'm like all over there.
Yeah, well, that makes sense.
There is another one there.
Yeah. It was funny that we didn't have no outlets here.
Mm.
Usually they got outlets, right?
Yeah.
Oh, I think that was 3 minutes before we started.
How long is your car for?
How many years is
Actually,
The current form, like, how old is BPF in its current actually form? The eBPF, it's well, like 6 years ago, like around.
Yeah.
You didn't watch the movie?
Oh,
No,
I heard about that.
I purposely, I have not watched that movie, no.
I actually made myself sit through it.
You did?
I did. I mean, if you want to know that, it's maybe just a bit more than 6 years now.
Okay.
But no, you don't need to watch it.
No, I have no intention to do so. Because I watched the trailer. Someone sent it to me.
That's probably really neat to see, yeah. Unless you're really, really into the personalities involved and want more of them.
I have that pleasure from time to time in several conferences every year.
Mhm.
I don't think I need rehearsals. I don't know, things we should not be talking about. Because you never know when those things are.
Yeah, nobody's recording this, right?
So,
So
it's
let's,
supposed to start at 2:30, right?
Yeah.
I think this is speaker's not even here. Oh, you're speaking the next one?
John Hong and myself.
Oh, we're not moved, oh, wait, the one that, the session I'm not in, oh, that's right, we're at the end of the session.
No, you are moved, yeah.
Yeah, we're moved to the very end of the session.
Yeah.
Okay, I was worried about.
Okay, so should I not be seeing the BBB instance here?
Oh, wait, what's that? Here you should be seeing, oh.
Yeah.
it's not logged in?
No.
Oh, wait, you have to,
There's a
okay,
second
there's
session.
there's a second
I
session.
just
Shut it down,
joined.
Shut it down, so we are tool chains, so, oh, they haven't started it yet.
No,
Wait, no,
there's
we
a
have to
second-
refresh it.
There's a second session.
You have to
we
refresh
go
it, there we go.
get this thing.
No, you just had to
So they
refresh
shut
it.
it down and now
Yes,
they are-
and what didn't show join thing, you had to refresh. Yes, whoops, I joined the wrong one.
No.
No, wait, did I?
It's right.
Okay, I thought I saw, oh. I know, I'm the one that's running the show here. Yes. It should be,
Slides.
Wait, are you sure I opened it, clicked on the right one? Wait.
The slides are not there.
Oh, no, because we canceled the session, so you have to
Okay, yeah,
upload it.
I'll
for the
get
second
them
session.
uploaded.
Yep. Oh, wait, let me cancel because you won't be able to get in it. Okay.
You got them all? I have them, but Steve, I'm not the manager of the room, so I can't.
Oh,
I can't
like-
take presenter.
Oh, you're not a moderator? So let me make you moderator again. Why do I not see you? All right.
I don't know if that's possible. but-
Are you moderator now? You should be able to do it, right?
Yes.
So,
I don't know.
what's it called? I talked to James about it, and he says he knows for a fact that you registered as like a non-speaker.
Oh, yeah, that's probably.
And that's
Because I bought a
why,
ticket immediately.
right, and you registered as a non-speaker, so that's why you never, they use the speaker code to figure out who gets moderator.
What are the presents, Steve?
Was that?
What are the speaker presents?
Oh, okay. Okay, then. Well. And I'm the one that actually picked it because I have.
Wrong slides.
Yeah, sorry. I got this from the P99 conference. I loved it so much.
Yeah.
I'm like, plumbers need
I wasn't
this.
listening.
So I pushed
Yeah, this
hard
one is
for plumbers here.
correct.
So
I think they created two instances of challenge.
I think
for the board.
you're getting one, right?
Yeah.
Yes, from speaking side, right?
Okay.
I haven't gotten one yet.
And so if you just take back presenter now,
By the way, just want to know, did you guys give the cups to all your speakers, or they should?
No.
So a lot of the every speaker should get a cup, and if they don't have it, we have to go talk to talk to me.
Oh, I thought they would have gotten it in.
Yes, but for some reason, some people aren't marked as speakers.
Oh, okay.
We had a lot of instances of speakers not being marked as speakers. They're only giving it to speakers. So if they're not marked as a speaker, they won't get one.
Okay, so
Yeah, we might have to fix that. Okay.
Yes, yes.
yeah.
Anything else we're waiting for?
I think we're good to get started. Yeah, take it away.
Okay, let's get started. And my name is Yahan, and actually I'm from the BPF community. And but I also maintain the BPF backend in LLVM.
You gotta close that microphone or.
Okay, is this better?
Yeah.
Yeah.
Okay, great. So try to repeat again. And this is Yang and working on the BPF and mostly the BPF LLVM part. And so I'm also a BPF backend maintainers for LLVM side. And so I will give some kind of like verifier issues and specific with LLVM and also some of the work we are doing. So let's go to the next one. And first, let me briefly explain the workflow and from the BPF program and to the eventually BPF program run in the kernel. And typically BPF program is written in C, and although you can written in assembly code and a different way to write, but C is the most popular one. And currently both GCC and Clang is able to generate an object file. And although Clang probably is widely used at this moment. And once you get an object file, and there's a library called libbpf, and which do some processing and do some relocation resolution and pack some kind of like an instruction stream together if you have a sub-function calls. And then you get a program and with some additional information. This program will load it into kernel, and then the next step inside the kernel will be verification. That's a crucial part of the BPF ecosystem. And the verification has to succeed, and before you actually can JIT and run. JIT means just-in-time compilation. You translate the BPF program in BPF instruction and to the native instructions. And so the main goal of verification is two folds. And the first is the program eventually will end. Well, this end is a quotation mark because verification has its limit. And for example, current maximum verification, the number of instructions verification try to verify is 1 million. If you have a huge loop, and it probably won't work. And even it eventually end, still verification will fail. In that particular case, the suggest is you try to have function calls, and this offload some of the verification work to a different function. And the second goal is the program should not cause a kernel crash. And so there's a lot of safety verification and in the verifier. So this slide shows a little bit more information about kernel verification. And the first, it is flow or path sensitive. So every possible path is explored and to ensure program is safe. And so basically we try every path come to the exit. You have to be safe. And a few other techniques in verifier. And first we try to maintain the register and the stack states and during the path exploration. And because it could be tons of passes, so pruning is a crucial technique and to speed up verification. So if a pass and at a particular checkpoint has been explored, and that means it is safe, and later on you come to the same checkpoint, you find okay, and the previous pass already done this, and you can skip that. So this is a crucial technique and try to speed up. And also simple liveness analysis. And so if you have a write and later on you don't have read, there's some special processing in verifier. And also sometimes you need a precise range for scalars. and because different scalar and may have impact on the path you explore. For example, for conditional instructions, and you need a precise scalar, so it may in different cases and go to different branch. And so the register and states actually the scalar numbers is represented by the T-number. It's a tertiary number, basically the 3 states. And this is a trade-off and the kernel people made in the very beginning of verifier. And you try to represent numbers in reasonable preciseness. And it is not as good as a list of ranges, but is good enough. And complete formal verification is known to be a NP complete. So we cannot do that in verifier, and it's just not possible. So what we actually want to do is a fast verification time, and especially in some cases it's crucial. And for example, you have a DDoS, right? And kind of like attack, and you find new patterns, you want to replace it, and the verification time program has to be verified before load. So you want to really short verification time, and so your program can load, can fight against the DDoS. And also we want to control the verifier complexity, because currently verifier already very complex, more than 10,000 lines of code. And it's very hard, and only a few people like Alexei and some other people can understand. And so to fulfill these 2 needs, and fast verification time and the reasonable complexity, verifier will not be able to maintain too much information. And so we try to have reasonable information like register stack slots, liveness, and sometimes we maintain some kind of like a register equivalence. And so the goal is to try to have a faster verification and correct verification, but sometimes this indeed may cause a verification failure. So people have different ways, and including users and the kernel community, and try to prevent verification failures in their code. So there's typically 2 ways to do that. The first is let the compiler do the work, and the compiler hopefully will generate a verifier-friendly code, and by checking certain patterns, and which is not accepted by verifier. And the second is modify the source code, and some source code, and if you understand the verifier failure log, you identify particular places, and you can play with that with some assembly code and force ordering, and or use inline assembly and try to emulate the functionality you try to achieve. And in this case, you can also pass a verification. And but from the community perspective, and we really want to actually, and the source code can be changed by, basically optimization can be done by the compiler. So we minimize the user's overhead, try to scrutinize what's going on, and try to hack through. So in the next few slides, I will give a few examples, and real examples happens, and in the verification process, and it fails, and how we resolve that, and will give you an idea and what kind of problem we try to attacking. And in this particular case, and it is simple, and you have 2 conditions, and you try to say, okay, if less than 4 or greater than 12, return 0, otherwise you do something. And but you can see there's a 2 conditional here, but the verifier, but the compiler is so smart, and it actually generate code with 1 condition. And for example, it say -3, and compare it to FF some 7, and then you go to next. And in this particular case, you can see initially the assignment temp equals ID, And the compiler then has some temp operations. And after the comparison temp less than this one, you get a narrow temp range. But later on, and ID is used. But from a verifier perspective, ID is still the original ID. It's a unknown number. The range is from minus infinity to basically minus range and to the maximum range. And in this particular case, verification will failure because V plus ID, the ID offset could be huge, and the verifier doesn't like it. So this is the case, and we already fixed it in the compiler side to work around this issue. And another use case is for old kernels. And sometimes we improve the verifier because, well, somebody discovered a problem and or we ourselves found the problem and with the new introduction of BPF program itself. And in such cases, we are able to fix the issue or improve the verifier with the latest kernel. But it will be not easy actually to backport because the verifier changed a lot. And in this particular case, we want to patch LLVM. And so the older kernel can still use newer LLVM and try to work around the issue. And this is an example, and we fixed at the LLVM side. And so see in this case, you have I equal to a constant and I equals to a register, basically unknown, and you do a bunch of things. And compiler transform to this register and this constant and use this constant as an offset. But this offset is still a variable. So in some cases, in older kernels, this offset, the upper, and is considered just an arbitrary number. And because some limitations in the verifier. So for older kernels, and this will not work because this transformation and verification will fail. And so we have to patch the LLVM so people can use a little bit of older LLVM and try to compile for the kernels. This is the second use case. And the third one actually it related to the manual source code to do the work. And in verifier, and we don't really like two value all, and this two value both are pointers. But this actually is possible. And in this particular case, and original code is like a walk is a pointer or func, and the LLVM happily generate all operation for these two pointers, but verifier will fail. In this case, and although we could actually do that in the LLVM as well, but we somehow didn't do that. And we just work around the issue with a barrier variable. Barrier variable is an assembly code, which is just read, write, walk, but actually didn't do anything. Eventually, it will be a no-op. It prevents this optimization. There's quite some cases in self-test and try to use the barrier variable or assembly code. And I think if any people interested can look at to see whether can help and improve the compiler. Okay, I think this how to generate a verifier friendly code, and well, we all like it, and the LLVM community could do that. And the current approach is we have several backend passes. The backend passes and try to generate a basically verify friendly code. Essentially, by similar idea is barrier variable. It just put different intrinsics. It's intrinsics, and basically it act as a gate and prevent a certain optimization. And so this is the current use, but we are not really happy with this because this is something we try to either modify and IR and try to prevent certain optimization, or we try to undo some optimization. For example, existing paths, they do some optimization, we don't like it, and it causes verification failure, we have to undo that. So we provide an alternative approach, and basically is TTI hooks, a list of TTI hooks, and it try to disable certain really specific, not passes, but some transformation inside a particular pass, and which are performed by the middle end optimization. And all these passes mostly including some passes in instruction combine, and also in the simplified CFG. And but this approach actually is rejected by the upstream, and upstream actually prefer the legalization, IR legalization, the similar as we try to insert a bunch of built-ins and in the IR, and try to enforce certain concept like ordering. And another approach actually is try to provide an option, and this option can provide a separator of optimization passes, and also allow this optimization pass try to customize and to generate a BPF friendly code. Essentially, you provide this option, and this option available, and for this pass we have this option, and then we could do a little bit of tailoring, like okay, this is verifiable, this is not verifiable, and for different targets they have different meanings. So we could do that, I think. And how to do that, and this is only an idea at this point, there's no implementation yet. Yeah, this is all the slides from my side. And any questions, or Jose will do the next.
For the passes, the pass pipeline, are you trying to use? Sorry. Oh, the speaker. Yeah. For the passes, are you trying to just use Clang as the driver and not use opt? Because if you use opt command line utility, you have very fine-grained control over. You can explicitly list what passes you do want to run or not want to run, and in what order or not. So opt, the command line utility opt, that's part of LLVM. If you use that, you can say Clang, you have it emit LLVM IR, but then you use opt to fine tailor what passes of LLVM you want to run or not run.
I know there's a pass, but I'm not familiar with ops, so maybe we can discuss it later.
Yeah.
Okay.
Cool.
Sounds good.
This won't work. It's not a pass. You cannot disable it. Like, does not do. Like, what we're trying to do there is like add another flag, and then we gain the flag. So it's not a pass. It's not something that you can do either with opt or with like manually creating the passes. One of the options we considered is to have like our own set of just enable the passes that we know will work. But this is much farther. It's like breaking down into like inner bits of one particular pass. So it's not the pass itself.
So there's another thing called opt in LLVM, a class for command line options, and a lot of passes will have flags to custom tailor the pass itself.
There's no flag.
But you can add them.
We actually try to add a hook, which is similar to flag. And we initially proposed the flag, actually, add a flag, and so backend can override, is a global variable, we can override, that is rejected, and then we go to the TTI hook and also reject it.
But it was like the global flag, it was a CL opt, or no?
Yes, it is a CL. It's a global variable, but it's a CL, yes.
Yeah.
So there's some pushback on it.
All options were rejected.
I have two questions. Question number one, you do all the fixes in the LLVM toolchain and as a case-by-case base, basically, right? It's basically just another heuristic on top of another heuristic, right?
Something like that. Yeah.
So which basically becomes arm race, right? It's the verifier changes and you have to react, right? The second question I have, which LLVM versions do you have all these patches in?
Always the latest.
So it's an ongoing battle, that's what you're basically saying.
Yeah, I didn't specify and for this particular one, and actually you can dig out.
Well, yeah, there are alternative approaches to that. Basically, you can take a look at the verifier code and you can generate a proof either in Isabelle or in the COC. And then you can generate the BPF program code based on those proofs. Right.
Yes,
It's more complex, but it's a little bit more scalable, right?
Yes, that's from BPF side to the LLVM side. Yes, that's true. But actually, we are doing.
So just to clarify, so it's not a race against the verifier; it's race against the LLVM.
Well, all the peculiarities you have to deal with are inside the verifier, right?
No, in this case, it's LLVM. That's LLVM changes that we all constantly have to fight with. LLVM changes, LLVM adds another optimization, and then we have to react on the LLVM side and verifier side. It's not the other way around.
BPF program code is very simple. Majority of the optimization passes and
Not,
around it, right?
not really.
That's what we did.
Not really.
Not really.
Programs are 1,000 lines of code.
Yeah, but the stack size is tiny, right?
So-
most of the code is inline.
No, it's not aligned at all.
Majority of it should be inline, otherwise you'll
No,
be fast.
you're talking about state of BPF that was 10 years ago. Now it's not. Now it's not always aligned.
That's not what we see.
Okay.
I'm curious on how did you decide the list of the transformation that should be disabled from the verifier?
From the
How do you-
actual BPM program, it's go backward from BPM program. We found that which one was a problem. We go
Oh,
backwards.
okay.
It's not. We can imagine this is no go backwards.
Okay. So then that list might be changed later
Yeah,
if you
could
found
be,
more.
Yeah. I
Oh,
don't know. It could be. That's a thing I discussed with Hossein. Just a single option and there, and then during the LLVM changes, and we can actually change internal and which one to disable, which one not disable. So we
Okay.
don't really explicitly specify at the content.
so the list for GCC and for LLVM are same?
No.
No?
It will be different because the optimization are different.
Okay. But the verifier are the same, right?
Verifier is-
Verifier are the
well,
same.
Verifier could be the same, and there's another verifier called Prevail, and by Microsoft currently using, which is more problematic because they do not use a path sensitive. They use this loop summary, and they have more verification failures. So not sure how to address that yet.
So the verifier rule, is there some definitely rule, right, in the verifier? No?
It is in the kernel, to look at the kernel code. There's some rules, but
But the rules are fixed or it's still changing?
evolving is evolving. The kernel version to kernel version are evolving.
Oh, okay. Even the verifier are changing
Yes.
from kernel to different kernel version. The verifier rule are changing. They add different.
Possibly.
Okay.
We will try not to have a backward break. Previous verifier successful, we try to be successful again.
Okay.
But verifier changes.
And another question is whether it's possible to, if the verifier, we have a list of the rule, it's possible to make the rule in a higher level language than the user, when they write the C code, they know what kind of code is
Verifier
good.
rule is based on you can consider mostly based on the
Assembly.
The state. Low level.
Then when verifier failed, the user, it's very difficult for the user to change their code. So that's a gap. There's a gap, right?
Some advanced user can do that. Some user will seek help in the mailing list.
Is it possible to make the lower level verifier rule become higher level language rule?
This is the problem at hand, right?
Good question. And probably very hard to do that.
Okay.
We should go on because otherwise, it's not because it's my part, but.
Okay, yeah.
Cool. How can I
Let's see. So
You say hit plus, and yeah. You know what the file name was? It was called verified. Those people.
Maybe I don't have that one.
We had to re-upload all the presentations.
Remind me again, did you email it to me or did you?
Yeah,
post it?
email to you, yeah.
I think you sent me Yonghang's. I don't know that you sent me yours. I just sent you yours. Sorry.
Are you logged
There you
into your
go.
laptop
Yep.
too, or, because you could upload it right from your laptop.
No, yeah, we got it.
Yep. Sorry, I'm just posting it now. Verified. Uploading them. Cool. And
Yeah.
then you just hit the plus and take presenter back. It should work. Sorry about that.
Okay, so this is gonna have to be very, very fast. So it's gonna be fun. So for some people, this may seem like a little bit repetitive because I did something very similar in the GNU Tools Control conference to get, like the GNU Toolchain people and maintainers, the other maintainers of GCC, like on board with all this. So anyway, so Yonghong, he expressed it very well. In theory, this whole problem is not solvable, but in practice, it works. So the thing is, from the tools perspective, we need to make compiled BPF practical, and we need to make it, as easy as possible for people to actually write BPF programs in high-level languages like C, and actually to compile those high-level programs into low-level BPF, like BPF assembly. And we should make the experience as normal as possible, like when you write C programs for other architectures, to the extent that it is possible. So in GCC in particular, the BPF support in GCC and the GNU toolchain, we've been working for a few years in it. And the first goal, which is the number one there, was to sort of achieve parity, in terms of functionality with Clang, because Clang was like the native, the first optimizing compiler supporting BPF target. And then that involves to compile all the BPF kernel BPF self-tests. We are there at the moment. We managed finally. There are one or two here which are giving us some problems, but because they rely on some particular LVM optimizations, but that's something that can be fixed. And then the next step is to actually run the BPF self-tests. And basically, we have two goals. First is to compile and run all actually existing BPF programs. And this is important because, again, to compile and run all potentially existing BPF program, it's going to be complicated, but at least the ones which are actually existing and used and developed, then we should support them. Okay. So I'm not going to repeat what Yonghong said already. There are several verifiers. This is, like the development cycle. You write your BPF program in C, you compile it to BPF assembly code, you get an object, you put it in the kernel, you load it in, it gets verified, it gets executed, or it gets rejected, and you get, some error messages. So, toolchain-wise, so compiler-wise, basically the challenges that at least on the GNU side, on GCC, we are facing is basically, the first one is that BPF as an architecture is peculiar. It's peculiar, it's very peculiar. And that imposes some problems, but those are not interested here. The second one are the big ones, which is that you need to be able to, from an optimizing compiler, you need to be able to generate code that can be verified by some existing verifier, like the kernel verifier. That's the big deal here. And the last one is also important, which is we need to be able that this whole process is not, for it to not drive people nuts, basically. So you have a C program, you compile it to BPF, you try to verify it, you get an error from the verifier, but as Chink pointed out already, the verifier, what it sees is the BPF code at the assembly level, and there is a gap because you are writing your program in C. So it's not that trivial or immediate to actually go up the gap, right? So, okay, what does this mean? So those assembly instructions, what source level construct refer to? So, as far as we see it, I mean, there are two sources of unverifiability, right? The first one is some source constructs in C, for example, are inherently not verifiable. Like, for example, a jump table, an indirect jump, right? I mean, an indirect jump, how can you actually verify or how can you predict where the jump is going? So it's when the compiler finds something like that, ideally, it should error out. If you tell the compiler that you want to generate verifiable code at compile time. The second one is that even though in your C program, because you are a BPF programmer, right? So you are writing a C program that you know you are going to compile to BPF, so you are careful to not have computed quotas in it, for example, right? But still, from a completely legal C program, which at face value is totally and completely verifiable, an optimizing compiler can very well actually do some transformation that leads to code that is not verifiable. And then your program will not actually pass the verifier. So those are the two main sources of not verifiability involved here. So then what we did in Cauldron was to discuss with the other GCC hackers and maintainers several approaches on how to tackle this. The first one is the approach 0, which is do nothing. Ignore the problem. So that is what GCC implements now, the BPF port in GCC. And well, I mean, we generate BPF code in the backend. It sort of works for many use cases. For example, for the dtrace runtime support routines, it works, even though they had to actually overcome some stuff from the C part. It works maybe well enough. But it's not, we know it's not good, it's not enough, because most of the kernel BPF self-tests will not work with this. We need something else. The other approach is something that it was also mentioned here, which is, okay, if the optimizing compiler, this is for the second sort of problems here, which is the compiler generating not verifiable code from verifiable logic in your industry program, is disable everything, disable all of the optimizations. Well, this has problems. This is not going to work in practice. First, it has an impact on performance, on the program size, which actually is limited, maybe not as limited as it used to be, but it is still limited. I think the verifier itself, it has a limit on the number of instructions that it can verify, right, as well. So the verifier itself is bounded. And also, even if this worked, it will be only a solution for the second kind of source of not verifiability that we saw. Because the source constructs that are not verifiable by itself intrinsically, they will remain there. And actually existing BPF programs, they require to be optimized. This is not correct, the -02, it should treat -01, but I think that it's recommended, you recommend for it to use -02 anyway in practice. So this will be the first approach, no optimizations. The second approach will be disable only the optimizations that we know lead to not verifiable code. Okay, there are two issues here. First, and John Honk already mentioned, what leads to unverifiable code is not actually whole optimization passes, but only certain transformations that certain optimizations passes produce, right? And also, in my opinion, this should be automatic to actually be practical for a day-to-day operation. Why? Because people tend to think about compilers, optimizing compilers, like modern ones, big ones, like, okay, you have a linear set of optimizations that happen, of passes that happen one after another. That's not the case. I mean, it's a mess. If you open in GCC the definition file that describes the different passes, and there are hundreds of them, it's not as simple as that, right? So basically, even if you could specify manually what particular optimizations you want to disable or inhibit, I would personally don't know how to do it. Right? And also, one optimization can have an effect on the next one. So it's not just I disable this optimization to avoid this transformation, and it will not happen, because this might have an effect on some pass that happens afterwards, and actually removing that you know it leads to not verifiable code could actually make another pass to actually generate a not verifiable code, right? So, and the granularity is bad. Actually, the last question is that can GCC actually try a pass? Well, that is the how to make it automatic. We will need to get the verifier, extract some rules from it, like the set of constraints that it checks for, one particular version of the verifier, and then somehow express it in the corresponding compiler internal representation contract, how to say. This is, I call it legalization in LVM, I think. I don't know. In GCC, it will be like in RTL, like every time an optimization runs, you get the output of the optimization, and then you check those constraints and...
Oh, yeah, verification. Yeah.
Yeah. Okay. Fast. The next, the other approach could be like what I call counter passes or anti-passes, which is that, okay, we know that this optimization pass is doing some certain transformation that it's making, is producing, is ending producing not verifiable code. So I will intercalate an additional pass after that one to undo some of the transformations of the previous pass. And this is something that the Clang, the LLVM BPF target does at the moment. It works. But well, it has better granularity because you don't need to undo the whole pass. You just need to undo whatever particular transformation was hurting you. Another huge advantage it has is that it's pretty neutral. You don't have to even to talk with the, I don't know, middle end maintainers, or the maintainers, of other optimization passes. You can do it all of it in your backend. So it's a very peaceful approach, right? So to say. The problem is that it is fragile. It is fragile because if some optimization pass changes, doing something completely, totally legal from a semantics point of view or semantics point of view, it can break because you have to modify your counter pass to adapt to that change. Another approach is, instead of trying to undo previous transformations, you can try to actually somehow hook from the target, so from the target for the particular target for the BPF backend or whatever compiler, to hook into the existing generic optimization passes. This also been used by Clang, which is what John Hong mentioned, right? It's called TTI hooks. But the problem with this is that now you are stepping over the feet of the other maintainers. And this can be polemic because traditionally in optimizing compilers, we are with the concept of what is a legal transformation. A legal transformation is that you don't break semantics of what you are optimizing. But as someone in Calder, I think it was Florian, he mentioned, okay, well, this is like adding like an additional dimension to the whole compilation process because you have the dimension of program correctness from a semantic point of view, but now we are adding another dimension, which is like predictability or verifiability, right? And I understand, and actually with the other GCC maintainers, I could prove. I mean, It's true. Sometimes it's difficult to explain to some compiler maintainer that, look, your pass is legally correct, it's legally sound from a semantic point of view, but I want to hook into it to change something because I want the result to be predictable or verifiable. So this is not that, I mean, this can be like, this requires talking, basically. And then there could be another approach, which will be generic pass tailoring. So this is not about the BPF backend hooking into generic passes to make them do, you know, like what we want them to do. No, this is like having a new option called -O predictable or verifiable or whatever, that it will work in the same spirit, in the same way that -O small or -O fast. What are those things? Those are hints for the compiler. So when you use -O2, -O3, or -F, whatever, you are specifically saying, I want those optimizations to be activated or not. When you use -O small or -O fast, you are not specifying any particular fixed set of optimizations, but you are saying to the compiler, when you are processing and transforming the program and optimizing, if you have to choose between speed and size, give more weight to either speed or to size. And then you are, indirectly, in a generic way, you are impacting the way that the compiler is doing the transformations, right? Okay. So the idea is to add a new one, which is verifiable, which is telling the compiler, which is the same, is telling the different optimization passes which are generic, is if at some point you have in the balance performance, well, actually it will be like a 3 balance, right? So you have performance, you have size, and verifiability. So give more weight to verifiability. One example that I was talking with John Hong before today. If you pass to the compiler -O verifiable, and the compiler is generating code for a switch statement, for example, the compiler will not generate a computed goto or a jump table, because it will know that that's not verifiable. So instead of that, it will generate a less efficient and a less compact, probably sequence of jumps, right? Of conditional jumps, but no longer indirect jumps that cannot be predicted at all. So that's, you know, this is. And the language level support, actually, when I did this in Cauldron, I was totally wrong, because I was like, okay, let's put annotations in the source code that the verifier can use conveying to it. But actually, John pointed out, no, that's not going to work. So basically, this could be like, you must know pragmas and optimize or fail pragmas. The first ones will be something like this. It's like pragma loop must bound to this particular bound. And what you are telling the compiler is, if you cannot infer by yourself at this particular point that this loop is bounded like that, error, compile time error. How will this work? Well, this will not guarantee you that the compiler is going to generate code that some verifier is going to be able to verify those bounds. But at least you can say, okay, well, if the compiler, knowing everything it knows, it's able to know to infer those bounds statically at compile time, then there is some chance that a verifier is going to be able to do the same thing afterwards.
Thanks. I'm just curious, would it be possible to add a variable in that? So it's basically, if you had a loop that was dependent on another variable, and you say, like, say if a variable was like allocate this much, so you want to make sure it stays within that, or like if an array, you had a dynamic array that was allocated by some space, and then you had a loop over it, and you just you just want to make sure the loop doesn't go outside the bounds of the array or whatever that you passed, so you knew that some variable was. Could you do like I don't know if compilers could do this. Could you actually have, like, you know, bound from 0 instead of 64, 0 ... y?
Well,
or something.
Yes, and actually it will not change. I mean, yeah. because I mean, the thing is, if the compiler do some tracking, it has, you know, some variable tracking, variable tracking, for example. There is a pass that does that.
Okay.
And if the compiler could statically use that to determine the bounds.
Because that way you at least might be able to, if that's a possibility, you could get rid of, like Alpha would be optimizing, but instead of say checking a bound check, maybe you could do some other check that you could say, okay, I don't have to do the bound check. The compiler, if it's not verifiable by the compiler, I don't have to do that. But.
Well, I have not tried to do any of this. I mean, we are in brainstorming stage. Anyway, but the point here is that those pragmas, they don't convey anything to the verifier or in the object file, right? The second is the optimize or fail pragmas is like make sure that this particular optimization actually happens. Otherwise, error out. Some of them already exist already. And
Jose?
then very fast.
One question at the back.
Oh.
First of all, the O-verifiable.
Yeah.
So the fact being verifiable or not, to me, should not preclude choosing a level of optimization. So O1, O2, those are level of optimization. They are kind of placeholder. They gather a set of optimization options.
I agree.
Being verifiable should be, I think, one option. So -F verifiable. So that's my first point.
Okay, I agree to that. Yeah.
Yeah, -F or -M kind of flag.
Okay, maybe not -O verifiable or
Yes.
minus. Yeah.
My second point is that what you are describing seems to be extremely specific to the eBPF verifier, right? So for instance, let's imagine you have a verifier that allow unbounded loop that in terms of execution time and have some other mechanism to kill the whatever is executed if it goes beyond a certain bound. And maybe BPF could evolve to that in the future. But the thing is, if you fix a semantic for verifiability for everyone, then you cannot tie it to the actual backend you are compiling for.
Right, and that's precisely why I'm pushing for the generic pass approach, in the sense that what is verifiable and what is not. Well, some things are inherently verifiable, some things are not. And actually, I not only have the BPF stuff in mind, but like I mentioned in the Cauldron as well, there are some companies who actually run static analyzers on object code that they compile from their own programs. Before they put those binaries, they distribute them. So if you can make your compiler to generate even a slightly more predictable object code, those static analyzers will work better. So
yes,
well,
but you could have a use case where, let's say, unbounded loop could be disallowed if it's used to index an array, but it could be allowed if it's just extending the runtime because, I mean, in that specific virtual machine, there are some mitigations for kind of extended runtimes.
Yeah, yeah.
Right.
Yeah.
Time check. We're down to 2 minutes. You have any more slides, Jose?
Yes. Well, basically, the assembler support. Okay, there are some couple of pointers which are there to be discarded immediately, but I think the assembler could do something, because it's not about the assembler detecting an assembly time everything that the verifier is gonna reject, but even little things will help. Like, for example, for the assembler, now that it has the CFI stuff in it, for the assembler, it's trivial to determine when a jump goes backwards, right? So that's something that is simple cases and particular things that BPF programmers will actually appreciate to have at compile time, basically, or in this case, assembly time. So basically, okay, the conclusion is the solution is going to be a combination of all those things and even additional ideas. So it's not like, okay, only is the approach 1, 2, 3, or 4. Likely it's going to be a combination of all of it. And what we think is that whatever it is going to be developed in both Clang and GCC and maybe other optimizing compilers that will start supporting generating BPF code. And well, for that we need coordination between toolchains, which has improved a lot in the last months since the LSF meeting. And well, you have some links there. Yonghong told me that the LLVM stuff is no longer in this reviews LLVM.org, but in GitHub, right? So yeah, we don't have time for more. So thank you.
Cool. Let's thank our speakers. Thank you. Hopefully there's more hallway discussions or in the BPF track about that. Let's welcome our next speaker here. Your slides go. Okay. Yep, you can use that one.
Okay, good. Hello, everyone. Thanks for coming to my talk. I'm actually excited to be here and talk about this project, which has been requested for years, if not a decade, from a number of developers, including Peter Zylstra and Stefan Renian. So yeah, my name is Namyeong. I'm working on the perp tools at Google. And this time I'm talking about the data type profiling. So the goal is to get a precise memory access profiles with type information. So with this, you can see which data type in your program is accessed frequently and which field in the data structure is accessed. So it will help your program, help you optimize your program by changing the layout of the data structure in a way that it can be accessed more efficient way. With this, I don't want to change the target code, target source code, or in the library or somewhere else, or required to recompile it. So how to do it? We just use the existing binary with PMU sampling and the dwarf debug information. So before going to that, let's look at the existing profilers, memory profilers. To be honest, I'm not an expert in this field, so maybe I missed something. But roughly, I think there are two kinds of memory profilers, which is one is based on the PMU sampling, so it targets on the memory accesses. Right? So perp tools has two commands for this. Perp mem is kind of general memory access profiles using information from the PMU samples. And there are perp C2C, which is similar, but it's more focused on the catching the data false sharings. So this talk is about this kind of profilers, and I think we can improve this profiling technique by adding type information there. On the other hand, there are some heap memory allocation-based profilers. Heap track is a great project to check memory leaks and heap use patterns. And also, Valgrind is a very good tool to do a lot of things, including memory leak checks and uninitialized memory checks and simulating the cache behavior and so on and so on. I'm not sure this project can help on these profilers too, but in general, it'd be great if they have some type information in their analysis. So PMU memory sampling. So modern processors have PMU, performance monitoring units, and they provide very precise information about the samples they captures. Actually, perf event has a modifier, P modifier, to enable this precise sampling, which gives you basically a accurate memory, accurate instruction address of the sample, right? But if you use some dedicated memory sampling event, you can get more information about your memory access, including the data address it accesses and where the access actually happens, like from L1 cache or L cache or memory or whatever, or what's the actual latency in cycles, or what the cache snooping status, and so on. So this kind of information is very useful to analyze your memory behavior. So we want to use this information with the type information. The supported vendors, all major CPU vendors now support this kind of precise memory sampling. So, but they have different level of support. So on Intel have PEPS, process event-based sampling. They started this very early, and they have the most advanced functionalities. So they can target load or store operations specifically, and they can also filter on load operation on the latencies. So you can filter like I want to sample memory operations longer than this cycles or shorter than this cycles, things like that. On AMD, they have IBS, which is an instruction-based sampling. They have similar information, but they have some limitation that they only capture random instructions. They have no control which one, or they cannot specifically target the memory operations. You can just random samples and check if it's a memory operation, and then we can use that information. On ARM, they have SP, Statistical Profiling Extension, I think. I think it's pretty much similar to AMD IBS, but they have filters. So they can filter load or store operations, and they have latency filters. But to me, it's not clear if when they apply the filters, if it's from the beginning of the pipeline stage or the last one, or if it's the last one, they will drop the sample if it's matched to filters, right? Not matched to filters. But yeah, maybe I could be wrong. Please correct me if I'm wrong. So to get the precise memory samples, you can simply run the perp memory code command. So it will pick the best event in your system, basically. And there are some options to control the behavior. Like you can target load operations only or store only, or you can set different latency filter values, and you want counter code, you want sample counter codes only. And if you are really familiar with this, you can use plain perp recode command with your event. So this is an output of an example. So I ran my program with perp memory code command, and after that I can run perp plain perp annotate to see the disassembly of the functions. So as you can see, there are three samples. Three instructions get samples in this code. So I put the red boxes. So first number in the box is the overhead based on the sample counters. And second number is offset in the code if it's a target of jump instruction, and then their instructions. So here you can see the memory instruction, usually move instructions, and there are operands that describe the memory location. On x86 AT&T syntax, it will have a pair of parentheses for the memory operations. So you can see the first instruction has RDI register as a base and offset of 4. Second one has RBP with its offset of -4. And last one is from RSI register and offset of 8. With this memory location, you can look up the debug information in BoF and you can find this register names in the relevant debug information. So I ran it with readout-wi command, which dumps debug information section, debug info section, and there will be a variable or parameter in the function. So dwarf location description. So as you can see, dwarf has location expression to specify the object in your program is located, right? So it's basically a simple stack machine to specify register location or memory location with some operations like arithmetic, logical operation, or step manipulations. With that, you can get the location of your object. If your target object, variable or parameter, has a single location, the debug entry will have the expression directly inside that entry. But if it has multiple locations, when it moves to a different location in the code, like from register to stack or things like that, it will have a list of locations with a code range it covers and the location expression, as you said before. So let's look at the example how to get the relevant dwarf information. So for example, we have a sampled instruction on the upper right in the black box. It has an instruction address 0x12345 and it has move instruction with memory operand and RCX register. So we need to look up the dwarf information. Some basics on dwarf. It's basically a tree structure, and each entry can have child entries, which has a relevant information to the parent. So on top level, it can be like you can see it like a list of compile units, and compile units correspond to a source file. So you first need to which compile unit your code is in. Then it will look up the child entries to have relevant information to form a scope, like functions, like lexical blocks, inline subroutines. They will have their own scope or variables or parameters. So you look up into the child until you cannot find anything more. In this example, there are 6 scopes from the compile unit, and the last one is lexical unit. It has a list of variables, and the last lexical block has the code range from 123450 to 123460. So it will cover our instruction 123456. Okay, then it finds a list of scopes, and then it will try to look up variables in that scopes from the very last one and going up until it finds something. So when you check the variable entry, you first need to look up the location list first. With the instruction address, this variable has 2 location lists in the gray box above. First one covers only from the 123450 to 123454. It's not. Second one covers this instruction. So we find the second one, and then we need to check the actual location with the instruction. Instruction has the RCX, and this location list also has RCX. So we are matched. So we can use this variable for this instruction, right? Then this variable will have the type information in it. Most likely, it will be a pointer type because we are using memory. We access memory using the pointer. If it's a pointer, we can get the base type of the pointer. So that will be the target data type, right? And also, the instruction has an offset from that register. With that information, we can find which field in the data struct, in this case, the struct type, which field in the struct we are accessing. So with all this information, we can construct sample of data types like this. This is the output of the purple report with type, sorted by type. As you can see, there are still many things are unknown. We cannot find the matching variable or something. And second one is struct RQ, which corresponds to a run queue at each CPU to manage vulnerable tasks. And third one is unsigned long, maybe from some bitmap operations or something. So yeah, this is not perfect, but I'd like to improve with help of some Toshain support. And the next output is per perp annotate, and it shows per field access profile in a data structure. As I mentioned, it targets right now RB node, which is a red black tree node, and it gets total 6 samples. But 3 of them are from the first field, RB parent color, 1 from RB right, 2 from RB left. So you can see which field is more accessed. And if you combine load and store events together, you can see which field is load mostly and write mostly, this kind of thing. So basically this is how it works. But there are still many issues you want to solve. First one is, as you can see the previous example, sometimes you cannot find no variables. You cannot find variables. So imagine this simple example code, function foo, has a parameter, single parameter PTR, and it has a local variable val. So it can generate binary code like this, like in the black box below. And imagine we have samples on the right, the last instruction, the last move instruction with RCX register. But most likely, the debug information from this function will have this on the right box. There are function foo, it has a formal parameter PTR with location or the I register and local variable in the stack. But it has no information for RCX because no variable for RCX, right? So this is the most case it cannot find the type information. So there are some possible solutions. First one is to do from the tools, like BoF consumer side, to build type information table from the variable or parameter type information. As you can see, it has a parameter in the BoF information. And the first move instruction is from the parameter because it starts from the PTR and the code. So if you follow that move and transfer type information from the beginning of the function, we can build which register has which type of information. Yes, sir?
Sorry, let me get you a mic.
Yeah.
So you will, you mean that you will disassemble, way back that the assemble language and find that which one is accessing from where?
Yeah.
So
Yeah, this is what I can do without changing compilers or BoF. So
yeah,
it starts from what it knows and transfer
Hmm.
the information.
So that using the same assembler disassembler output and passing the instructions and what's say
Location.
Yeah, the finding that the location what's say that offset and finding that the next okay. So
Yeah.
yeah.
So the register likely to point a type.
Yeah.
And we have offset, and we can find the type in the struct at that offset and move it to the target register. Right.
Okay, so that are
Then-
yes, it will work. Yeah, most of the time it will work, but yeah, of course you need sometimes that the compiler optimization will say change that the
Right.
the
We will
order
talk
or
about it
something like
later.
that, so.
Okay, yeah, this is the basic approach. This is what I can do now. So I'm working on it. But as you said, we can do better if Dwarf has more information. Right? So another solution could be for compilers to generate more information, like in the pointer chain case, they can generate the intermediate artificial developed information entries for each pointer type in the middle of the chain. Then you can find, even without the variable names, you can find the entry using the location information, and we can find the types. Or maybe more costly, some way. I found a discussion in the Dwarf mailing list that to build a lookup table like I built in the previous slide, to look up from the location to a variable or type. Yeah, so I think there are other interested folks out there to do things like this. So I hope we have some support in the toolchain side for this. And there are compiler optimizations. And I noticed compiler can move struct field. They can change struct layouts for some local variables. I think it's from SROA pass. And it can optimize struct layouts to, I think, to reduce text space. I don't know. But yeah, I saw some cases. It generates very complex location and expression in some variable types, some aggregate variable types like struct or union, maybe struct. So right now I just made it reject this complex location expressions. So it's hard to track all. Question?
I thought that the dwarf information is made by your optimized code or not, so that even if the compiler will change that their layout, the dwarf information will be also updated for that. Yeah.
Yes, right. They updated dwarf information, but it's hard to follow. Like we only assume the layout is same all the time with the source. Maybe not necessarily it's the same with the source, but anyway, we use offsets, so it needs to be consistent with the type information in the dwarf entry. If it's the same, we are fine. But sometimes, after some compiler optimizations, struct is placed, it's scattered around in the stack, right?
Oh,
it's mixed with different variables.
You mean that the context based? different, have a different data.
No.
So
Just,
that it's
just plain stack local variables in a struct type.
Ah, I see. So that it's mapped to the local variables.
Yeah, they extract two integer types from different struct and put them like adjacent and things like that.
Okay.
They're very hard to track.
Thank you.
So I just reject those complex location expressions now. So what it can accept is just simple cases mostly. The most cases is just a pointer variable in a register. That's the most common case. Or for global variables, the location expression could be a absolute memory address. And stack variables, it's an offset from the base of the stack frame. So it can accept those simple locations. But if it's become complex more than that, well, I don't know. And I also found there are struct layout randomization patch. No, there's a config in the kernel. Like I think it's a security feature, but it makes me scary. So I think there's a plugin to randomize there are structures, like structures, but according to the kconfig help message, I think it's mainly focused on the struct with function pointers only. But
I think it'll randomize more than that.
okay, then we are in trouble. I don't know. So I haven't tested it yet, but I hope they would update the layout information in BoF after randomization. Yeah, then it might work. And language support issues, of course. So to simplify my work, I target to my work to C program only. And right now the first target is kernel, of course, on x86. But C has its own issues, like union types. There's conflicting memory pointers, right? The same offset, then we don't know which one we choose. And array can be complex in the location expressions or bit field, maybe. And typecast can be a problem also, since we have this variable in this type, but actual access can be a different type, then we don't know. And sometimes it access memory using a return value from a function call, right? And then may not have the type location or type information. So there are some issues in C, but to more general user space support, it should support more complex languages, C++, Rust, maybe Rust it for kernel 2 and go. Question?
For unions, you could sometimes disambiguate by looking at the kind of instruction. So if you are accessing a 1 byte, then there will be a different instruction than accessing a long. So that way you could, let's say, oh, it's accessing that field and not this field.
Sometimes,
yeah.
But if it's in same size, then
Okay, but then you deal with one.
Right. Yeah, more difficult. Yeah. If there's a chain of pointers and with union, then we are screwed.
You would have to look both to see if you can disambiguate it.
Can be complex, yeah. But anyway, yeah, there are some issues, and actually, I'm not familiar with these languages like C++ and Rust. I need some help on it. So it's not this time. It's not my target, but I want to focus on the kernel only at this moment. But kernel has some special kind of variables called percpu. So percpu variables in the kernel it's a big chunk of array, and each CPU will get a copy of its own copy of the variables. So it will have a different start offset for each CPU, and access to that CPU per CPU variable will start from that offset and add the address for that variable. And I guess thread local storage in user space will have those similar concerns. So in this case, as I said, the location expression will be complex, or not that complex. Anyway, not so simple, right? So, and for this CPU case, to access variables in the local CPU, it has a different form of instruction. So it will use the GS segment registers and the variable address directly. So we need to understand this format too. And there are issues with the split dwarf. To be honest, I don't follow the development on this side, so I don't know the status. So I'm curious how well it's supported. So dwarf 4 with fission and dwarf 5 will support split debug information in multiple files. So, and perf tool use a libdw library for dwarf parsing, but I'm not sure it will support multiple files to get the debug information. Gotcha.
So Alpha Utils does support split dwarf if you're using the original format where every object file gets its own .dwo file. I don't know if, as long as like perf is just using standard libdw access to it, it should work. The other way you can do split dwarf is the DWP format where you squish all the DWO files into a DWP file and then delete all the DWO files. And Alpha Utils upstream doesn't support that, but I have patches that are currently being reviewed that should add that, but no one really uses that.
So I think config debug info split will produce the WOs and not the DWPs.
Yes.
But like I have internal customers that want DWP support in the kernel.
Yeah.
So it's one of these things where everyone wants less debug info and stuff, but like the industry is kind of ossifying more P4.
Yep.
Like, we keep trying to push for 4P5 or split dwarf, and then like all the other tooling that needs to consume it is all broke.
Yeah, and the funny thing is I think Google and Meta are the only ones that use DWP, so we're the only ones that run into this. But Alpha Utils should support it soon.
Okay. And there were some performance issues during the development on the object dump. So object dump is needed to disassemble the code to analyze the location information and do like build a type table things. So every function, it gets samples. I need to run object dump to get the disassembly, but it was terribly slow. So the problem was when it runs with the debug information. So I used the perf annotate a code to call the object dump, but it has -l option by default to print line number information, but I didn't need it. So after removing that option and make it conditional, now it's run much faster. But at the moment, I had a -l option to print line number information. The LLVM object dump was much, much faster than GNU version. After I removed the GNU object dump runs faster than LLVM.
Have you tried data type profiling the disassembler itself?
Oh yeah, not yet.
That's a joke.
Okay. Yeah. I plan to run object dump with data type profiling. Yeah. So maybe we on x86 NList we have in-kernel instruction decoder, so we can do simple things NList manually, like extract location information from the target instruction. Maybe harder to do all the disassembly, but we can extract that information. Question?
So how do you what's say that specify that the obj dump? I think that the obj dump has an option to disassemble one specific function or something like that.
Yeah. I specify the code range, start address, and stop.
Hmm.
The element disassembler, you can give it a function symbol and say just disassemble this function.
Yeah.
I think it would be the same.
Mm.
So it doesn't dump all the instruction in the target.
Yeah. Anyway, the in-kernel instruction decoder is much faster, I think.
Yeah. Of course.
But how much faster you want that to be? I mean, what kind of issues are we talking about here? I remember seeing some emails about this, but I don't recall right now. I mean, how slow it is?
It depends on the number of samples and number of distinct function and instructions to get samples. But for some example, I have a sample data. It runs. It's fixed in my V2 posting, and V1 it runs like less than 5 minutes, but 4 minutes 30 seconds ish. But with V2 it runs in 10 seconds.
Okay, got you. Yeah, and this is only in x86.
Yeah, right now.
Okay, because each disassembler is actually a different world.
Yeah.
In binutils, yeah.
Okay.
So yeah, okay.
Yeah, but the goal is not to call object dump as much as possible. Use in-kernel instruction decoder, and x86 is much harder to do it manually, but I guess other architectures is more easier. So that's it. So now Perp tools are implementing the data type profiling with PMU samples and dwarf debug information. And I need some help from toolchains to have better dwarf information. And let's make it more useful and easy to use. And here are links to my postings. And thank you for listening. Questions?
Okay, we start here. We go back then.
So you mentioned in the very beginning, so this kind of information is used to guide the compiler to do some structure layout optimization, right? Is that a major purpose?
Not the compiler, folks. It's to developers to maybe compiler too, but main motivation was to each developer understand their
type
memory behaviors.
Okay, so it's not a target to be used by the compiler to do optimization.
Maybe we can do that later, but not at this time.
The problem is that they need to understand the whole program to make sure that it's safe to swap two fields, right? How do they know? So they need whole program kind of analysis to do this.
Yeah, but we already
maybe
have
profile guarded optimization kind of things can be done later.
Okay, so there originally there is some structure layout optimization, the compiler based on the whole program mode, and then the compiler can instrument the program to profiling the structure during runtime. So so it's a different. So this one, your work is only based on the object file, right? You're starting from the object file and then reverse engineer to get the type information.
Unless we have dwarf information.
So you're not from the source code level to no. You from the bottom up.
Right.
Okay, and then provide the type information then analyze the program. Then how to use it? How to use it is still.
It's more like perf is giving you the program counter. Some axis is really hot.
Yeah. Then
you're going in dwarf and working from the location lists to say like at this program counter, what could possibly be at this offset.
Okay.
Trying to reverse engineer like what type.
What type is used most?
Axis of this member.
Have you taken a look at the perp mem or perp C2C command? I recommend it.
We cannot do what you suggest because we want the data to be from production workload. It's not like, hey, let's run a binary instrument to trace. At Google, we cannot do this on all the applications. They don't have a benchmark or something like this. We want to do the same approach as AutoFDO, that you collect the data from production workloads, not instrumented. So they need to be optimized. So the code needs to be optimized. And you come in with low overhead, you sample, and you do the analysis offline. And I wanted to add something. The motivation behind this is like to try to optimize the data accesses. Why? It's because we believe that you may bring more cache lines to the core than you really need to do the work. It's about reducing the memory bandwidth usage. Right? It's about minimizing this. And if you bring a cache line of 64 bytes, you better use 64 bytes, not just 2.
That's false sharing, isn't it?
No, it's not just false sharing. It's just, hey, I'm just bringing a byte, but I'm just bringing a whole cache line of 64 bytes, and I just use 1 byte. Right? And then my other hot field is in another cache line. Says, no, it's so expensive to bring a cache line that you better make use of it at the maximum. So it starts with maybe organizing your data structure a bit differently to optimize for this. Now they can get it.
P-hole can do reorganization of structs to get it more packed. Right. The idea is getting this information. We would see, oh, there's this axis, then another axis, then another axis, and they are on the same like sequence of events, like the same function, let's say. And then you could, instead of 3 cache lines, you bring just 1. That's one case. No, automatic, because that's how the cache hierarchy works, yes? You would get this thing. And other things is like, oh, this algorithm is not well tuned because it's getting things from another node, in another Newman node. So the latency will characterize that. Getting from the local memory, that latency. But that bigger latency is getting from another Newman node. So that's the kind of thing that once you have this characterized and map it back to the fields, you can go on. It's not just one thing. There are multiple things that you can be detecting. False sharing as well.
Looking at like that data profile guide computation.
That could be. I mean, you could rewrite the source code and recompile. That could be as well, or inform the compiler, and the compiler does it for you.
Yeah, if we find that there are something like referring that some pointers or something like that, we can other let's say prefetch instruction before that. Yeah.
There was.
I have one question. So, is it possible to feed the profile data back to the compiler so the compiler could reorder all the struct layout? Yeah, pretty much like auto FDO, but for memory.
I hope so.
Yeah,
someday. Maybe not this moment. Okay.
You have 4 minutes. 5 minutes.
I don't know, I mean, if you said it, that so far the data that it needs from the PMU is just the ability to sample loads and stores precisely. And all the architectures support this. He was showing it on the x86, but on x86 Intel, but on x86 AMD, you can do that. On ARM, you can do that. So it's a portable kind of approach, right? The dwarf is like the same. It's just that the PMU needs to point you to a load or store instruction. And they all do that.
More information that you can get from PEBs. Yeah, you can get, let's say the offset in the cache line. that caused that latency, that load store. So he mentioned getting the offset from the instruction, from the IP. But perhaps at some point in some of the cases that are difficult to solve, you could use the offset from the cache line to help find the type.
All the PMUs can also give you the data address, the address of the load of the store. It's doing it now, but it's available.
I understand this is sample-based. That's why you mentioned auto FTO, right? So it will be something similar. But I mean, if it could be done in a not intrusive way yeah. No, but I mean, maybe instrumentalization could also play a role in the sense that you could, yeah, that's why the if, yeah. So you could generate the profile data and then.
Statistical sampling, so you will not get a trace of all the loads and stores. You don't need this because we're after the hot accesses.
Yeah.
You not the rare accesses, you want the hot accesses. And the PMU is designed for that. So you will get.
And do you have a particular specific list of features? I think it was the last slide that you will benefit to have in the toolchain?
Yeah, this one.
Okay.
To make an artificial debug entry for the chain of pointer cases like SPTR, another pointer variable access.
And maybe this is something to discuss in the kernel toolchains list. If it's not been already.
Patches to the toolchains list.
Yeah, but you know this part. No, I mean, what you require, what would you benefit to have in the toolchain, in the different compilers? Better Dwarf, whatever it is.
Yeah, right now I mostly I need more debug information for this missing part of the memory access.
What you need is that I think the dwarf is designed for debuggers. So you go from a variable and it will tell you which register has the variable. And here we have the register. We want to find the variables, the reverse. Right? And that's why it's difficult. It doesn't work all the time. But if you had that, then you could solve this more easily.
A common issue that I've had is I'm trying to track down, like Clang has very excessive stack usage, very bad. And it's actually very sloppy with the lifetime of values, which is important for stack slot coloring for reducing the stack usage. And it also spills more than it needs to, and there's bugs. We need to fix them. But there's nothing in the tooling to say, like, break out the crayons and draw me a picture of what does my stack look like? What values are being stored where in the stack? And technically there's a temporal dimension because as the program counter moves, you may be spilling something suddenly into a stack slot or reloading it, and then now that stack slot is dead and you don't touch it anymore. But your problem is similar, and I've done similar things with looking at Dwarf to try to draw that picture, but like it would be nice if the compiler could draw that for me. But your problem is even more generic than just the stack. You care about all the memory accesses.
Thank you.
Thank you.
So 10 minutes break.
I think maybe our plan of doing the
Now on year 6, on year 12. Boom, 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 boom. A boom, 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 boom. Boom, 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 boom. A boom, 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 boom. Excuse me, gentlemen. Excuse me, excuse me.
We don't feedback and tech is working out very good for me. I like to see other options. PS4 is an
That's why. So you like that few seconds. Only if I don't restart. Won't have that knowledge.
She'll be talking with me on Wednesday. Yeah. Most an abstract, and then I got exceptions, and then it's out for talk. So his question is saying like the risk drive. Actually, I suppose you were in the risk. So I was at the risk drive conference last week, and I've got a risk drive t-shirt, and I was like, I don't think there's any time I check my risk drive. So he's saying like all the vendors who are risk drive, they don't know what like configuration value they're going to instructions and cycles. So he doesn't want to put a massing kind of instructions and cycles through to some configuration value because every vendor's going to do it. He's like, can we do this mapping in the BoF? And I'm like, software is software, like nobody else does this, so I said it's not much. I'm trying to. So, if you make it such that, so what else you kind of say to make it there's the raw roots, and then there's like the built in like some, and then but I think those are some we might. That's what teachers say. He's saying like, why don't we take this out? But then it's a case that we need to have a special. If we start cycles and go on this and go like, because the loads of cycles around. So we have to. We have to have a different event path for this part. It's not that's why, I know that. Somebody on the Zoom and then like maybe some great
Okay, so you're dialed in. And then all right, so we'll move this. I'll take this laptop and put it on this table here, and you can put your laptop on this podium. Nice to meet you, by the way.
Yeah, finally we meet.
Yep, perfect. And then if you have a demo outside the window.
Yeah, but my slides are not full. I need to update my slides.
I think they are. So hit the plus. And then it's one of these. Do you remember what the name is?
Yeah.
Cool. Okay.
Awesome.
And then from there. Okay. Yep. That's your laptop. You can. But
Change the slides, and then
for
I
a
can
demo.
yeah share my screen,
Perfect.
and I can
Yep.
share a window. Oh, I can. Oh. Okay, I'll share my window screen. I was hoping I could share. Wait, maybe fine.
Maybe if you pop it up full screen mode. will it
Yeah.
glitch in? Seems
Yes.
like a bug in Chrome, but.
No, it's gone.
Oh.
Okay, anyway, I'll share the whole screen. That will do.
Do you have a card? Do you have a card? Card.
But yeah, reach out after the talk, and I can give you my email address. Or something. Actually, you have my email address.
Really? Okay.
Yeah. Okay, everyone, we're gonna get started with our next talk here. Yeah, me so.
Okay. Well, hi everyone. Today I want to tell you a little bit about an IDE setup that I came up with for kernel development. And because it's a difficult topic, I wanted to start with a disclaimer. So this is not a war. I know there's an editor war, and I'm not here to feed the troll. To be entirely fair, there's a lot of problem with VS Code. It's an IDE written in TypeScript. It's not something I particularly like, but it's very cool. It's very powerful. And in the end, I could come up with a setup that is so powerful that I ditched my VI habits and I started to use VS Code. So yeah, why am I giving this talk, or why am I building this thing? Originally, it was to lower the bar to entry. My team was going to have interns, and we didn't want our interns to spend half of their time setting up some environment, some tools, and blah, blah, blah. So I started to hack on something and see how far I could go. And yeah, it worked pretty well for the interns. They saved a lot of time. I realized it was pretty cool, so I started to use it myself. Then my teammates started to say, hey, can I use it as well? So we also have VI users, Emacs veteran in my team who switched to VS Code. And then people across the company started to reach out and say, hey, I stumbled upon this and it's really cool. Can I use it? Until Nick reached out and asked if I could present it. So I open sourced it. So now it's all available on my GitHub. And hopefully you will be interested in it. Yeah, so one benefit I found with this setup was that it improved the reproducibility of the setup. So for example, I work a lot these days on syscaller bugs, and I find that people complain about, oh, syscaller bug doesn't reproduce on my setup because I'm using this and that and that. But having this sort of reference setup that everybody likes to use makes it easier to say, well, this is how you set it up.
And then I have sort of a philosophical point about the Unix philosophy of do one thing and do it well. I find that the reason why the Unix philosophy is so effective of tools that do one thing and do it well is because of interoperability. So if you have less, ls, grep, find, whatever, they are really so powerful because you can pipe one into the other and they sort of all work together. So I wanted to take this as a design idea and see how far we could get with integrating all these tools we have together. But yeah, first, mention for all the tools we have, and that are great. So I'll scan through a bunch of tools that exist and you probably use already. And all of the tools I'm going to mention, they're all integrated in the VS Code setup I will demo afterward. So I said I split them in different sort of categories. And the first topic I want to talk about is the mailing list tools. So if you want to send something to the list, most likely you're going to use git format patch. Maybe you set up a cover letter and you want to edit it. And I know that Git has some features for this, but I find lots of people, what they do is they spin up VI, they modify the cover letter locally, and so on. Then you probably want to run check patch. You want to see who to send it to, so you're going to use get maintainers, and then git send email. And to highlight one of the interoperability issue that I see is, for example, the output of get maintainers is human readable, but you have to sort of copy paste the email addresses into git send email, which is always taking a bit of time. And I found that it caused a great deal of anxiety with my colleagues. So actually, often my colleagues would pull me in and say, hey, can you triple check my git send email command? Because I'm so afraid to do something wrong. And if the email is not, if I forget someone, or blah, blah, blah. Yeah. Other tools we have, Lore. Lore is kind of cool. Archives all the emails. It's this kind of old UI. It's maybe sometimes a bit hard to read, but it's great we have it. Patchwork, lots of subsystems also index their patches with Patchwork because that's sort of more modern UI. They can assign people. They can set the state of review. And Patchwork has pretty nice APIs that you can interact with. So I'll get back to this later in the demo, but yeah. Lots of people have MUT or some email client set up. Everybody has different setups. Some people have lay, I don't know how it's pronounced, other things. Before, it's amazing. I think Before is really great. It's sort of an inspiration for the direction of this talk, how you can take these different steps and try to integrate them, and then you get value from the combination of all these tools. Yeah, so a bunch of tools that are pretty nice. Now I want to talk a little bit about build tools. So in the domain of building, we have just the config generation, of course, config. But again, I stopped counting how many times colleagues will come to me and say, "Oh, my bug doesn't reproduce anymore. What's the problem?" And turns out they keep copy pasting the config they've been using for 4 years because they're too afraid to regenerate it from scratch because it's the one config they know run in their VM, and if they regenerate it, it will not run in the VM. So sort of a sane setup to generate a config file. That's quite cool. Make. What could be possibly changed in Make, right? Well, everybody I know has a wrapper for Make that uses the maximum number of CPU because it's so annoying to type make -j something something. We have Ccache as well, which is quite a cool tool. I found that most people I know don't use Ccache, and quite some people I know who use Ccache actually have it misconfigured. And basically, every time they try to generate an object, the timestamp is different, so the cache misses, and Ccache only has cache misses, and it's completely pointless. So having a setup that has Ccache integrated, which works, is very cool. Clang. So the question maybe for the recording is someone was told to not use Ccache because it might interfere with the kernel. Possibly. I haven't had any issue myself, so maybe. Don't know. Clang, this is the toolchain track, so lots of people know there's a lot of value in LLVM. The most value I find in LLVM is all the ecosystem that comes with it. For example, I really like Clang format. Well, you don't really necessarily have to buy into Clang to use Clang format, but still. I don't have to think about how to format my patches anymore. I just ask Clang format to deal with this for me. Just remove some mental burden from contributing to the list. And the star of the night, ClangD. So ClangD is this daemon that knows how to parse your files because it uses the same compiler frontend as Clang, and it has the same compiler arguments as Clang, and it serves a language server protocol so that your IDE can query ClangD and ask for types, information, users of functions, blah, blah, blah. And ClangD is really a key part of the setup I'm going to present. Cross-compile. It sounds easy. Sounds like there's not much to it, but it's so easy to type. Make cross-compile equals ARM64 J32. Make cross-compile equals ARM64 devconfig. And then one day you forget and you just type make menu config. And now it will default to x86 and mess up your config file. And you have to start over. So there's so many ways to shoot yourself in the foot. Another domain of tools where we have a lot of stuff again, and they sort of all work independently. Virtual machines. So I've been working in a few different companies, and it's been so interesting to see that everybody has a wrapper for QEMU. Everybody has a wrapper for dbootstrap. And you will be happy to know I came up with yet another one. Yes. So what do we have here? Well, dbootstrap as an example of something to generate a rootfs, but I know some people use buildroot or anything really. QEMU. So QEMU is of course amazing, but the command line of QEMU is difficult to remember. So yeah, everybody comes up with that. The one shell script that wraps it. GDB. I think there's so much value in using GDB for kernel development, but from what I can see around me, most people do not use GDB just because it's a bit annoying to set up. So it's easier to just print K and reboot the machine and see what happens. Symbolized backtrace. Yeah, if you have a kernel backtrace, you have all these addresses, offsets, they are hard-coded, hard to read. People may or may not know that they can actually have line numbers. And personally, I always forget which script it is and the tools that does it. So I often share backtraces that are just hexadecimal addresses and are pretty useless. And then other tools that are pretty nice to have in a VM. So I don't know, if you generate your VM nicely, you have probably SSH access into it, but maybe you want to easily throw it into your VM image. Maybe you want to have some shared directory with the VM with 9pfs, blah, 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 blah. Okay, and I'm not even done. So more categories of tools that people come up with, automate, what I call automation. Let's say you are working on a new kernel feature, you probably introduce a new syscall or something, and you want to have a fast iteration cycle where you reboot your machine, and every time you reboot your machine, you want to run your stimulus that will just call your syscall. So you don't have to log in and type a command, and so some sort of auto start every time the machine reboots. Depending on your subsystem, if you're lucky, you have self-tests. They're amazing, and but yeah, sometimes a bit cumbersome to build, to run, so on. Oof, it's a long list. Huh? Other categories of tools, if you want to share a link to someone, you have your file and line number, but maybe they are on a different branch, and you want to have like maybe a cgit.kernel.org link. So there's some tools for this. And what I call interactive workflows. I'm going to take the example of sysbot bugs only. So I deal a lot with syscaller bugs. And the process is always the same. You go to the page, you find the line that you're interested in, you download the .config, you check out the commit, you download the reproducer, you build the reproducer, you push it in your VM, you run it. All these sort of things that would be cool to automate. Okay, enough of the existing tools. Let's see what I could sort of integrate in a VS Code setup. And let's see if I can share my screen. That's the big... Remorse. Yes, it is working. Amazing. Is there a way to make it bigger?
Let's see. I don't know which cursor is your cursor, but there's that.
I think I can't reach that one. No.
No. Okay. Maybe the controls in the back of the room might be able to maximize the screen.
This one? No.
Oh, yeah, there we go. Perfect. Thank you.
Amazing. Cool. Okay, so let's start with the mailing list workflow. I'm going to work on a feature. I'll just create a branch. And yeah, the thing I've been waiting for a long time is that fork will be more verbose, right? That's what we all miss, right? So let's just add a print K to fork. And that's going to be my patch. That's what I want to push to the list. So to create commits, to be entirely honest with you, I always use the terminal because it's nicer to use git commit. But for the benefit of the demonstration, I'll show you can also do it from VS Code. Make for create again. More print k. Okay. All right. So now I have my branch, I have my commit, and I want to send it to the list. Well, you're in luck. I wrote an extension called git send email. And what it does is it remembers a bunch of parameters for your branch. So here you have a LPC 23 branch. And you can set some flags for the mail you want to send. So for example, a subject prefix. We're going to start with an RFC because I'm not quite sure about this, if this will fly on the list, and I don't want to sound pretentious. So RFC v1, let's add a cover letter, print k, verbose, print k, and make print k, more verbose. All right, so I can select how many patches I want integrated in the series, but I just need one. I can inspect it quickly. So if I click on the patch, I can see the patch. And now I can use the magic wand to call get maintainers. And get maintainers will return me all the emails that I want to or CC. Give it a second. It's a bit longer for CCs because there are a bunch of people who are interested in fork.c. Okay, and yeah, actually, I will not email these people. So let's remove them all. And let's use the other button here. So this one actually parses the maintainers file and knows everyone in there. So let's find me in the maintainers file, and let's just email me. So you have a bunch of additional cool options that are useful when you work on a series. For example, okay, here we only have one patch, but an interactive rebase is something that I find myself running all the time for the patches I have in my series. And I don't know about you, but what I do is I do git rebase-i head tilde 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 tilde, and then I remove two tilde because there was two more. Yeah, so this tool knows how many patches you have in your series. So yeah. You can also inspect the World Series with the cover letter and before sending it. You can run check patch. So it will generate all your patches and run check patch. And for example, here, print K should include kernel level. Doesn't matter. I just ignore it. Okay, and then when you're ready to send it, you have the big blue button. And I always insist that it's a safe button. It only generates a command for you. It doesn't actually press enter. So you can still deal with your anxiety, looking at the terminal and opening the file, making sure that everything is okay. And when you're ready, press enter, yes, and yes. And then send. Yes. Wait, gets better. So actually, it found the patches I sent. Because it controls the terminal, it finds the message IDs in there. And it remembers them. So if you click on one of the previously sent series, what is going to happen is going to search for it on Patchwork. If it finds it, it will just open it on Patchwork. If not, it will open it on Lore. Well, this time we didn't CC any mailing list, so it won't actually find it on Lore, but it would if it was archived. And now, let's say I got some reviews and I want to bump the series. I can just bump the series. And now I got my LPC 23 v2 branch bumped to v2. And it still remembers my previous send, so I can still find my history of lore links, because finding my previous submission is also something I always struggle with, like, which was v2, v3, and blah, blah, blah. Plus, it knows the history between the link between all the branches, so you get an extra button now, like range diff, which lets you compare the current branch with the previous branch, and then you can see what changed between your v2 and v1 branch. All automatically from the click of a button. That's very nice when you need to say what changed since v1, this and that. Okay, so that was the sending path. Now let's see about the receiving path. So I wrote another extension called the Patchwork extension, and as you might imagine, it integrates with Patchwork. So this is a series of list of patches that were recently sent to the list, and if you open just a random one, you can inspect the patch here. And so Patchwork has pretty advanced metadata extraction from the patches it finds on low. So actually, I can really render the diffs nicely in a 2-pane diff. You can also have links to the local files. And you can do things like reply. If you just click reply, what it does is it will just download the content of the patch and generates a nice mbox, which you can send with 2 commands. So it's quite straightforward. You can just type from the comfort of your ID and reply to the list right here. Save. So that was just a single patch, but it also works with series. Like here, we have a series. There's going to be a cover letter. Of course, it doesn't load. Demo effect. Doesn't matter. You have to believe me. And the patches of the series. The question was, does it use MUT for sending the emails? No, it doesn't. It just uses git send email. Or actually, it doesn't use anything. It just generates an inbox for you. And it gives you a nice header at the top that explains that if you run these 2 commands, that will send email. And the first command strips off this very header. And the second command just uses git send email. So as long as you have git send email set up, it will work fine. What else? You can filter things out. So let's say you are interested in netdev. You can filter by netdev. And let's say you want to stalk me because my patches are very interesting. So you can also filter by me. I find that stalking people is tremendously useful because let's say I know that this one kernel developer works on a feature I care a lot about, and I want to know if they renamed the feature to something else because maintainers ask that it gets renamed something else. And here I can just see the history of recent work from someone, and I can also know if they are slacking off on my feature by working on something else. Right, and maybe one thing I didn't show is also you have the work conversations log in a tree here. And lore links, so yeah. All right, I think, oh, and you can also save filters. So if you, let's say you like this filter of me on BPF, you can just save this filter and get back to it later. Right, now let's talk about building. So I'm going to use the Control-Shift-B shortcut, which is a standard shortcut. There's a question here.
Can you? No, we need remote. We allow remote attendees.
So some of my workflow around patchwork does involve pulling down the patch and testing that patch locally, so I can provide testing time. So do you also have integration for that?
Thank you very much. I forgot to mention something.
Yeah. It was exactly the question I had, because as soon as I'm going through my whatever subsystem I'm review for, or in this case it's GOC, but still I'm looking at kernel code, I'm looking at C library code, I'm pulling and then usually passing patches off to the tester. So I tend to use PW client or Git PW basically, but I'd love to not, and I'd love to be able to have interns do something like this. So what do you do for that?
Right, so if you have a patch or a series open here, like let's look at a series, for example, here, you can just click on the apply series button, and what it will do, it will download the patches and git AM them. It would be nice if it were also trying to infer the base and maybe creating another branch. Right now it's a bit simple, it just applies them, but I'm hoping to improve it if people start to use it. Okay.
Yeah.
Another question?
I saw in your slide you mentioned V4, and in your workflow you're using like just like raw git send email and pulling stuff down from Patchwork, and it looks really clean, really refined. V4 does a lot of this as well. I was wondering if your extension integrates at all, because I really like how V4 will get the maintainers for you and format your patch and do the cover series folding, and it will also fetch trailers, and I find that really nice to use. But that also looks great to you. So I was wondering if there's a nice crossover with V4 there.
That's a very good question, actually. Does this use before? It does not. I think the reason why I did not use before, even though I think before is amazing, is because the way I named this extension is Patchwork and Git and email is sort of like a generic across different projects. And I'm not sure if before is kernel specific or works with, let's say, QEMU or Mesa or any other project that uses Patchwork. So I scoped my extensions in a broader perspective. That being said, I'm also very open to having conditional features. Like, for example, in Git send email, the magic wand to use get maintainer is only available if you have a get maintainer PL script in your workspace. So let's say if you're working on something else and you don't have get maintainer, the thing will just not be there. So I guess I could also have something that if you have before, then you will use before and you will get all the amazing features that before has. Okay, back to what I was saying about now the build. So yeah, there's a standard shortcut in VS Code. Command Shift B that just builds, and what happens there is it runs what they call tasks, and tasks are just commands. So I have a mega bash script that implements all the tasks, and it's very simple because it's just bash. You can read it, and it's straight to the point. So it does very simple things like check if you have a .config. If you don't, then it will generate one for you. We missed a step because we did other things. But basically, it generates one with make dev config, make VM guests, so it runs well in the VM, and it enables debug dwarf. And then it will also run make. And then by default, it will use all your CPUs. It will use LLVM. It will use Ccache. And it will generate a compile commands.json file. What is compile commands.json, I hear you ask? So compile commands.json associates all C files in your tree with commands. So it's just a log, essentially, of every call to Clang or GCC that was generated by make. What that means is that ClangD can parse this file and knows if you're trying to open this file. So let's just open this file. ClangD knows which are the configurations you had enabled, or what are the include paths and everything. So it can gray out the parts that are not built, and it can also resolve precisely the configuration you have. So for example, here, if we look at syscall table, and we look up syscall table, we end up literally on the syscall table definition we're using in this build. And it's very cool because from what I could see, a lot of developers, what they do is they use something like grep. So this will be the equivalent of grep, where you just search for syscall table, and these are all the hits in the code base, and you'll find, oh, this is for alpha. So no, I'm not using alpha. This is for arc. I'm not using arc, and so on. So you really find the symbols for your build. What else? Maybe that's it for build. I have a list. I have notes with everything I'm supposed to talk about, and I will just make sure I didn't forget anything. Yes, I did forget something. So another thing that's pretty cool about this setup is that, as I say, tasks are implemented in a script called task.sh. And one of the things it does is it sets up some environment variables, and then it sources a file called local.sh. And in local.sh, you can put whatever you want. There's a question here.
Question about the compile commands. Do you have any scripting or automation to generate the compile commands? When I've played around with ClangD, that was my single biggest hurdle.
It's in tree right now. Scripts, Clang, gen, compile commands.
For stuff that is not in tree, or if your tree is slightly different, say you're using sparse trees where you don't even necessarily have the entire thing. I have not played around with it. So the in-tree script is the best answer at this point, is what I'm hearing.
If you're in tree, use gen compile commands. If you're out of tree, doing your own thing, try bear. B-E-A-R.
B-E-A-R. All right, cool. Thanks.
So I actually have a similar problem. I work on a branch that doesn't have make compile commands.json, and what I do is I just extract the gen compile command Python script with git show from a branch that has it, and then I just run it, and it works even if you are on an old kernel tree. Anyway, yeah, so I was saying task.sh implements all the commands. It sources a local.sh, and there you can have your local configuration. For example, you may choose to cross-compile for ARM64. And now everything I'm going to talk about will work for ARM64. That's not just compilation, but that's also cross-debugging. That's also emulation. and anything else I can think about now. All right. So now let's talk about virtual machines. So I showed the first shortcut, Control-Shift-P. Now the second shortcut you need to remember is F5. So F5 is also the standard shortcut in VS Code to run your target. You can, of course, change all these shortcuts, but I just want to say this disintegrates with how VS Code is supposed to work, and if you change your shortcuts, it will work for all projects. So I intentionally deleted my rootfs, my guest rootfs, just to demonstrate the generation of a new rootfs. But what happened here is that the setup noticed, oh, you don't have a rootfs. Let me create an X4 partition, and let me inflate Debian init with dbootstrap. Or actually debstrap, because I found that it works a lot more reliably than dbootstrap. So yeah, it takes a second, and now I need to keep you entertained for 5 seconds. I don't know what to do.
Dance, sing? No?
Yeah, my singer skills are not very on point. It's actually relatively fast, but yeah, for example, when I say that if you set target arch ARM64, it will also generate a cross image for ARM64. Okay, got 5 seconds from that sentence. And anyway, once it's done generating the image, what it will do is it will use a mechanism called autostart. So as part of the setup, there's an autostart directory that contains 3 things: an autostart systemd service, an autostart.c, and an autostart.sh. So here it noticed that autostart is not in the image, so only then it will actually open the rootfs and install autostart in it. And then it boots. So it's quite fast because it's on x86, so it's using KVM. And the whole thing is set up such that you are directly logged in. You already have your root terminal, and you can do other things like SSHing into it. So that's another task. And here I have another terminal in the virtual machine. One thing that's also pretty cool is that by default, it will always run with a debugger attached. So without you noticing anything, this run under GDB. So now if I pause the VM, I have backtraces on all CPUs, and I can inspect the local registers and variables if there were variables, but there's nothing. I can single step. And so on. I can set breakpoints, remove them, blah, blah, blah. More things. Yeah, so I said there were many tasks. For example, some of the tasks are shooting into the virtual machine. So if you do not have your guest kernel running, you can still choose to shoot into it and modify the file system and adjust things. And again, this works cross-architecturally. So actually, if you're shooting into an ARM64 rootfs, you will also use QEMU static to run the binaries, and everything runs transparently. Cool. Let's see. That is enough for VMs. Now, yes, I was mentioning actually automation, autostart. So this autostart.c file you can modify. And there's also an autostart.sh. So if you want to run a stimulus, which is more of a syscall kind from C, or if you want to run more of a sysfs write from bash, you can just modify these files. And then the next time you run a VM, it will notice they changed. It will push them in the VM, boot the VM, and then at the end of the boot, you can see they run. So it's quite useful. For example, to reproduce syscall bug, you can just iterate super fast. You just press F5 and the whole thing runs. We provide other tasks for self-tests. For example, I work a lot on BPF, so you can run BPF self-tests. It's also integrated. Another feature. I have a lot of things to say. I hope you're dealing with. There's a bit of Git integration here, and one of the things that I find super cool is the blame at the end of the line. So often documentation is sort of lacking in the kernel, but you find that the commit that introduced the line is super helpful. It has really good context. So here you can just overline and You can see the patch description that introduced the line, and I find this saved me a bunch of time with really good context. Another thing I want to share is how you can just generate CGIT links. So this is the content of my copy-paste buffer. If you go in the right copy as, you can just generate a CGIT link that links to the right file at the right commit and at the right line number. It's very useful to share code with someone.
Oh, Florent,
Yep.
let's say in your make fork great again change, let's say I messed up my indentation. I use space instead of tabs.
Very good question as well. So let's say you have messed up your indentation and you've used spaces instead of tab. So you get live squiggles from checkpatch. So here you can see code indent should use tabs where possible from checkpatch. So you have live checkpatch. You don't have to wait until the end and until you run checkpatch. And on that topic, also something I forgot to mention, because we are using ClankD, we also get live squiggles from Clank. So as you type your code, you get basically compilation errors. And even better, you have compilation quick fixes. So like the cool kids who do Java in some modern IDEs, now you can just say apply quick fix, and ta-da, which is amazing.
Hey, nice.
Can I get a question in?
Yeah.
Yeah, so I think VS Code is one of the only editors with like first-class Copilot support. So is Copilot writing all of your patches? And how does that integrate into the workflow? Can it write my patch descriptions for me?
So the cool thing about VS Code is you can install a lot of extensions. So you have this extension tab and you can install a bunch. And this setup comes with a bunch of recommendations like device tree, kconfig, VI, no, this one I installed myself, x86 and assembly and a bunch of stuff. But it doesn't recommend any of these AI code generation tool. You could play with them. I haven't played with them myself. I believe for kernel development, they are maybe not as, let's say, advanced as they will be for stuff where Stack Overflow is well, has a lot of information. So like, let's say, if you write Python, probably works well. If you write kernel code, probably doesn't know about your subsystem, I assume. But play with it, please. And let me know how it goes. I'm interested. And I have one last thing to show. So VS Code has really good integration for notebooks. So if you're not familiar with notebooks, these are sort of like documents where you can mix text and code. And I provide a couple of reference notebooks. One is for Sysbot bug reproduction. As I said, I care a lot about this. So the idea is you can just provide the URL of your bug, and then you can interactively run all the cells. So you can just do run all, and what it will do is we'll download the Sysbot page, we'll parse it, it will ask you for the crash you want to reproduce, it will check out the commits, get the config, build for you. It will download the reproducer, build it, push it, run it. And there's no hidden magic. You can see how everything is implemented. There's no crazy layer abstraction. You can just dive into test.sh and see how everything works. All right, that I think was it for the demo. So how does it work? The reason why I want to talk a little bit about how the setup works is because I want to show there's no dark magic. It's very simple. You can modify it. And that helped a lot of people to adopt it because they realized, oh, that's just a bash script. So how to install it? You just have to clone this .vscode directory under your kernel tree. And essentially, that's it. You should run the update task once because it generates a file that maybe I could do in the default Git repository, but I need to think more about it. Meaning that the whole setup is versioned with Git. You can Git pull it, you can fork it. It's just a Git repository. So, and everything is under .vscode. So it's as simple as that. You can also update it, which is basically Git pull, but it does a few things to make sure you will never get any conflict. Because as long as you modify your local.sh, you will never get any conflict. So what's in there? Briefly, so VS Code understands these JSON files. One is extensions.json. These are just recommendation of extensions that the setup thinks you should want. You can choose to ignore it if you don't want these extensions. But for example, that includes the patchwork extension, the git send email extension, and let's say language support and so on. There's one that describes how to run the VM with a debugger. So you can choose, for example, to run the VM and as soon as possible attach a debugger. You can choose to attach a debugger to a running VM, or you can choose to start a VM, wait for the debugger to attach, and then continue. Settings provide a bunch of default settings, for example, or sort of like code linting options or options to ignore all sorts of temporary files. So you know if you grep through your kernel tree and you find that 80% of the hits are temporary files, and like these are filtered out by default with the setup, so you don't have to think about it. And tasks.json associates commands, so just have a nice name, to bash commands. So executions of the tasks.sh script. So yeah, all the actual magic happens here. It's just this tasks.sh script. It sets up a bunch of environment variables, sources to local.sh, where you can override some of these environment variables. And then it's just a huge switch case. And depending on the argv1, it will just do different things. So you might run make, you might run make defconfig, or blah, blah, blah. Notebooks are just notebooks. There's not much to say. I only showed you the Sysbot one. I have another one for Lisa, which is this framework from ARM, which is kind of cool. It can SSH into some target, and then it basically extracts ftrace data as a pandas data frame. So then you can do data analysis with this and so on. So the setup also comes with this, and it's pre-configured for the SSH port that is set up by default by the VM and so on. So everything just works. And then how to start, I also showed you, is just this C file, this SH file, and this system service. And that's all I had. So thank you very much. And if you have any questions, please.
Any questions? Do we have any questions or perhaps feature requests for the
I got
speaker?
lots of feature requests.
Oh, yeah, go ahead. Yeah.
How much of what you've written would work outside of VS Code?
That's also a very good question. And another thing I forgot to mention. So, as I said, a lot of the magic is are calls to task.sh with a specific argument, like task.sh start, task.sh SSH, task.sh stop, push, pull, shoot, whatever. So actually, you can just have an alias in your bash RC or wherever you want to task.sh, and then any command there you can run from a terminal anywhere. So yeah.
Specifically eyeballing the integration you have with, I don't know if it was Lore or Patchwork, but pulling down different revisions and specifically like tracking across multiple versions of the same series to see how it's evolved. Does your tooling lend itself to that, or is that something else entirely?
Not at all. These are, if you want really a full good control over the VS Code UI, you need to buy into this VS Code ecosystem of extensions. You need to write them in TypeScript, and you have access to nice APIs, but it's highly VS Code specific. Okay. And for example, it uses APIs to store workspace specific information, branch specific information. So I don't see how you could access it outside of VS Code, unfortunately.
B4 has some similar features outside of VS Code, but not identical, I think. One other thing I wanted to ask is how quickly do those compile test cycles tend to happen? And have you considered using slightly scary things like user mode Linux to have a quick way of checking things still compile and at least boot?
That's also a super interesting question. I would love to dive more into it, but I try to take a non-opinionated approach to kernel development and stick to the basics of probably you're using defconfig, probably you're just using a vanilla Debian, probably you just stick with a normal setup. So I haven't really played too much with exotic use cases where you know that, or let's say, I think playing with is it KUnit?
Yeah.
KUnit has amazing features as well that I would really like to play with. I haven't really had the chance because my work doesn't.
So you showed in one of the configs you could set target arch equals ARM64. challenge. Try target arch equals and try to get that working. And I think that'll make David happy.
That's a
feature request. A lot of times I like these user space images that we're going to boot in a VM. It's a pain when you want to add things into them, and maybe you can SCP them in now if you have SSH. That's nice.
There's already that. You already have test.sh push,
Yep.
test.sh pull, and truth.
Because like a common thing is I want to put these KOs of these
Yep.
modules like into the VM or something like that. And
Damn, there's another thing I forgot to show as well.
Okay.
So from within the VM, you have a /host mount by default, and you can access your host
Perfect.
from the VM.
Beautiful. That's really nice.
So it's using 9PFS. There was a pretty interesting talk today about virtme ng, where I look more into this when I have time. Yeah, you have. They talk a lot about.
Are there issues though where like if the guest wasn't configured with those drivers, it just like it's broken, and no one knows why?
Yeah, so the reason why I stick with 9PFS is because make defconfig enables 9PFS. So you don't have to do any weird.
But like the user could have done like a rand config, and 9PFS has been turned off, and then they're like, "Why is it not working?"
If you disable a bunch of things, you might start to miss some features. But it's like saying, "Yeah, I disabled net, and now SSH doesn't work."
Yeah, I just wish there was like some better way of it telling me like, "Yo, you forgot to turn on this config."
Yeah, that's something we could probably do.
For Linux users in general, for every driver. Yeah.
It's also a difficult cursor to keep between. I want to keep this setup simple so that people feel comfortable. That there's not too much layers of abstraction that hides where the features are happening. So yeah, it's difficult to be a bit opinionated, but not too much.
So I have a very basic question. Usually that we send a series of patches, and sometimes there's, for example, 10 patches, but the second patch has something like wrong thing, bugs or something like that. And in that case, that the next version, I need to only update the second one. Can I? How can I do that?
So do you want to change the what is it called, the prefix, the subject prefix, or what is it?
No, just what's it, the code has some issues. Yes.
Okay, yeah, that's a very good question. It's also something that I find myself doing all the time. And currently with the extension I showed, you have this interactive rebase. And what I do is I just do interactive rebase, edit the one patch I'm interested in, and that's how I do it. But it's true, it's so common, such a thing I would really like to improve.
Yeah, about, I guess, this topic. I use a lot of stack git, and it helps a lot to, well, it's kind of a git rebase interactive, but much more powerful, but quicker to get to the point. So that would be really nice to have such an integration with your set of tools. And so we talk about UML. I use both virtual machines and UML to test some kind of features. And one thing I find really useful with UML is that you can rely on the hostfs file system. So this way, I have a script which is on GitHub actually, and so it enables you to run your own kernel with the exact file system you're running on the host, kind of, and it's really quick. So it's really easy to run any self-test or whatever, just running the same kernel that you will run on your host. So yeah, that might also be another lead.
I think that's the approach that virtme takes to reuse the host file system. Actually, quite interestingly, today on this virtme ng talk, the speaker talked about some issues they had with running systemd, because systemd keeps some state in the file system, and when you run systemd again on the same file system, it finds that it's already running and it freaks out.
Yeah.
So I find it easier to have an isolated system on which I can install all sorts of crazy garbage.
Yeah. Actually, I kind of rely on the host system to run the command. And so, for instance, if on your system you have systemd, it kind of use the systemd units, and most of the case it works because systemd detects that it's running on a kind of virtual environment. So yeah.
Okay.
Can I probably time for one more question?
Okay.
Hi.
Yeah, sorry.
What's your experience when editing header files with VS Code and ClangD? In my experience, if your project does not use like strict include what you use, it's just get a lot of squiggly lines and.
Yeah, it's also a very good question because ClangD knows how to parse a file from a command line, and C, that's really how C works, right? If you write an inc file, something that you intend to be included from somewhere else, and the file that includes this will have extra define or extra include, then ClangD will get confused and not know how to parse the file. So it happens sometimes. I didn't come here to complain, so I didn't do it, but now that I get a chance, I'll do it. It would be great, from my perspective at least, if every C file was an independent compilation unit. And some of these C files, if you try to open them with ClangD, you find that they don't parse because they are never compiled independently. They are meant to be included from a broader context. So yeah, I'm out of time, I think. Thank you.
And let me know when to start.
The last talk of the day, so you can take as long as you want.
Alex will be basically going
Oh, okay, folks, I think we're going to get started here. Heads up, we got another speaker.
Okay. Right, should I start? Right. Hi, everyone. My name is Surem Bagdasarian. I'll be presenting call site trampolines, and my co-presenters are Steven Rosted and Alexey Vetrov. So, let's see if it works. Okay.
Or you can use the arrow keys.
Okay, got it. All right, so I'll present the call site trampolines ideas and current applications and implementation. And the goal of the talk basically is to gauge the interest of the compiler community for this feature, explore some possible new applications for it, and also discuss the implementation details that we have. So first, the motivations. I was recently working on a memory allocation profiling feature, which the goal is basically to account for every allocated byte in the kernel. And that includes page allocations, lab allocations, per CPU allocations, VM allocs, and so on. So to do that, we naturally need to account for, at the call sites, how much memory did we allocate, how many times we allocated that location. And to do that, we are instrumenting the allocators, which are quite a number of them in the kernel. So for that, we need to instrument our code at the allocation call site with some data which would represent how much memory was allocated, and also to represent the location in the source code of that call. So the location is generic data. We call it call tag, which basically has file name, source file name, line number, and module name. And it is wrapped into the application-specific data. In our example, memory profiling, it's basically how many bytes were allocated at that location and how many call sites happened at that location. Let's see. So that data is injected at compile time, obviously, and it's placed into the array so that we can easily iterate over them. So they are allocated in a specific section.
Question, is it like called KMAP?
Right. Yeah.
This information, file line module.
Right. So at every call to the kmalloc, we want to basically inject some small data structure which contains information about that location plus counters like how many bytes we allocated and ultimately how many times we allocated at that location. Allocations from the modules are also covered basically because we are instrumenting those allocators. Let's see. So this is the memory allocation profiling is the biggest application right now, but we have also working examples of dynamic fault injection. Basically, we can at runtime we can specify which allocation we want to fail, so that we can test how we handle those failures. We can have latency tracking. Basically, again at runtime we can specify which specific code paths we want to measure the latency for, and error source tracking, that's an interesting one. So let's say if your function returns like e in val, and there are several places where that code can be returned, by enabling this we can find out which exact code location actually generated that error. And the code tagging framework is actually generic enough. As I said, it's a code tag plus application specific structure which wraps it. So additional applications are very easy to implement once that framework is in. I did post the latest version just recently. There is a link in the presentation if anybody wants to look at the implementations. That's like 39 patches. And this is what current implementation looks like. We are using macros basically to inject this code. And the macro takes allocation function as a parameter. So do alloc basically. It's a alloc hook is a macro which takes allocation as a allocator as a parameter. Define alloc tag here. I skipped the details, but what it does basically it defines a static structure which includes all that information like code location and counters. It also stores a reference to that structure in the current task structure so that later on the actual allocator can increment those counters. And it also stores the current reference into the old so that we can restore it later if there are nested calls to this function. Basically, we can recover the previous alloc tag reference from the current task. The second line is basically calling the allocation, and the third one is restoring the old pointer to the alloc tag. And this is how we instrument the actual allocator. So kmalloc node is the actual Linux kernel one of the slab allocators. So we basically redefine it as a macro, and we need to rename the original implementation, and we wrap it into this macro, alloc hook macro. So this way, every time Linux kernel calls kmalloc alloc node, basically we inject static structure, we implement this logic to store a reference to that structure, and when the allocation happens, we increment the counters and so on. There's also some additional references so that we can during the free we can decrement those counters, but this is outside of the scope of this talk. So when I was upstreaming this, it became obvious that in this instrumentation, macro-based instrumentation is quite invasive because Linux kernel has lots of allocators, especially slab allocations. So Main concern was code pollution. Basically, lots of headers need to be changed. Lots of macros, which are not very readable. So a better way is needed, basically. Also, we have name collisions. So if, let's say, I redefine page alloc pages, for example, as a macro, then we have a structure like something ops, which has alloc pages. Then preprocessor will change that according to the macro, and compiler will not really like it. So we have all those issues. So bottom line is upstream feedback is changes to something much more readable and easier. And here we go to the Steven's proposal to implement basically call side trampolines, and I'll let Steven present that.
So at LSFF when this was being proposed, there was the MM maintainers came to me and said, Steve, is there a way that we could do this like with like static calls? So a lot of people know me as being like loving to do strange things with the kernel that, you know, like modifying text and stuff like that, since I've been involved with almost every single thing that does like modification within the kernel at runtime. So self-modifying code. And I sat down and I thought about the whole situation, and I said, you know, if we had a way to at least say, where is every single call site of kmalloc? So if I were to say, tell GCC during the compilation, everything, give me an address of this site when it's called, we could then possibly change the call site to be like a jump or something. And also, it would be also great if we were able to say, hey, by the way, I want to automatically create a trampoline with maybe some C code, and it will create the trampoline as well that it will call to. But the funny part is it might, well, if we use a jump, then we may have to play some more tricks, because we may have to create a trampoline for every single call site as well, which is okay. We don't mind the code side. This will be compiled .time options. So the idea is this. I will just base work. No, it doesn't. I have to go click the arrow here. Oh, that one does. Okay, so I should know this. Anyway, so the idea is, let's say, one thing is, let's say we patched everything to change the calls to kmalloc to a jump to a trampoline, so that K1 and K2. And then what would happen is it would then, well, it'd be like this. It would jump to K1, and then this trampoline would have the code tag before and after the call. So it does the beginning of the code tag, and inside the trampoline, it calls the actual kmalloc. And then kmalloc jumps back to the trampoline to do the ending part of it, and then it jumps back to the user. So if it's possible that we could have the compiler help us to do this, then everyone in the memory management loved this idea, because it doesn't touch the current code. It's something that's added. And then we could also do this anything. It doesn't have to just be kmalloc and memory management. We could do this with the scheduler. We could do this with anything. So if we have this infrastructure, we could just say, okay, give me this function I want, and then I do the work on top of it, and let everyone else figure out how to do that. But it's not, the goal is not to be intrusive to the subsystem that we're attaching to, where the other way with the macros is very intrusive. You have to change names of functions. You have to do that. And that was where everyone balked, and they didn't want to do that. So does that everyone understand the idea? Do you want to continue? Or?
Yeah. And now Alexei will present implementation for Clang. So we have basically a working proof of concept. And Alexei, are you with us?
Is the mute on? Is it remote?
Yeah, Alexei is joining from UK, so he will be.
Do you have a chat there?
Yes.
Oh no.
Looks like. Well, it's spinning. Right. Alexei, can you hear us? Okay, it looks like he can hear us, but we can't hear.
Yeah, the chat is not working. Yeah.
All right, 1 second. We're just trying to get his audio working.
Okay.
he showing up as a bubble?
Yes. He's the presenter right now.
He's presented, but it's not showing up as a bubble, so it's maybe on his end.
Alexei, can you say something? Let's check if we can hear you.
Yeah, because otherwise it would show up as a bubble. It's not showing up as he's connected. It would show up as when you log in. It would show up here as a bubble. His name would show up here. If he's
maximize this.
So
does he have to do it that way for the demo?
I thought it was with headphones if they're audio only, but he's got the mic. Yes, but it's not his microphone, his sound.
But he's in the chat and he's with
Because
the
otherwise it would show
webcam
up.
working and he stops speaking.
Oh, that's why it's his side. You may have to try to.
It's his side.
It's on his side. It's on his side. I can actually test real quick for mine. If you hear me, then you know it's just to show you.
Okay, I think he's reconnecting.
I tried
Oh, you hear?
Yeah, looks like we can hear you now.
Oh yeah, finally. I just reloaded the window.
Okay.
Okay, go ahead.
Okay. Hello everyone. My name is Alexei Petrov, and I have implemented the proof of concept of the idea of call-side trampolines in cloud, or as I call it, it's call-side wrapper. On this slide, you can see a usage example for new edit attributes to the compiler. First, you can see a wrapper definition, which starts with a call-side wrapper keyword. It's not an attribute, but a keyword, and I will explain later why it's so. And when compiler sees a keyword, the whole function becomes a template with some type and non-type constants available. For example, now the wrapper have access to call-side file, call-side line, and now wrapper have access to the actual callee which you want to wrap, like kmalloc. And the wrapper has access to arguments and return type. Actually, you may notice ellipses, the 3 points, which means that this argument is not just one argument, but it may be any number of arguments. And the only change in the code of MM will be adding this attribute near the function that we want to wrap. So this attribute is call-side wrapped by, and the only argument it has is the wrapper. And because wrapper is a template, it can accept any callee, any number of arguments, any return type. So actually, you may use the one wrapper for any number of functions. And what happens when you attach this attribute to the function you want to wrap? After that, compiler will replace all calls to the wrapped function to the wrapper instantiation. So actually, it will be not foo, but wrapper instantiated with foo as the callee argument. Even more, you can get a pointer. You can get an address of this wrapper. In this example, you see foo pointer, and it's equal to the point. It's equal to the pointer of foo, but actually, it's not pointed to the foo. It's pointed to instantiation of the wrapper at this exact point. So when you call foo pointer, it will still be monitored by the wrapper. The only difference that the line and file will be at the point where pointer was created. So it will be a little bit, maybe a little bit off, but at least it is at least something that works for the pointer. The macros approach will not work for the pointer at all. Okay, and also please notice the static variable inside the wrapper. As Surin said before, we use static variable to collect call-side data, and actually this variable is allocated in the special section of the ELF. And this section we can actually read from, we can read with any other function and collect call-side data information. And the important difference for the call-side wrapper is that it's template, and every template instantiation will have the unique static variable. Let's imagine that this wrapper is not a template, and it just accepts an argument like file line pointed to the function. If it is not a template, there will be only one static variable for each call site, and there will be no way to create and allocate separate static variable for each call site. So that is one of the reasons why templates are used. So let's move to the implementation details. As I said on the previous slide, a call site wrapper transforms the function into a template. If we were in C++, it may look like this. So it has a lot of parameters, and the first parameter is the callee. So it's basically the function foo, which will be wrapped, or any allocation or something else. These parameters is passed to the template explicitly. And all other parameters are deduced from either call site or from the call itself. For example, arguments. You may also notice the ... It is actually a template pack that contains all the types of all arguments. And you can use this template pack in arguments that pass into the wrapper. And using these arguments and the callee, we deduce the type for return, like the return type. And also something like that, we may deduce a line, function, or any other call site information. So when you attach an attribute to a wrapped function, it just replaces your call to foo with a wrapper foo. So let's sum up why we are using templates and what are implications of this. The main reason is to have everything substituted in compile time. So everything is static, and we don't spend any time doing it runtime. We don't spend time for looking for allocating place for call site wrappers. We don't spend time for looking for the for the structure to collect for the structure for this exact call site. Everything is in static, so the result in machine code is actually very small. We know the address of the static variable, and we just increase counter or add the number of bytes allocated. And the result will be very fast to execute. And also, advantage of using templates is that every instantiation of this template is addressable, and you can take a pointer of it. So a call site wrapper is able to track calls through the pointers. And like I said before, every instantiation, every specialization of this template has its own scope for any static variables that are inside of it. And these static variables are instantiated independently for each call site. Okay, templates are cool, but we are coding in C, right? No templates. And we also, like in previous slide, I showed the usage of ellipses or 3 dots to forward all arguments past the wrapper to the wrapped function. However, these 3 dots means different thing in C and C++. In C, it means variable arguments. So we want some solution that does not mess with C standard and does not change parser or semantics too much. So how exactly we introduced templates into the C mode without breaking everything? In fact, Clang internally has the same machinery for compiling C and C++ code. And the difference is hidden under multiple if cases, like the one in the end of the slide. In this case, is check whether we are in C or C++ mode and enables or disables some parts of the code. So what we did is that when parser sees this call site wrapper keyword, it does multiple things. First of all, it sets an internal flag on the declaration, on the function of the wrapper that marks this wrapper like that this flag that can be accessed at any part of Clang pipeline. So when you have when you have block of the code that works only in C++, you just add a new condition. So if this declaration is call site wrapper, then we enable this chunk of code. And now we have some C++ code enabled when we are parsing or generating code for C. Also, this keyword creates a template parameter, like on the slides here. It creates this thing with all the template parameters and adds these parameters to the declaration scope, so they can be accessed only in the declaration, not outside. So now that we have a template, we just need to enable some C++ code. But like we wanted to enable only parts of C++ code, because if you just enable C++ mode inside the function, you may find a lot of unexpected things. For example, some user may try to instantiate a class or exception or something else. We don't want to blindly enable all C++. So with this thing, with this flag, we enable only parts that we need for templates to work. Okay, now we have a wrapper, which is template. How do we call it instead of a function? Every time a function is being called, there is a lookup stage when we have a name of the function, and we want to find an actual function generated function node in the syntax tree. So we changed a little bit lookup code. And now when we look up a function that has this attribute wrapped by, now when we find this function, we replace it with template instantiation of a wrapper with the parameter of the function. So when someone, for example, pointer address generation or call generation sees a function that should be wrapped, it finds, instead of this function, just a wrapper instantiated with the function. And now everything works fine, but still there are few issues that we need to figure out. First of all, is that we put explicitly only the function that is wrapped inside a template instantiation. But actually, we have a lot of other parameters like arguments, return type, and so on. And I lie to you on this slide. This code will not work in C++. Because of few issues. For example, you see call site line equal to built-in line or equal to some macros underscore line underscore. If you try to do it like this, it will just put the line where this code is located. Just put one line of the wrapper, the line of the location of the wrapper. But we need call site line and call site file and call site function. So there is no such thing in C++, and we have to implement it ourselves. And the other thing is this return type. You cannot write this decal type in C++ because of this template pack parameter. Like this will not compile and is not allowed in C++. So the return type deduction is also made manually. And so we went to the code that deduces parameters and implemented extraction of call site information from location of the like from the location of the call. We also deduce return type manually, and the only thing that is deduced automatically by C++ code is the args themselves. They are deduced from arguments, and we need to do nothing for this to work. And the last problem left is name mangling. In C++, name mangling is used to separate names for overridden functions or for template instantiation. But in C, there is no such thing. There is no function override. There is no templates. So in C, name mangling is disabled unconditionally. But we can do the same thing as we did before. If we see a declaration with a wrapper flag, we just enable mangling for this declaration and all static variables that contained inside. And after that, we will reap the benefits of using templates, because C++ already have this code implemented. C++ already can encode all arguments from the instantiation, from all template arguments into the mangled name. And all call site specific arguments are already in template. So you see, we have a wrapper, we have a function that we wrapped, we even have a line number here. And the only problem that C++ code does not solve is mangling of constant string, like file name. C++ does not really support string constants passed as non-type template parameters, and does not have good mangling for it. In fact, the only thing it puts in a mangled name is the length of the string. However, it's not a problem, really, because these wrapper instantiations are used only locally. They are used only the compile unit in the file that we are currently compiling. And they are usually just inlined. Like only in case of pointer, they are not inlined, but generation is simple. But we don't have one definition rule in C, so it's not a problem if multiple compile units have declaration with the same names. So basically, we don't need to separate functions by the file name. We only need line, we only need wrapped function, and that's all already supported. Okay, so that's all for the implementation. But you may ask a question: is this the only way it can be implemented or not? Have we considered any alternatives? So one alternative was preprocessor macro, as Suren described on slide 4. But the main problem is that preprocessor macro does not know code semantics, and it may mistake a function with a structure field with the same name. And you also have to rename the original function, which may be problematic if you need to have stable ABI for the modules. And so we actually thought about another alternative that will be an instrumentation that lives outside of the compiler and does the code transformation before it is compiled. And that's actually not a bad solution. The main advantage in this approach will be that it will be independent from the compiler. After the transformation, you can compile the code with Clang or even GCC. But in our approach that I described slide before, the only supported compiler is now Clang. Unfortunately, we did not implement GCC support yet. But if this approach gains traction, we might actually do it also. And but this Clang tooling, this code transformation is also not a perfect solution. It has its own flaws, like you have to distribute this tool somehow. Will you put it as a binary in all the Linux distributions, or you put it as source in the kernel? But if you write a solution based on Clang tooling, you have to put either the whole LLVM or like tell users to have LLVM development package installed in the system, and it actually may have a license that is incompatible with kernel. And another problem with the solution that you have to implement everything by your own. You have to implement template instantiation. You have to implement name angling and all of the stuff that we just reused from C++ in our approach, where we modified the compiler. Yes, our approach has its own disadvantages. And one of the disadvantages is that what we currently implemented, the proof of concept, is not yet ready to be upstreamed. It needs a lot of cleanup. It needs check, I commented some assertions that it's in C++ code or something like that. So it should be re-implemented cleanly. But I'm open to any suggestions to the proposed design or to the implementations. So feel free to ask any questions. And I think that's all for me. Thank you.
Okay, I mean, the wrappers that you are defining, why do you need them to be so generic, other than convenience? Like,
okay,
my point is, it seems to me that a lot of the C++ hocus pocus here, it's because you need those wrappers, those static inline functions to be generic, basically, right? Like the arguments.
Yes.
Then the template that you are using behind the curtains are basically passing those arguments to whatever function you are wrapping. But it's not the payload. It's not the payload in this case. This call site data counter pretty specific to the function that you are wrapping.
Yes. So you actually may have.
Yeah. What I'm wondering is that maybe you could use like C macros on the wrapper definition side.
Yes.
Then you could still have like clean call sites, right? And you can, maybe you will not need to use all those C++ compiler features to define the wrappers.
So with the generic wrapper approach, basically, let's say we have 10 different allocators, k-malloc versions, which with different parameters, right? With one generic approach, we can basically use the same wrapper for all of them. If we changing, for example, one of the issues was this variable arguments. If we are changing it to more like, okay, we have wrapper for 5 parameters, for 3 parameters, for 4 parameters.
Yeah, I understand, but you have variable arguments features in C macros, like
So
VA args.
Right.
So I understand that in your case, on the wrapper definition side, it will be annoying to have to define one wrapper for every function you want to wrap, right? Like k-alloc or any other. So I was wondering, if you use the C preprocessor on the wrapper definition side, so you don't have to manually define, a wrapper per function you want to wrap, maybe it will be enough, so you don't have to resort to C++ templates.
I think as long as in the source code, in the kernel source code, we don't have to change the definitions of the functions much. So in this case, we are basically just adding like it's a call site wrapper, and basically just the name of the wrapper, right? So on the right side, you can see like attribute, call site wrapper, and so on. So as long as we can keep the changes to the source code to the minimum like this, whatever happens in the call site wrapper definition, we can play some tricks with macros or some other ways. The goal is to keep the original code as clean as possible.
Yeah. I have some questions. Actually, that's some comment and some questions about that. I think that if I'm not sure that your final the feature or what you need to do, but if you wanna make this one kernel interface or something like that, how do you think that get that result of this profiling? if you expose that profiling,
So
there.
how this information is exposed to the user space?
Yes.
Right. We use procfs node basically, and when you read from the procfs, it basically says, okay, this many bytes, this many calls were allocated at this location, the file, module name, line number, and so on.
Yeah.
So user space tools basically can monitor it from time to time and regularly and see, is there any allocation which constantly grows? That would be a good good point to start looking for leaks, for example.
In that case, that you don't need to use that. One thing is you don't need to use that file name path or something like that, because that it depends on the compiling environment. So that it's better to use that symbol and what's it, the symbol plus offset or something like that. That could, because that user space tool can decode that, and also if you export that those information from the kernel, that is the kernel. What's it? The kernel developers know that that will be exposed. In that case, that you can expand that your the call site function or something like so that are using that the macros for each what's the allocator. It's better to understand better to get a more understanding font, because that if you for example this one actually that we can make it similar feature by using that ftrace the trace event or something like that.
Sure.
But if you are how I say that embed that that's the feature inside of the kernel instead of using that user space tools from via ftrace or something like that. In that case, that is a part of the kernel feature, so that you can you're good to expand that the current kernel code, I think. Because that in that case that the user can not the user that the developer, kernel developer and the maintainer can understand how it works, but in a with the working with the compiler feature, we don't usually that to understand how it works, we need to know that how the compiler works too.
There's not much to know how compiler works, because the call site, the trampoline code is also exposed in the source code, so you can see exactly what's injected. Then your question about exposing symbols to the file name and so on, we wanted user reader human readable form, so that you don't need to okay, you got this information, you need to process with this tool, then go to another tool, and kind of you also need the source image to convert those to actually source code online. So we wanted something that is actually usable by the end user right away without going through additional hoops. That's about the interface that we came up with. Implementation of ftrace, yes, it's possible. It's less performant, and one of our goals, and that has been discussed during LSFMM. One of our goals is the minimum overhead, performance overhead, because we want to deploy this in the field. The issues that we're trying to solve with this is some, let's say, weird memory leak, which happens once in a while in the fleet of millions of devices, and you can't reproduce it locally. So you need that additional information right there when it happens, right? For that to be deployable in the fleet, you need minimum overhead, performance overhead. That's why we are kind of trying to generate everything at compile time. Ftrace would require you to have dynamically linking at runtime, linking this allocation tag to your call using the red IP or something like this, and that adds overhead, which we are trying to avoid basically.
Yeah.
So jumping back onto Jose's point about basically dropping all of the templates and making it like pure C code. if you do that, and then kind of backtracking to the original problem that you're trying to solve, which is to track memory allocations, you already have an attribute called alloc size, which should be associated with every allocator function in the kernel. So combining the alloc size and the wrappers, it seems to me like you could basically write a compiler plugin and not have to change the compiler itself to kind of implement all of this. Have you considered that idea?
Yeah. If we can generate, again, the main issue here, we need to generate not only the logic, but the data structure at every call site. If we can do that,
In a plugin, I reckon you should be able to do that with
okay.
With
Yeah,
the
yeah,
so you're
we can
basically
try it if it works.
yeah you're basically using, instead of the alloc size attribute, you're using the call site wrap by attribute. So if you in this kind of framework, if you replace call site wrap by with alloc size, and you extend it to also like include wrapper information in there, you should be able to associate the two and build it through a plugin instead of having to patch the compiler proper to do that.
Okay, we can explore that. I'm not very familiar with those compiler-specific things. Probably Nick and Alexei will be in better position to reply to that, but we can explore that.
Yeah.
Yeah, I'm interested in a new use case to annotate all call site of kernel lock functions. We have similar issue with lock contention. Sometimes it's hard to know which lock or where is holding or contending the locks. So there are lock contention trace point, which is it can be enabled on production environment, not like locked up. But the problem is that the trace point has symbols for the locks. Right now, we are using the call stacks to figure out which lock is called from this path. But ideally, we want to have symbols for these lock instances, which locked up trace points support already. So if we use this call site trampoline things, can add some symbols for the locks. Like if we can use preprocessor macro approach, we can symbolize the argument of preprocessors, like adding hash signs.
Yeah, if you have access to original images, then you can understand that symbols, and yeah, with call site tagging, you can also do that.
Yeah, but I'm not sure this is possible with this approach.
Right. Basically, you will wrap a different structure with so alloc tagging that we are doing here. Alloc tag is basically counters plus a code tag, which represents a position as a code. So in your case, it will be code tag plus your structure, which includes the symbol for the lock. So yeah, it is possible.
Cool.
Just to be clear, I was not suggesting to basically drop in all this and go back to a pure macro implementation. My point was that the attribute call site wrap by is on the point, but it's on all this dynamic aspect of the wrapper itself. Maybe it could be used macros for.
Yeah, I just wanted to say that like it's not only used for wrapping, like for generic functions, for generic arguments. It's also used to deduce this file and line. If you, for example, you have instead of call site wrap by wrapper, call site wrap by some macro, then this macro will only have file and line from this macro, but it will not have file and line information or any call site information, because it was basically implemented by passing call site information through template parameters to the wrapper. So template parameters are also used to pass call site information, which is not possible with macro.
So one thing, I've been a bit confused up until I think some of the comments you made just in the last moment. Hello? Sorry. So I was going to say, I've been a bit confused throughout the presentation because you said really early on that one of the things you didn't want to do is like change all the code in the call site, right? But we already do that for a bunch of things today. Like, for example, whether or not using KASAN, we go and rewrite a bunch of the things like the wrappers for all of the string ops and so on. I think one of the things you said later on indicated actually there's a slight difference here, which is that it sounds like this is not necessarily a thing you're going to use for everything upstream, but it's something you want to hack in at the last moment with minimal invasive changes. Is that a correct assessment of?
No, this is something we want upstream.
So what I mean is that you said like you wanted to use this in your fleet because you're trying to diagnose one thing.
Like,
So
is
it's
it a
not
one-
necessarily that the actual site that you want to add the trace point in would always have the trace point information you want in there. That's something you want to add in at the last moment. Is that?
Maybe I'll read when you read.
Here.
I think maybe I can reword what you're kind of trying to ask. Yes, I think something is like for K-Malik, they want their upstream and never touch, put in, boom, boom, and with the least invasiveness in there. But it sounds like what you're saying is, say if it was last minute, I'm like, hey, like the scheduler is having an issue. I just want to throw something in there. It may not be upstreamable, but I could just slap a simple tag right there, boom, I get the same functionality of everything. Is that kind of like what you're saying?
Sorry, I'm just trying to work out if that's the argument or the justification for why we can't go and change all the call sites. Because we go and change all the call sites today in a bunch of other cases, and it's much simpler to have all of that like with a slightly different name in the real implementation, a header file that wraps that with C macros, whatever. But also you can, if you need to pass additional information, you can go and pass that in like registers and so on. Whereas these wrappers, because they've got the same prototype for the wrapper and the real call site, they can't pass additional information. They're gonna have to store it somewhere globally.
That's what they're doing with the static variables. Right? So that's why it's like templates of punching out copies of these functions where they all have static variables to restore them. So
yeah, sure. Whereas
like,
I think in a lot of cases where you want the call, where you may want the call site information for something upstream, actually really want to pass that like an implicit argument rather than have some global variable that you have to go and shove it in, and then the caller has to go and extract that out.
So I feel like, when I close my eyes and think of like, what's the prior art here? I can't help but think of Fortify and like passing along the object size or the built-in object size as like an implicit parameter where we have all these calls to memcopy and no one wants to rewrite 10 million calls to memcopy to pass 2 additional parameters for like what's the size of the source and the destination.
Yep.
So instead, we have all this complex machinery to implicitly pass additional parameters. So I'm kind of curious because I feel like this is incredible that you got this working. I am slightly horrified at like the C++ templates in C aspect. I'm amazed. Congrats. Okay, next part. Can we pass the file inline information along as arguments and like have always inline or something like that where like,
I think
the thing I'm very nervous, like I also like your final slide where you said we have this third idea for the tooling approach. I would encourage you to play with that as well because you don't need to ask for permission from any compiler vendor. This, you're going to have to ask for permission from compiler vendors and uh-oh.
Yeah, sorry,
It just means we have to implement it right?
Yeah, so one other thing on that front is that if this is passed through a wrapper as an additional argument, that you can make that work with existing tool chains, which means that if you get it upstream, it works everywhere today, not on new version of toolchain. Half the world doesn't have it for 5 years, etc.
The problem with passing file and line as argument is that we will have one static variable. Like we want to clone static variables for every file and every line. And like this is
that you pass the pointer to that code tag as an argument. You instantiate that per call for a macro. In your call site, in your real implementation, you have that as an argument.
Okay, this is a good idea actually, but I see.
So I was thinking of a slightly different approach, and let me know why this doesn't work. But like outside of the compiler, like if you just take the VM Linux binary, you have line information and all that already in that. And from the binary itself, you know what all the call sites are. So in theory, you could process the whole binary, build a table, and link that along with the existing binary. And then, that table would have all the call site information. and then you do what Steve was suggesting, which is once you know all the call sites, you can then, patch them in the like after the kernel boots, patch them and have them jump to the trampoline, and then you can. And then later, you don't have the line information at that point, but later you can take those counters and make sense out of them with the VM Linux dwarf.
Sure, if you have access to VM.
So that actually just reminded me, one thing that came up that was a feature request from LSFFMM was that like sometimes you boot up and you like want to find your memory leaks or whatever, and then like, okay, I found it, got the information, I don't want to reboot the machine, boom, just turn it off by actually call patching all the sites again back to the normal function calls. So it's actually one of the things to say, well, we could do a live, not just turning it on, but because they said a lot of this stuff needs to be recorded from boot up, but to be able to turn it off once you got enough information, and then you're back full 100% in performance.
Yeah, and the other advantage of this is you don't have any extra instructions, and there's no overhead, there's no wrappers, no macros, no compiler support. Yeah, it just feels like it's more like people who don't care about this stuff will have the same binary as before, and then it.
Sure, yeah.
Yeah.
So Coltrane trampoline was that idea.
Yeah.
We just thought that having basically using compilers to do that and replace, basically removing the dependency on additional tools, which would need to go and do the systematization would be more advantageous.
And I mean, it's just, additional tools, but like I said, if the compiler people don't do it, we have stuff like ops tool and stuff like that that actually just goes through and we'll do it for you.
Yeah.
So we'll write an external tool that analyzes the code and say, okay, we'll create the long trampolines and, separately and everything else and just link it in. I mean, so basically we could link in a table of all the call sites, link in the trampolines for all the call sites into like the VM Linux. And then when you boot up, you say, oh, here's all the call sites, patch them to jump to the trampoline.
So then we need to generate also those structures, right? Which we don't know beforehand how many of them we need to generate because we don't know how many call sites are there.
Well, no, I mean, the tool will actually generate it.
I think you need to parse a lot of dwarf information to make this work, to understand which part of the code attached to which part of the machine code.
Yeah, I just say that if we start from the x86, we can use the object tool to find the core site.
So you're familiar with ops tool, I'm assuming. Yeah. So I mean, say if you basically, this is one of the things I was thinking about. If you had the information, if you're able to make a template or something, start off with a template, pass it to like an ops tool type of utility that goes in, finds all the call sites, give you a section with all the call sites saying, here's where you have to patch. And maybe with information about, and with that, another table which actually has, takes the template, converts it to like the trampoline that you would have, go through all the information that would add information and then link that, it will compile it separately and then link it all in. And at boot up, you could do all the patching and whatever. Or
you can basically limit all the changes to the compiler just to this attribute, which assigns something, like put something in the machine code that will be used by separate tool to patch this. Yeah, sure. It's less intrusive to the compiler.
I was going to say, I think generating all those trampolines and patching them, that's not going to end up working on ARM64 because of branch range limitations and all the usual fun we have with that. We need something explicit at compile time before you have the object. We can do a load of things, but I think there are a lot of options that we can do with existing compiler support. And there's like one thing that we can do today is if the cost of actually looking up the caller can be higher in this. We can go look at the return address, go and index into a table, binary search, etc. Now that's obviously expensive, but we can limit. There are things that we can do to make that faster. And if the whole thing is, I want to have a single binary that just works all the time, and this is off by default, and it runs fast, and when we enable, we can enable it and disable it. We can do things like that relatively easily today.
The goal is to have it running in the fleet, because we don't know when the problem happens, when we need to turn it on, right?
Okay, at which point, why do you need the trampolines? Just, you're always passing it. Sorry, to
Yeah.
Stephen's point, not to.
Right, but then your suggestion to use like indexing would be not as performant as generating it at compile time.
Sure, but then my other suggestion of you pass the thing as an implicit argument is going to be better anyway, right?
But explicit arguments will not instantiate a separate static variable for you.
Could you expand on that, Alexei?
Yes, when we pass file and line as a template argument, there will be separate static variables for each call site.
Sure, but imagine you have in a header a static always inline function. Within that function, you go and create this in the same way because you have access to that information. You put that into a static variable, which is scoped within that function. You take a pointer to that variable and you pass that as an extra parameter to the real function invocation. Generating the code to get the address of that is really simple. On ARM64, that's an ADR or an ADRP plus add. Putting that in a register is really cheap. Now the callee has that immediately. So it can do whatever it wants to it, or if you want to manipulate that in the trampoline, you can do that. But you can do that with existing compiler support. The painful bit is the two things relative to this is the callee has to have a different name. I don't think that is a big deal because we have many cases today of wrappers with that naming scheme, and we have idioms that we could use and expand. And the other thing, yeah, it's a bit painful to write those wrappers, but we already know how to do that. I think the macro expansion examples of nesting that you mentioned, yeah, that is painful, but we already have that problem today with our existing scheme. This is going to get knacked by other people.
So about the name, the always inline and maybe weak symbol. I mean, I'm thinking about the naming thing, right? So if you
replacing the names, you mean?
I mean the per call site data storage, which is a static, but you need one per call site. I think the always inline that will give that to you, I guess, right? And but then now the problem is the naming of the function.
You still need to rename the original ones, right? In that case.
Yeah. If you do all of this in the same compilation unit, you cannot use like weak symbols or some dirty trick like that, right? Like you provide your own definition of foo, which is your wrapper. No.
Yeah, that would be very similar to what we had with macros, basically. The biggest pushback was on those renames, basically, that we have to rename so many things.
What I would really recommend is that if you go the compiler support way, don't make it in a way that you require C compilers to actually compile, parts of C++ in order to implement it.
Yeah, no, we understand that this is hacked.
Yeah.
Just for pure proof of concept. And we know that we need to clean solution.
But I agree with Nick, it's very impressive that you got it working. Yeah.
So I have to ask, because I'm a little bit confused by the feedback from the MM folk about renaming a bunch of things, because they already have a set of existing wrappers for memory allocation functions that pass the caller in a few places. So was the complaint that we were adding this to many more places, or it went deeper in the call chain, or what? Because I'm struggling to understand why this is substantially different from what already exists. Why the macro approach is substantially different to that existing approach.
It's sheer number of renames.
Okay, but why did we have to rename so many additional places? Is that because we only have
we have lots of allocators. Just lab allocator has like versions of.
Okay, my understanding was a bunch of those already had macro wrappers. So maybe that's only a small subset of the ones that exist, and you're expanding it to more, and I've just missed that, or Joel is going to correct me.
But it's also not like future proof, right? Like now you have new use cases. Again, you need more macros and renaming and all that. So it might work for Kmalloc, but
Sure. What do you do when you have a new use case and you want to wrap something that's already wrapped?
no,
Which order do the two wrappers
that's
run?
fine.
et cetera?
But if you see the use cases list, right? He had many use cases. This is not the only use case. It's not only for memory management. So
I mean, we can add additional different use cases, and we implement this as frameworks that other people can use for other use cases. As I said, the only generic part is code tag, which identifies the code, but you can wrap it into different structures which represent different things. Like,
Sure, and I have use cases for a similar mechanism, which is not listed on this slide. But I think that some of those things like dynamic fault injection, speed really should not matter.
That's true.
I think that one is better served by
It's
existing
really
mechanisms.
easy. Once you have like memory profiling,
But it's really easy
to
today
add.
using ftrace, which with regs, which we already have. So
No, well, ftrace, as I said, performance issues. Not fault injection.
I'm just saying, rule out fault injection.
Oh, for fault injection, yeah. If you are interested just in that, sure.
So I feel like because there's this impression that the toolchain community has rejected this, I feel like I should probably elaborate a little bit more in that it seems like the first pass POC that will actually work and solve this immediate problem is write a plugin that works either with Clang or GCC, whichever, doesn't matter, and does all of this without the C++ tricks. Once you get that working, plug in with the alloc size attribute, we can then make that into a general attribute, something like wrapped by, which then both compilers can agree to, and we can actually build a general feature based on that. Like Nick mentioned, you could even write the Fortify wrappers in a similar way. Right now, we have inline functions that. So
yeah, if you go
that's way to stage the whole thing. To me,
if you go the like plugins way, it's even better to write just a separate tool for code transformation. So it will work exactly the same as a plugin, but it will be a separate tool, and you don't need a special compiler version to plug into it. So I think it's better just if instead of plugin, just to use this alternative. And as Nick said, it's really need to be explored in detail.
So the reason why I mentioned plugins is specifically to stage it for the compilers to actually get it in future. That's one. And second, because the kernel already has plugins within its kind of repository and its framework. So it would be something that you would be adding into the kernel and probably maintaining alongside it. So that probably becomes something that's maintainable in the long term instead of something that you do today and then like forget about in a while, or it's something that you kind of end up maintaining downstream.
I think we don't have Clang plugin support in kernel. I think Nick may say something about it.
yeah, but I think the suggestion is not that we do a plugin for the sake of doing plugin. It is try implementing this as a plugin, because if you do that, it demonstrates that the impact on GCC is small. It demonstrates it's possible. It allows us to use it for a while before there is support upstream, and then that gives pressure to the GCC folk and Clang folk to go and implement it.
Okay, now I understand.
Sure, but I think Sadesh's point was there is a style of implementation that would be preferred. It's already possible with plugins. If it's possible if you can do that with a plugin, it demonstrates it's nice and self-contained and so on.
To repeat, so you don't have to touch random bits. You basically prove that you don't have to touch random bits to get this working, and that makes it much easier to get into GCC. And I'm pretty sure it'll be the same for Clang as well, where you can prove that it has a small enough footprint and at the same time is a useful feature to have.
Okay, sounds like
yeah, the containment is very big problem of this solution because it spreads across a lot of if cases and patches a lot of places. It's not self-contained, and it's definitely a point for improvement.
So next step is basically implement this plugin for POC and test that approach.
Nag.
Folks are still gonna nag.
No, I won't promise ag, but I can promise looking at it closely.
Generally, it's helpful to have some way to
Can I hear
insert
you?
a wrapper in
Can I hear you?
Sure. Like it'll definitely be generally useful to programs outside the kernel, I think, to wrap any call, right?
For sure, yes. That's
Right.
that's why I improved my stand from write a plugin to start with a plugin, and then we can build on to something that's more general. Because the plugin is going to solve the immediate problem as well, which is tracking memory allocations, because we already have an attribute to do that. And you
Again,
just have to
they're
build
going to
on
want
top
to
of
use
that.
this stuff for other things other than memory tracking, right?
Right. At that point, we can actually start talking about it, about a new attribute that builds on that. And it's going to be an incremental process at that point, which is
I
a
don't see
smaller
how
delta.
plugin, like people have to prototype with stuff, whether they do it in a plugin or a fork in a patch to show that it's possible. It really doesn't make a difference.
Yeah, I think the key bit of feedback, ignore plugin versus not plugin. I think the key bit of feedback is this needs to be demonstrated in a much simpler way to start off with.
Yeah.
Right?
That's
that.
yeah,
Plugin
that's a fair
was-
way to put it.
Plugin was this, yeah, for example. And I think the reason plugin kept on being said is that we have GCC plugins in the kernel tree today. That has been used to prototype a bunch of features, demonstrate kernel side that,
Which
yeah,
has
we can
built-
actually use
yeah.
it if it's implemented this way. Then that has gone and influenced GCC community and Clang community to actually implement that feature. So I think the suggestion for plugin is not that is what the route we want to go finally, but that's a mechanism to actually get it into a state where we can experiment with it and demonstrate this is actually useful without requiring everyone to go and build a whole new tool chain, which for a bunch of people is a lot more painful than building a plugin.
We do have an event.
I know. That's why I'm trying to move this along so we can get on the bus.
Yeah, but I mean, you don't need a concession for me. I will continue to enact Clang plugin support in the kernel.
Yeah. One more thing before we leave. If you can think about some other applications other than what I presented, or please reach out and let us know, and we'll be happy to hopefully provide a solution for that.
I think.
Sorry?
Oversight droids and
All sites. Oh, trace events. Maybe. Okay. All right. Well, thank you very much.
check, check, check. Check, 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 check. Check, check. Check. Oh. No, I did turn on, right? Oh, man.
Not much. In the dream.
You are both. Yep, there you are. Check, check, check. 1, 2. Cool. They're ready. All my rooms for the day are ready. Fresh batteries in the chat box. Catch box. Call them chat box. Why? And then just took the T out and just said, fuck it.
They do use them for chatting.
Yeah, they actually do. After lunch, my availability is going to be very limited to like the last few minutes of your talkers. I don't know if we're even getting any more wipes for the mics. I'm about to go find out now.
Okay.
If we don't, you got my number. Just hit me whenever any audio issues arise, and I'll just be poking my head.
Sound good.
Yes, sir.
Hopefully it'll get smoothly.
Hopefully nobody is sitting here and run over 45 minutes.
Yeah. I mean, during the day, I don't care. Like the
Right.
last one.
They had to make a point, right?
Was this the only one that went on that long?
Yeah. Everybody else was gone. Like, I think I remember somebody sat there was like, yeah, we're about to miss our last bus.
Yeah. Yeah, you better get out of here.
Right. I'm still befuddled by the appearance of this guy. If you have any reason, you know anything about this?
I don't know. The guys who came in yesterday, like who were in the conference, put that up. So maybe they'll come put up a different one. What is this?
All righty. Well, enjoy your first couple meetings.
All right. Thank you.
No problem.
How's it going? Good. Great day. And yours is still flickering? It's just on here. That's good. Maybe that's what I gotta say. All right, I'm doing. All right, you do.
Hello. Test, test.
All right. So that has a USB 8 port, excuse me. Then I can transfer. USB 8 will be almost fast. Yeah.
It's got an A drive. Got an A drive.
Okay, so if I don't have to, it does, I'll copy it over to the administrator, whatever. Yeah. Pop it in there. All right, great. Okay. And, is this second report? Then we have up to. Anything else? Yeah. Okay. Okay, great. So we got really got people. Yeah, there you go. All right, great. Thank you. Anything else? Okay. All right. Cheers. Let's see. No, we met. Yesterday. All right, good to see you. Yeah. Yeah, we're back. Okay. All right. We're gonna see you guys again. Yeah. This is gonna be, this is, you guys asking questions mostly. Magnolia is just for talk randomly. However long. Yeah, I can do that. Okay. That's fine. By default, I just talk about what's happening with that here and there are some things, so that's. Brooks. Okay, yeah, so I have a question. What's the significance of the Garth Brooks banner? Actually, I was in a taxi and the driver was somebody who used to be part of his entourage. So it was kind of an interesting conversation.
So angry that he raised hotel prices in Dublin back then by
Yeah. Oh, maybe that's
150%.
Okay, that would be it. Very good.
What, $400?
Yeah, well, Dublin was really tough if you want to show up early last year. And usually if you show up at like a little bit before check-in time, you can still get a room. Last year in Dublin, it was just a mess. I mean, the hotels were full because everybody was there for the Garth Brooks concert. And it was a mess. Okay, so we got cash boxes. Good, got that right. So we're done. And I'll put this somewhere. Like maybe back over here. Oh, right, you get it? So, it won't get in the way. All right. So we got a couple more minutes here. Let me know when you're ready. I'm sorry? Yes, let me know when you're ready. Oh, okay. Well, we'll give it a few minutes. I don't need to put that away. I'm not gonna throw my. Yeah, well, give it a few minutes for people to show up. It's I used to be. This is 30 years ago. There was a IEEE computer science chapter in the Portland, Oregon area, and I was kind of in charge of the talks and stuff for it. And it was computers in general, so we had both hardware and software topics. If we had, and the way the talks were structured, there was kind of this half-hour social hour where there'd be like cookies and punch and stuff. And then there'd be an hour-long talk. If we had a hardware topic, everybody would show up right at the beginning of the social hour. You know?
If we had a softer topic, people would kind of start showing up when the talk started. So we kind of had to give it a few minutes on the softer side. So I'm following that tradition today. And yes, people coming out. Actually, you guys aren't there yet. All right. So this will be just kind of a Q&A session. I can talk about what we've done last year. We got of the 6 people beating up an RCU directly, we have 4 of us here today. Yeah, okay, there we are, all are. And so we can talk about that. But the biggest priority is your guys' questions about pretty much anything regarding RCU. I mean, you ask other questions too, and I might not be able to answer them. Maybe Joel, Frederick, or about RCU. All right, front row seat. This guy's great. I like that. I'm sorry? Show off. Oh, okay. You two and him.
For the mics?
Yeah.
Okay, yeah, sure.
I've got the one up there.
Yeah.
And if they have something that one of you guys needs to answer, we'll invite you up here. Okay. Is it supposed to come out easily? Yes, there we are. All right. Well, might as well get started. If people filter in, they'll filter in, that's fine. As I mentioned a bit, and you ready? Okay, great. This one? This one? Okay, very good. So I'll not stand in front of it. You know, if somebody says something objection, I'll just do that, right? I don't like that guy. All right, there we are. Actually, I like that guy, but he's saying something really silly, so I'll save him or her. Anyway, this is just kind of a Q&A session mostly. If there aren't questions, I would just talk about things that have happened with RCU, but let's give priority to the questions. And I'll start off with one thing. One of the things that's different this year. This year there have been 2 so far pull requests to lean us on RCU that have not come from me. And the thing there's another one, there'll be another one this upcoming merge window, and this will be the first time that somebody doing a pull request hands off to somebody else, not me, both not me, doing a pull request. So the point of this is to do something about our Linux kernel RCU's bus number. And these guys have put a lot of work in over a long period of time, helping solve that problem. And let's have a round of applause for them. It's a lot of effort, and one's management, people don't see RCU as a problem, so one's management isn't necessarily as happy to have people working on it as they might. So, thank you all for that. There are 2 others. So we've got, why don't you guys stand up and turn around? We got, I'll just go from that side, motion phone, whose name I just mangled. Joel Fernandez, Frederick Weisbecker. Not here today because they couldn't get to travel, would be Vlad Retsky and Niraj Upadhyay, whose name I probably mangled really badly. But yeah, so thank you guys for that, and thanks to Niraj and Vlad. And that's kind of the most important thing that we've been doing the last little bit. And in fact, we have Anna Maria Boehner, Thomas Gleitner, she's right there, Thomas Gleitner's daughter. I don't know if that was a good or bad introduction, but there you are. Found a bug. We aren't sure exactly where it is yet. It might be RCU, it might be work queues, it might be somebody abusing RCU, abusing work queues while RCU is trying to use them, or some combination there. But these guys have done most of the work on it because I've been being late and had to spend the time doing my presentations ready. So that's another big advantage of that change. Anyway, somebody got a question on RCU. And yes, the answer to your question, Anna Maria, is I don't know. Throw our catch box so we can throw our catch box. I couldn't.
I just want to say, yeah, thanks for the not having the possibility to give an answer, but I already talked to Frederick and he's also not yet able to give me an answer. Are you?
Well,
Seems like we are, I think, solving the problem. I don't know. I'm trying to. We have lots of networking issues. I have a VPN issue again.
Yeah, but
We'll
that's,
see.
that's the other problem I have. My VPN decided it didn't like this hotel, so I can't get my test feed right now. But yeah, what we've done is we've narrowed it down. These guys, go ahead.
Yeah, I think Anna Maria's timer patches could have caused us to arrive at the issue earlier because it is related to timers. But we were seeing this for a long time. It just took like 30, 40 runs to reproduce. But we've been seeing this issue for a while. So I think you accelerated us by reproducing it.
So well, what that means is actually advertisement by talking to 30 hunting Heisenbugs. We had a reproducer and she made something that reproduced a lot faster, which is a good thing. Well, it may not feel that way when you're actually running into it. Okay, any questions on RCU? Yeah, get this guy a catch block as we could, please.
Okay, so I'm probably one of the rare, corner case guys.
All right.
So what I developed is a debugging tool which basically isolates in CPU, disables preemption or anything, and then polls the GPO to be like a logic analyzer.
Oh, that would be it would have some interesting side effects with RC. You get RC CPU stall warnings.
What caused a bit of problem is a RCU CPU stall detector. So I use sysfs to just disable it.
That's legit.
Okay, well, but I talked to Stephen Rosted about it, and he said that I should not do that because I'm only using one core, so it's not needed to like disable the whole stall detector. And then he pointed me to some code in the tracing folder, and I got totally lost.
Okay, so yeah, that's are you using in this thing where you spin with preemption disabled? Are you actually using RC readers at all?
No.
I suspect. Okay, and but you have anyway. There's a couple of things you could invoke that tell RCU, hey, yeah, I'm good.
Yeah,
okay.
I found something. I came up to basically
RCU momentary quiescent state, I think is the name of it. I'd have to look it up. It's not one I look at much.
There was something like cont rescat task RCU QS or something. So that's what I found in the tracing code.
Yeah,
and that helped me a lot where to go further.
So what? It just didn't do anything for you?
Because it calls rescat. That's not what I'm basically busy looping. So I don't need any rescat.
Okay, yeah. So what you want is something called something.
Basically, ignore this CPU. It's
going momentary.
Yeah. Could one of you guys like further look up it's something like RCU momentary quiescent state or dynamic quest, something like that.
RCU.
The one that atomically adds to the context tracking counter.
CT.
Yeah.
CT state inc.
Well, that's the lower level one that.
CT kernel.
The one that increments the dynamic counter.
Yeah, he's there. We just need to get him up to the.
Yeah.
He knows that part. We need to get him up to the level where he's.
CT idle enter or CT NMI enter.
There's one that just those things incremented by a value,
Mm-hmm.
and we want the one that and then you say exit and it increments by the value again. We want the one that just increments by double that value.
You want the lowest level function.
We want the highest level function.
Highest level.
Yeah, there's one RCU momentary dynamic.
Momentary dynamic QS.
Yeah, something like that. Something like that. Yeah.
Okay, well, I'll just get my laptop out. Look for it.
Let me check.
I knew there's a reason I should put my backpack here instead of leaving it there.
Good question, by the way.
Yeah, so RCU momentary didn't take idle.
Thank you.
Yeah.
Okay. How do you spell that?
RCU momentary MOMENTARY Dyntic
CK, yes. Why don't you go over there?
Yeah.
And look over his shoulder. Anyway, what this function does while they're making sure they got the right name. So what happens is that RCU, well, back in the day, in the 90s, when I was first doing concurrent programming, the highest power consumption of a CPU was when it was idle, because it would be in a tight loop, and there'd be no memory reference, no nothing. The ALU would just be blazing away on this tight loop. And the original design of RCU back in Dynix PTX, before I was working at Linux, Dynix PTX was a Unix, proprietary Unix operating system that you've probably never heard of, done by a company called Sequent, that you've probably never heard of. We got one guy that seems to recognize the name, which is better than usual, so good. Anyway, so what we would do back then was we just didn't worry about it. You know, I mean, we would just check and see if the CPU was running an idle task and say fine, but we didn't concern ourselves about it disturbing the idle CPUs. Wasn't a big deal. Anyway, I learned the hard way that no longer was the case on about 15 years ago. And so we understood that they started having the Dyntic idle thing, where the idle CPUs would go into deep sleep states. And it was understood that you didn't want to disturb them. But there were cases where a CPU had callbacks waiting, and you clearly didn't want to just have those callbacks stick there and do nothing for like, a minute while the CPU was idle for a long time. So no big deal. You just make sure the scheduling clock tick stays on until RSU state machine gets rid of its callbacks, and then you let the thing go into deep idle, and life is good, right? This caused some anguish to some people doing some battery power embedded. And when I say anguish, I mean that flaming me on the Linux kernel mailing list was not sufficient to vent their ire. All right, they called me on the phone and yelled at me. I kid you not. I answered the phone and they're yelling at me about how I'm worth 30 to 40% of their battery lifetime, and they were not happy. So this meant that RC had to be more aggressive about going idle. It couldn't just kind of let the state machine drain out. And so we did a bunch of things. Two different things, one of which on purpose, and the other by accident, solved the problem. The one that we did by accident is the one that is still in the kernel today. The one that I was doing on purpose turned out to be less effective, so we got rid of it. So that shows you how life works sometimes. But one of the things that happened, the way it works is there's a counter. If the counter is odd, give or take lower order bits, then the CPU is busy. If the counter is even, then the CPU is idle. RCU notices the CPU hasn't said, hey, I've got a quiescent state, I'm done, you can let the grace period proceed. It looks at the counter and says, oh, the counter's even, so I'll just report a quiescent state on its behalf and life will be good. And one of the things that showed up was that there were cases where we needed to just sort of momentarily idle a CPU. We needed to say, look, you can let the grace period go. I'm not blocking the grace period, but I don't want to let go of the CPU, as is the case with this gentleman. So we have this RCU momentary Dyntic idle, I think was the name. And what it does is it just adds, instead of adding 1 to that counter, it adds 2. Because I only told you half the story on what RCU does when it samples it. When it samples it, it picks it up, and if it's odd, it doesn't just say, oh, the CPU is busy, so I can't do anything. It stores it. And next time it comes around and says, okay, it picks it up and says, oh, it's still odd, but wait a minute, the value's changed. So sometime between now and the last time I sampled it, it must have been even. Therefore, sometime in the recent past, the CPU was idle. Therefore, I can report a quiescent state on its behalf. And so what happens by calling that, it should just be an atomic increment and of a local variable. So the cache miss overhead should be minimal. It may still be a problem for you if you're doing logic analyzer like stuff. I don't know. I mean, try it and let us know, right? Yeah, you try it, and if it is, we'll figure something out, right? I'm not sure what we'll figure out at this point. We'll figure something out.
Well, if you say that using sysfif interface is legit, well, I can always fall back to that one.
That's true.
I mean, I could enable it after the sampling.
It's legitimate. It'll just hide other problems from you. But in any case, if you call that, what happens again? It's increments by 2, and so we've seen it before, and it's busy because it's doing its logic analytic stuff. We come back, it's still busy. Oh, but wait, the value has changed. Therefore, it was even for a little bit. Actually, it wasn't actually ever even because you incremented by 2. But was a little deception among friends within friendly code within RCU, right? So there we are. Very good question. Let us know how it goes.
Yeah.
Other questions? Yeah. Give this guy a mic, please. I'm not sure who has the mic. Okay, we got a couple.
Yeah, thanks, Paul. Follow up to that. Can you talk a little bit about the tick dependency of RCU in like a no hertz situation when the CPU is not idle?
Okay, you talking about no hertz full?
Yes.
Where you're running user space and there's no tick?
Yes, exactly.
Okay. So yeah, RCU is kind of keeping a separate set of books. When Frederick went and combined the RCU 19 counter with the context switch tracking, we had to make it a little bit more explicit. And I'd have to go look at the code to figure out exactly what it does right now. But in any case, RCU treats user space no hertz full execution as if it was idle. So as far as RCU is concerned, that CPU is idle. It's doing real work, but it can't possibly do RCU read site critical sections because it's user space. And I mean, I suppose you could write to dev mem but if you do that, you just voided your warranty. So we're fine, right? Now, one complication is the scheduling clock interrupt is disabled during that time, which is fine because we see the value saying, hey, this CPU is not busy from an RCU perspective. Okay. And so we just say, great, we'll report a quiz and say it on its behalf. But if it does a system call, we don't re-enable the tick. The reason we don't re-enable the tick is that they're very lightweight system calls. And if we re-enabled the tick, re-enabled it, and then disabled it on exit, we would multiply the overhead of the system call by a large factor. So we don't do that. Of course, that means if, and what I'm talking about is kind of a dumb thing to do if you're no hertz full. I mean, if you're no hertz full, you're supposed to, your reason you're doing this is you want to run idle without interruption. So why are you doing a system call that's going to take 5 minutes? But you could, right? I mean, that may be a silly thing to do, but the kernel isn't supposed to die when you do that. And so what happens is that if the grace period has gone on for long enough, and we see that there's a CPU that hasn't been responding, and it's a no hertz full CPU, we do a special thing that Peter Silstra gave us called resched CPU. And what it does is says, hey, CPU, you CPU over there, even though there's nothing for you to do aside from what you're doing, pretend there is. And so it takes a trip through the scheduler. And that trip through the scheduler tells RCU that the CPU is idle. Now that's not a good thing as far as user space execution is concerned. And there is a race where we decide, okay, no more Mr. Nice Guy. You've been in the kernel long enough. We're going to hit you. And then suddenly you're back in user space and we interrupt you. But on the other hand, if you don't want that, make sure that your user space code doesn't invoke long system calls, okay? The other thing is you could get interrupt that went for a long time. And the same thing applies there. Direct your interrupts to other CPUs. So if you're doing the isolation properly, this won't happen. But RCU has to allow for human error. I mean, we all make mistakes. And if you make a mistake, we should do something reasonable. And the reasonable thing we do is we whack you over the head, whack your CPU over the head, perhaps unnecessarily. Is that what you're asking, or am I missing the point?
Yeah, that reschedules it, but I'm missing the part where you need to re-enable ticks. Like take the dependency.
I'm sorry, I left out part. So what we do is there's a call that Frederick supplied some time ago where we say, okay, turn the tick on that CPU. Now that has no effect. We just set a flag and the CPU is off doing whatever, it's off in the kernel and it doesn't see it. The resched CPU forces it to go through the exception path. And in the exception path coming back, it samples that again and turns the tick on. So that's a more clear, complete description of the mechanism. That help?
Yep.
Okay. Yeah, that's a good question. So what are you doing with no hertz full?
VM scheduling, where you want to minimize the jitter for the VM, like avoid doing guest exit and going back to the host constantly.
Okay, so what you've got is you're doing a bunch of guest OSs, and you want the guest OSs not to be getting unnecessary scheduling clock interrupts from the hypervisor host.
Yeah, because
Okay.
basically all it's doing is incrementing accounting stats on the host, which we don't need every millisecond.
Yeah, no, that's I hadn't heard of that use case. That's cool. Thank you. Other questions? Yeah, we got one over here. Get Andrea, Mike, please. All right. Oh, good. Thorough
Thanks, Paul.
sketching.
So I have a question about lazy RCUs, since Joel's here.
Give Joel a mic.
Yeah, exactly.
Seriously,
I
give
catch
Joel a mic.
everyone here. So in Ubuntu, we decided to enable the lazy RCUs in the kernel that we call the low latency kernel, even if the name now is a little misleading, because it used to be a kernel that was targeting the multimedia, sound, the graphic people for like a soft real-time requirements. Now we don't need to target these people anymore, so we decided to change the scope of the low latency kernel to be more like a default kernel that goes in the desktop image. But that means that it's the default kernel that goes in the laptops, so that's why lazy RCU seemed to be a good idea. My question is, like, is there any kind of potential mitigation that I can do at runtime in case people are starting to scream and cry about potential regressions? Because I can save power, but as a downside, I may have potential performance regression.
Yeah, we currently don't. So the thing is, we just right now the approach is we just fix everything as we go, but we haven't had any problems reported on this, and we're on Chrome OS where I work. We're shipping this to millions of people as well. So we haven't, but there are people who want to turn it off at runtime. If I think if you want to do something like that, send a patch or something.
Okay,
but,
yeah, that's. I mean, there's no one that is working on a runtime adjustment to. I mean,
Yeah.
disable lazy RCU at runtime.
Yeah.
I can. Yeah.
Yeah, the Android guys have a boot parameter now, which they're using for turning it off at boot, but that's not upstream yet.
Are they going to send it upstream?
I asked them to, but I haven't seen it.
Well, who are these guys? Can I?
So they want to turn off the
Can I bug them? Who are there?
What's their name, Joel?
What's their?
Give him let him send an email.
Give me the
Let
name.
him send it upstream.
Oh, then okay. Yeah, talk to Kais Yusuf. I don't know if he's
Okay.
here.
He's here, right? QAIS is his first name.
Yeah, QAIS.
Yeah, I ran into him yesterday. He's here.
Okay.
Right,
Okay.
He might be in
Yeah.
the room. I don't know. I don't see him. But,
Thanks.
I was just talking to before.
But there
Yeah.
could, there's definitely things we need to be careful, like when you do that, and the transition shouldn't cause something in flight or for RCU to break or something like that. Those are the hard things.
yeah, it hasn't been heavily tested upstream, so it's it needs some serious testing. But
Yes, apparently
if you need it, we need to do
Oh
that.
yeah, we can do
and
lots
of course,
of
we
testing.
expect you to help with the testing.
Yeah, exactly. That's. I'm not afraid of testing.
Not yet. Oh, sorry.
So apparently the stable AI bots decided to backport it, and I freaked out actually. I was like, don't do that, because there were like 5 other fixes after that weren't picked up. So I was like, don't even try.
This is lazy itself.
Yeah, like the actual.
I
main
thought
thing.
it was supposed to be a bug fix, but
Yeah,
okay.
I have no idea why.
Quick question.
That's good.
What is lazy RCU?
So yeah, sure. So it's basically turns out that most use cases, not all use cases for RCU are to free memory. So it's basically like garbage collecting and stuff like that. But there's like a lot of use cases for RCU, obviously, where this is not a good idea. But what we identified is, since most of the use cases are to do some kind of reclamation or something like that, we can just make we can delay everything as much as possible and provide an API for those who need their callbacks to run sooner. So initially we had an API called call RCU lazy, which was opt-in, and then Thomas told us, no, like just make everyone lazy and then provide an alternate API, which we ended up calling call RCU hurry, right? So,
Hurry.
Yeah, so but it saves a ton of power because like every time the grace period has to be computed, like a lot of threads wake up and there's a lot of, it's a heavy operation. And we already, in RCU, we try to delay that and, amortize the RCU work so that we're serving more users, but it's still disturbing. It can be disturbing. So
Yeah, I guess you just need to delay it until you need the memory for something.
yeah. So we measured power and it was like 20% or something on some use case. So
Wow.
If the system was idle, if the system is busy, it doesn't generally save much because everything is active anyway. But if the system is idle, then doing this deferral was very, very good idea. So
cool.
So this is on Chrome OS and Android using it?
the Android guys are testing it now, but
Okay.
they merged it, but they're experimenting and all that. Chrome OS uses it everywhere.
Is the lazy RCU kicking on if it's idle, or even if you're using like the no errors hold, let's say, and there's just one task, right? Like one user space, is it also kicking the condition that it's like considered as idle, right?
Yes, it does. The only dependency it has is on the no callback RCU flavor. So we piggyback on that to implement it. So I think, Frederick, you're changing that to work.
I tried, but testing wasn't really. They told that it was not really a good thing. I mean,
Okay.
No performance improvement.
Yeah, I guess.
No power improvement, nothing actually.
Okay.
It was actually slightly worse.
Okay. I guess the no callback scheme itself is driven for power improvement.
It might also be that Frederick was doing things that were more server oriented, and so there was very little of the almost idle situation.
Yeah.
Maybe, I don't know.
I tried several things. A scenario which where the system was mostly idle, another scenario with lots of I/O, another one with lots of CPU down, and really nothing showed up.
So what this means is if you're in a situation where you can't use callback offloading, RCU, no CV CPUs, that kicking big option, and you think that being lazy would help you, you should chat with Frederick because he does have a prototype patch set to do it. And if somebody has a use case where it works, we should do it. If right now we're in a situation where it's great work and it proved a point. It was a good experiment, but we don't have a use case for it right now.
Yeah,
But maybe we will later. You never know.
Yeah. Another scenario where the stuff dynamically gets turned off is if there's some urgent RCU work that needs to be done, like somebody used call RC hurry, then we see that there's no point in keeping the lazy stuff in the back burner. So because we're anyway having to trigger grace period, so we pick up all of that work as well. It's a little bit like HR timer Slack, where if you have a non-Slack timer go off, then you'll pick up all the Slack work as well, because you might as well.
So what about synchronized RC?
Synchronized RC uses call RC hurry internally, but that's being changed right now to actually do its own thing and not depend on the async RCU stuff, because apparently that reduces wake ups and it's more efficient to do it that way. But right now it uses call RCU hurry internally.
And so another piece, if I remember correctly, see there were 5 or second delay. If you do a lazy callback, we say just call RC without the hurry, and it just sits there for, I think it's 5 seconds, or is it 10 seconds?
I think it's 10 seconds. Yeah.
Okay, at the end of 10 seconds, it's okay. Forget it. We're
Yeah,
gonna punch
yeah.
this through, which seems to be a good compromise
Yeah.
because 10 seconds is a good long sleep.
Yeah, and then we have a shrinker as well that if the system is under memory pressure, then we just flush all the lazy work and don't do this. So
Now, one question would be, should we make the Vlad's call RCU change from relying on callbacks to doing direct wake ups? Should we make that be default? The current answer is no for 2 reasons. One is it's new code and there's some people who benefited from it and they should take the risk. We shouldn't spread the risk across the rest of the installed base, which is large. The other thing is that as it stands now, it's written so that it works well for a smallish machine. I suspect there might be problems if you had a really big machine. which can be fixed easily. But, you know, we shouldn't put a load on the small machines who need it just because somebody else might need it, right? It's easier just to say it's non-default. If you want it, select it.
Yeah.
And if use cases appear, we'll update the code.
Plus, Android uses expedited RCU anyway for synchronized RCU.
So it wouldn't need it.
Yeah, so you probably wouldn't.
So,
Then expedited, it doesn't. Yeah.
What it is there's some kernel boot parameters. And one of them, which was actually introduced by the Android guys more than 10 years ago, which says, if I say synchronize RCU, pretend I said synchronize RCU expedited. Okay. And that gave them some boot time speedups, I think it was, and it may have also been application launch speedups. But in any case, at the time, this was before your time, before I knew you anyway, Saran. Who knows what it does now? I don't know. So that's why that's there. Now the real-time guys do not like expedited grace periods at all, because they send IPIs around and interrupts all the CPUs, including the ones that might be running real-time work, unless you're running no hertz full, in which case it'll not IPI that system, but there's a lot of real-time where no hertz full doesn't make sense, right? And for those workloads, there's another boot parameter that says, look, if I said synchronize RCU expedited, pretend I said synchronize RCU. In other words, if you set that boot parameter, you will never ever have expedited grace periods. So you can control that if your workload needs it. So yeah, excellent question, and thank you, Joel, for going through some of the details of lazy callbacks. More questions? Oh, we got one. All right.
Joel, maybe I overheard, but is there any use of RCU call RCU no callback in lazy RCU implementation? Maybe I heard wrong, but there was some mention about it.
Yes, I was saying the lazy implementation piggybacks on the no callbacks implementation. Yeah, because we depend on the internal mechanisms of that to actually implement. That takes care of a lot of the corner cases. Basically, it has this secondary list, which is used to carry RCU work to prevent lock contention, and we reuse that same list.
The odd thing about that is I added that list a long time ago for busy situations where people were throwing callbacks so hard that you can end up with lock contention problems where the guys trying to execute the callbacks can't get the lock, and so you get stuck. So I put this extra queue out there so that it had its own lock, and you could, you took things in batches from here, so you weren't hitting the main callback list lock very often. And so that was for busyness, and it turned out that could be leveraged for laziness as well. So,
Yeah, and that was great because the list that he had already added already took care of a lot of corner cases. Initially, I had my own per CPU list, and I realized quickly how difficult it was to get it to work. Like, for example, RCU barrier requires some logic there as well and stuff like that. So, but yeah, so I guess long story short, if you don't have the callback offloading or no callback mode, then you cannot use lazy RCU right now.
You have to enable it.
You have to enable it, and yeah.
Now, if it turns out that Frederick's been through a lot of that code as well, and he did a lazy patch set that worked without offloaded callbacks, but it turned out not to provide benefits in any way we can see, right? I mean, with the workload we had, if you find a situation where you want that and need that, send Frederick an email.
Yeah, my worry is that with no callbacks, basically your call RCU might end up costing in performance-wise, basically blocking your call RCU. You wouldn't expect
the delay is not visible to the caller, the guy that invokes call RCU. What happens is, so it's not like you say call RCU and it hangs out for a while and then returns.
Mm-hmm.
What happens is that it puts it on a list that's ignored for the most part for a while. And then, so what happens is you do call RCU and you come back just like you would have otherwise. So from the viewpoint of the caller, call RCU and call RCU take about the same amount of time.
Aren't they some additional logs that you need to do when you're using the no callback?
It's if you're already using, so this only works again if you're offloading callbacks. And it's the exact same set of locks and data structures as you're already using, because you're Android, right? You offload the callback. So there's no extra overhead visible there.
Okay.
But what happens instead? Go ahead.
What are the parameters to make it something that would show a performance decrease? You said it essentially is just putting it on the list, but what is there, like, I don't know, if you're doing a whole lot of allocations and freeing?
Well, so what happens? Yeah. So so let me just kind of give an overview of the flow. So we've got and I don't have look at that. Hey, we have the technology. This is for power savings, so I'll use a green marker. Thank you, sir. All right. So for an OCB CPU, maybe I won't use green because we can't see it. And sometimes power savings is counterproductive. You know, what are you going to do? Oh, okay, blue. Okay, we'll try this. Yeah, okay, good point. Thank you, Sim. So we have an OCB CPU. An OCB is it's kind of a weird name in retrospect.
Uploaded would be better, maybe.
Yeah, but that's a lot more letters.
Yeah.
Yeah, so not on CPU back. I don't know. Anyway, so what we have is an RCCB list, and I won't go into details on what this thing does. Joel and Frederick and a bunch of other people have made it do a bunch of cool stuff. All right, so that's good. But if you aren't offloading, the callbacks go directly into this guy. All right. And the problem with that is, to your point about really heavy workloads, this thing's lock can get hammered. And then the guys trying to DQ from it might not get any because they're on some other socket and, you know, too bad, right? So what we did is we put what we call a bypass. And what we're doing here, what we're bypassing is the lock intention. So by default, what happens, no matter what you're doing, if you have callbacks offloaded, it throws the callback into this list. And then it checks, and Frederick did a lot of work on this code to make it work better, which is cool. It checks a bunch of conditions. For example, this thing's full. Or if the stuff's been in the callback list too long. Okay. So we've been putting stuff on the callback list for, I think it's a few hundred milliseconds by default. And we say, okay, fine. We've had enough time here. We'll put stuff into here. At that point, the lock intentions of this guy are infrequent. Okay, because we're rate limited for here.
So you're batching basically.
Yeah, either by time or by number of callbacks. Go ahead.
And you said the bypass can fill up?
It can, in which case we throw it down there. But then the bypass,
how big is that?
Like several hundred callbacks. I can't remember the number. But
very quick, like it's a few GPs or something.
Yeah.
Default bypass.
We're using a lot of little objects, right?
No, so let me address a possible thing. One is you work for Oracle, you do database servers, okay? And one question is, should Oracle on its database servers do offloading? My knee-jerk answer is, why would you?
This isn't our problem, though.
Oh, okay. Whose problem is it?
It's Surin's.
Who's?
Surin.
Oh, okay.
Yeah, it's Android,
Yeah,
right?
yeah,
So
okay,
it's small devices doing offloading. They
Yeah.
have the no callback. So
Right.
there's a difference between what we see, or what I see in my testing, and what he sees, right?
Yeah, you'll see stuff going directly here.
Yeah.
There's no locks here in your case because it's per CPU.
Yeah.
So in your case, you disable it up, throw on the list, done. Now Seren takes some overhead because as soon as you offload stuff, you have to have locks on these guys. So his call RCU always has, going back to when we did offloading and they adopted it, had an extra lock overhead here, although the lock is a per CPU lock. And so most of the time, there's no cache miss overhead. The place with the cache miss overhead is there's some K threads down here, RCUO K threads. That was, anyway, there's a per offloaded CPU K thread, and it's going to be draining from these guys. Okay, occasionally. It takes everything all at once and then processes it. So it fairly infrequently hits those locks. You don't have to worry about that in your workload because in this case, this thing is not RCU, it's soft IRQ, RCU soft IRQ. So it's guaranteed to be on the same CPU, disable interrupts, yank the thing off the list, dereal interrupts, go, right? That's why I tried to make no CV default back in 2010, and a bunch of people really yelled at me because it slowed things down. There were some Java workflows that were really upset about this, like 30% performance degradation. Hence, we have the options. And so by default, you get your setup. You have to ask for offloading. And the reason people ask for offloading is it gives them serious real-time benefits.
No hertz needs it, right? I guess
No
that's
hertz
the-
full
you
enabled,
can't,
yes.
yeah.
If you're going to do no hertz full, then why are you? If you're trying to get rid of voltage on a CPU, why would you put up with invoking a whole pile of callbacks and software queue on that CPU? So yes, if you do a hertz full, you get it, which might affect you guys. I don't know.
Well, I mean, my use case is everyone at this point, right? So
Your use case is everyone.
yeah, right. Like it's the maple tree is what I'm looking at. And
Oh, okay, yeah.
So
If you're running MapleTree and it's on a device that enables no CP, you get no CP. Now, what happens? Yeah, so to your question, you've got this MapleTree and you're tearing down the processor, you're doing a whole batch of call RCUs. They're probably just call RCU rather than call RCU hurry because it's not like it's time critical to free the memory, as Joel mentioned earlier. So what's going to happen is they're going to go down here. They're going to each one of them is going to acquire the lock on this thing. But again, you have cache locality. You have lock and push it overhead, but it's just the CPU in the common case in lock. Occasionally, this guy will wake up and decide he needs to look at this. All right. But normally he just looks at this. Right. It's only if something bad is happening that he would mess with this.
right. So it's more about the startup that I'm concerned about, right? So tasks start up and they start putting VMAs in a tree. Android again, I think like duplicates the
Android has a lot of VMAs.
Yeah.
Tear the task down, you're going to be dumping a whole pile of MapleTree into this list.
Yeah, for sure. Yes,
And a bunch
but
of VMAs too.
but they're more worried about startup time, right?
That's what I've heard.
Also on that.
On that.
Right now, we do use core RCUs on part to like destroy the VMA.
So mmap part to destroy the VMAs.
Yeah, in any case, you should not use call RCU if that's why we have call RCU hurry. So if you need your callback to run quickly, you should not use call RCU to begin with.
Right, but I don't care. But they're using no callback. They want to offload, right? Because they have lower CPUs or whatever lower power that they can do these things later on.
So the other thing happens, even if you're doing call RCU and they're lazy, if this thing gets too many callbacks, then it'll say, okay, fine. We've got enough callbacks. The overhead of grace period is in the noise at this point. Just do the grace period.
Oh. Is there a way to know when that happens?
Is there a no when
When I've overflowed this bypass,
we could tell you, but why do you need to know? How's it going to help you?
it would tell me that it could potentially be what we're hitting, right? Like if we see a difference in performance.
Okay. Oh, okay. I'm finally putting this together now.
Yeah.
All right. So when you say no, you mean so one thing you could do is put a trace. There's some functions that we can get together with you. We only got a few minutes left, so we get together with you. You could put tracing on those. We could give you a callback into the kernel, but that seems since tracing works either with VPF or with ftrace, why not just use that? Right?
Yeah.
So if that's a problem, what can you do about it?
Well, so we can't even really see what's going on, right? Because when we're
Sometimes you don't need to see a problem to avoid it.
Yeah.
One thing would be is if you know you're tearing down a pile of MapleTree, you could take and group them together and make one callback.
That would be across multiple tasks. Yeah.
So you're getting rid of a whole pile of tasks all at the same time.
Well, I think that would be the only way you would do it because I group the whole tree together to do, and I do bulk freeze as well.
I'm back to my original solution. We can get together with you. Send us email if we don't get there or whatever. I would say right after the session, but I've got 2 more sessions today. All right, I'm sorry, but these guys are here, right? And they know that code. Frederick knows the NoCV callback bypass code really well. So maybe if you have time.
Enjoy too, yeah.
Yeah, so get together and they can tell you where to put the what function to trace, and it'll come right out at you.
Yeah, I think because our perf testing, right? Like it won't show this because it's that this isn't your task, right? Or
Yeah.
maybe it does with the no callback.
Well, this, if you, the work it does putting it on the bypass would be part of your task, but you're right. And draining it normally will be too, because it says, oh, it's full, I'll do it right now. And so that would happen under the call RCU.
Okay.
But you're right, there are code paths where this guy decides that life is hard and it needs to mess with one of the other queues. But these guys are their own K threads, and RCU owes something. Just go and look at the CPU consumed by those guys and look at what they're doing, right?
Yeah, I feel like I need to really figure out how to optimize this stuff specifically for an RCU setup.
Can I ask you, like, what is the callback doing exactly? Is it freeing memory or?
It's it's a K-man cache, so it's putting it back in the cache, but maybe it
I'm
frees.
sorry to interrupt. I think this is a good time for you guys to get together and talk about it. I apologize. I need to prepare for my next two things.
Yeah.
And we need to let assuming that the next BoF people are here.
There should be.
Yeah.
If they aren't here, we keep going, right?
We're in the grace period.
Ooh, we're in the grace period. Okay, this must be the next BoF people. Maybe not. Anyway, we should probably be polite and empty the room out so that in case they look in and say, oh, I should wait, they don't do that. Thank you all very much for your questions. I think it was a great session, and your guys' questions, and thanks to you three for giving some answers and some good feedback. Cheers. Well,
I should get the.
I'll try to.
The one after. It's in this room.
Yeah, it's in this room.
Yeah. Oh, let's stay here.
But actually, there's a break and then there's another talk. So it's only starting at the memory model starts at 12:15. That's 12:15.
Yeah, you guys.
Hi, this is Ajay. I'm audible. Okay.
So you're presenting remotely, right?
Yes.
Let me set up the slide and give you the presentation.
Thank you.
Vina is the right one, right?
Sorry.
This slides. Let me see. Okay. This is the
Yes, V9.
V9. Is it?
Yes,
slides
V9.
we want?
That's correct.
Let me see. Where's the button to make you the? Okay, make you the presenter. So you are in control now.
Okay, I got.
Yeah, we're ready to go.
Shall I start?
Yeah, whenever you're ready. The room is
Okay,
ready.
I'm ready. Okay, thank you. Hi all, thanks for joining. Myself Ajay works with VMware. Multiple teams keep on reporting us few problems with the perf tool, and one of them we will discuss today. That is the perf tool doesn't account for the task sleep. I hope you like the icon. So here we are trying to represent there are some tasks which is in the sleep state, but our perf tool is not mentioning anything about the sleep time during the profiling. Profiling of multi-threaded application are helpful to analyze performance and to do further optimization. Let's say we used perf tool to profile it and collect samples. The outcome should represent time taken at each step. One of the key parameters that would help to know at what interval and for how long various threads are in process sleep and resume. This would help identify potential improvement and bottleneck in the design and implementation. So perf tool also has something off CPU, which is similar to my talk. However, we try to implement in some different way. So first we will discuss on perf tool, not considering the task sleep time while calculating the CPU uses, followed by the perf architecture. I will cover a very brief architecture of the perf tool, which is required for my talk, and then we will move to the recommended solutions. So, as we know, perf is a performance monitoring and analysis tool for Linux. Perf record, perf report are very useful to identify which part of the code is consuming the CPU. However, the perf couldn't tell for how much time the process was in sleeping that is not consuming the CPU. It is because perf never collect the sample when task is sleeping. In this session, we will see why the perf is not collecting the samples when target task is in sleep state. And we will say CPU uses calculation is only based on the samples when the task was running. So as no sleep sample, so perf doesn't provide any info on how long the task was sleeping. So in this slide, you can see some graph. So the blue line is representing the task is running. Red line is representing the task is sleeping. So these samples which are in rectangle shape, basically number purple and the green boxes are representing we have collected the samples. And for red, these circles are representing the perf is not able to collect the samples. So let's assume our program was having only two functions, function one and function two. And as purple boxes are representing, we have collected the samples two times for function one as number 1 and 6. And for function two is representing, we have collected the samples 6 times, that is green box, that is sample number 2, 3, 4, 5, and 7, 8. So as of now, current implementation, it wouldn't consider this task sleep state. So it wouldn't capture any of the sample. And during the calculation, it will assume there are total 8 samples. And with some calculation, we will come to know function one uses is 25% and function two uses is around 75%. So in short, actually it wouldn't consider these samples. That's why it wouldn't show anything. And if you will see these readings 25 and 70%, so it seems like our program or our task was consuming 100% of the CPU. So this is what we want to change. So in the next slide is the expect. Okay, so our goal is to it should consider these sleeping time, and while calculating the CPU calculation, it should consider the CPU calculation as well. And this 8%, the 100% should have the weightage for the sleep samples as well. Here, the red lines are representing what we are expecting from the perf tool. So this thing, the left side, we have already seen the left in the previous slide. And in this slide, what we have taken, we have considered the number of the samples. So we have considered the 4 samples we missed because of the sleeping. So that here we have considered. So total sample this time will be 8 plus 4. So that is 12, including the skip sample. So we are not considering to take the sample, but we will count the sample, how many samples have been skipped because of the sleep, because of the task was in sleep. And with same calculation, but this time the sample count will be 12. And this will come to the function 1 has only 2 samples. So this percentage is actually comes to 16.6%. And function 2, as it is having 6 samples, so it will come to 50%. And we are having 4 samples, not samples, but 4 times for 4 samples, it was sleeping. So that will come to 33.3 percentage. Means from total CPU uses 33.3 percentage of the time the CPU, the task was actually in the sleep, maybe scheduled out or some other ways. So here we will see how the perf is getting the samples, means collecting the samples, because this is important to know for the solution part. So here we can see our target task is running. And once we will start our perf record, so init routine of the perf record will send some signal to the target task. And within the context of the target task, so perf software event init HR timer will be executed. So it's a kernel function, and it will set all the parameters for the HR timer. And it after that, the perf record will start the start timer. So once the start timer will send some signal, so in the context of the target task, perf software event start HR timer will be called. It will start the HR timer with the frequency or with the time provided to the initialized during the any time or provided to the HR timer. So once that tick is expired, the handler, that is the perf software HR timer, software event HR timer, will be called in the context of the target task. So it will call some of the function, and it will call the perf get reg users. So it will collect all the register states and the other information required, which is actually a sample for the perf, and this will be sent to the perf record task. And the perf record task will save this in the perf.data. So here we need to note whenever there is a handler called, so at that time the perf will capture all the reg register status and collect all the required information for the sample and send to the perf.data. Same if it's the timer is keep on running. So with every expiration of the tick, it will perform the same operation till the stop timer is not called from the perf record. So perf record would send some signal to the target task, and in the context of the target task, it will call the perf software event stop timer. So till it wouldn't call the stop timer, this HR handler will keep on calling, and it will keep on collecting the samples. So here the red box is representing it's keep on calling the handler and keep collecting the samples for the perf. Okay, so up to here we have seen the very happy flow where we are able to get the samples, but the problem is where we are not able to get the samples. So let's see that part. So why perf is not able to get the samples? So up to here we have already seen in the previous slide. So here is the main thing. So whenever there is a sleep gets called from the by the target, so at that time there is a some kind of hook is implemented with the perf implementation. So whenever there is a sleep called, so it sleep I mean in the context of target task, uh, after the sleep it will call the perf software event stop timer. So as it will call the stop timer, so there is no timer, so there is no handler will be called, and till the wake up is not gets called within the I mean by the target itself. So timer is not running, so there is no handler, and it wouldn't capture any of the sample, and also it wouldn't capture for how much duration it has not captured any of the signal. So at the wake up time, it will call the start HR timer. So that will restart the timer, and on the next timer expiration or next timer tick expiration, the handler will be called and it will capture the samples. So this is how we are not the perf is not able to collect the samples. So here representing there is no sample for the period when there is a sleep called till the wake up is not called. Okay, so in the solution part, we will be discussing only this red highlighted box. So solution part is lies within this red box only. For solution, we have tried multiple solutions, and some of the solution already present as a CPU offline that is based on the BPF. So here we will be discussing some solution which is within the kernel side. So in this solution, we tried first to capture the samples itself, and in another solution, that is solution 2, we will try to capture only the time for the time where we have not captured the samples, and we wanted to enhance the solution too, so that it will sample as well. So let's discuss first solution, that is the capture sleep samples. Okay, this part we have already seen in the previous slides. So whenever there is a sleep, so we will stop the HR timer, and after whenever there is a wake up, so only at that time we will start the HR timer. So because of this conditions, we are not able to capture the samples. So here what exactly we want to break this hooks from the perf, so that uh, timer will keep on running independently, means it wouldn't get be stopped by sleep, and sleep means it wouldn't get disturbed by sleep and wake up of the calls. So if we will cross this, so here we need to understand some part of the HR timer. So if task is running, then the handler will be called within the context of the target itself. But if target is in the sleep state, so handler will be scheduled for some soft IRQ. So in this case, if task is already in the sleeping state, so this handler perf software event HR timer, that will be called in the context of the soft IRQ, and it has to now capture the samples for some other task. Means this is running in some other context, but we want to capture the sample of the target task, so we may need to implement something like perf get reg targets. So this may be present or may not be present, we need to cross check, and this will get the sample for the target task. And similarly, I mean, as per the earlier solution, it will send this to the perf record, and which will store to the perf data. So this having some disadvantages, means we are keep on collecting the same samples for the sleep time, and um, data will, the size of the data will keep on increasing. Let's move to the solution 2. That is to so here what we want to do, we don't want to capture the sample, but we want to measure the time, means for how much time we have skipped the samples, and that time we will send to the perf record, and perf record will capture that in the perf.data, and the perf report will be using this information while calculating all the details for the CPU uses. Let's see. So here we have the target task. So whenever there is a sleep, so we sleep will call the stop timer. So along with the stop timer, what we have done is we will just capture the stop timer. So basically the local time will be captured to the stop time, And whenever there is a wake up, that time we will capture the start time. And by subtracting this, simply we will come to know how much time spent by the target task while it is in the sleep state. So as same sleep, so there is stop timer already called. So no timer is running. So no sample will be captured for this duration, but only the time we will come to know for how much time it is in the sleep state and have not captured any sample. So this information with some dummy sample, so we represented as a sleep time sample that will be sent to the perf record task, which will be saved to the perf.data. So now at the perf record side, perf report side, so record has already stored this data into the perf.data. So at perf report side, so it's already some functions which keep on getting one by one sample and processing that. So in the upper part, that is normal sample it will process the sample and it will add to the sample list. So here in the red line that we have tried in our POC, so that is it will get the sample and it will identify it's a sleep sample. So it is having the information for how much time the task was in sleep state. So it will process that sample and it will add to the sleep time. So let's see now how the calculation will happen. So in the calculation side, we have a sample time. So that is 1 second per divided by sample per second. So this sample per second we provide to our perf tool while starting it, and that will provide a sample time. So if we will use this sample time and the sample count, how many samples we got in the from this list, so that will provide us a samples time, means total samples collected time. And here we already have the sleep time. So total time will be sample times plus our sleep time. And to calculate the CPU uses, so here we need to use the sample time divided by the total time. So earlier we were already using the samples time. So now we need to use the total time. So this is where we will calculate the CPU uses, and sleep time we need to use the sleep time divided by the total time. So with this POC, we tried some of our some test program. So in this test program, it is a very simple program. So it will start a simple program that is, we can say, a dot out. So we need to provide one parameter, that is PWM. So according to the PWM provided to here, it will call the sleep time. So if we will provide, let's say 10 to this program, let's here we have mentioned a dot out, we started with 10. So that means for 90% of the time this program will be on the sleep state, and only for 10% of the time it will be running, means it will be capturing this time and other things, it will be on the CPU. So this program, if we will use this program, so in these snapshots, so this is the snapshot without our any POC. So if we will run this program maybe with 10 or maybe any value, so it will capture only the samples count will change. But here the percentage representing which function called, so that will remain same as 100%, because it will not capture any of the sleep time while the task was in the sleep. So it wouldn't capture any of the sample. Our if we will see in the perf record call, so we have given the frequency 10 and sleep is 4. So expectation is it should capture a 40 samples, but because it is only running for the 10%, so it only captured the 4 samples. Okay, so these are the snapshot. The left one is the snapshot with the existing perf tool, and the right side is a snapshot with our solution to approach. So after with this, after calculating the sleep time, so I mean same with same duty cycle, we have executed the same program. So here we were able to capture only the 4 samples, but with this we are able to capture the 4 samples, and that is actually we representing the 10%. And after that we have captured the sleep samples, so that is a 36. So basically these are a dummy samples only representing the time for the time the target was in the sleep state. And here if we will see very carefully, so this event count is also changed from 400 millions to 4000 millions. And main thing is here, so here earlier it was representing 100% CPU was used in these functions. So now it is only 10% is used for these functions. Okay, so solution, this is continue to the solution 2. So up to now, what we have already done as a POC, and what is the next step we are looking into our POC. That is, along with sleep time, we want to capture the sample. How to what extra we want to do. So along with the stop time, we want to capture a sample by using the same function, that is perf get reg users. So once we will get that sample, we will just save that sample till we will not call the wake up. So it may be this duration, sleep duration may be more than what is the frequency to get the samples, but we will only collect the one sample, because even if we will get the multiple samples, so all these samples will have a same data. So with this sample, once the wake up will be called, um, with this sample, the sleep time, adding the sleep time, so we will send to the perf record that will save into the perf.data. So here, as we have the samples, so it will represent the backtrace in the graph in the perf output, that for how much where actually the target has spent the time during the sleep. So if we will go back to the previous slide, so here even if we have captured the sleep time, we will representing 90% of the time has spent was gone while the task was in the sleep state. But in this backtraces, there is no information uh, about for which flow it spent the time in the sleep state. So that information we can add once we will get these samples. Okay, thank you so much. If you have any question or doubts.
Like this? Ah, right. Yeah, have you considered using trace events, sketch switch trace events in order to compute the sleep time delta?
Yes.
Oh, thank you.
So I was wondering whether this is really a problem if you're tracing the whole system, because you'll also get samples from the idle thread. So if the task goes to sleep, you will still get some percentage coming out of idle. But that could be a different use case. This sounds like it's more per task profiling. But what I've seen, like, profiling the whole system, is that the percentages won't be 100% if something's sleeping a lot. So yeah, that was the thought I had.
Actually, within, I mean, from internal teams, this problem is reported many times Like they are having multiple engineers, and they basically they want to see where exactly the application is spending the time. Means they want to trace the flow where the application is calling the sleeps. So that was not able to capture by using the perf tool. They were using some alternative tools. And if you will add this information, so they will be able to trace. And we recently I came to know, so this is already being done in some different way, that is called as this,
Yep.
off CPU. So they have
Yep.
introduced off CPU.
Yep. Yeah, so basically you can tell perf to trace the scat switch like Frederick was saying, and you get a perf sample when you hit the scat switch trace point, and that is recorded already in the perf. So you can already do this, but perhaps
Just needed a little bit of post processing.
yeah.
And yeah.
Yeah. But I think he wants it more like automatic or something.
Yes, with that off CPU, there is some dependencies with some
Yeah, he did it already.
kernel config.
Is it on?
And so as per the man page, it's written in the off CPU that it would require a frame pointer. So if the application is compiled with the frame pointer, only then we will be able to use the off CPU. So that's
Oh, okay, yeah.
Yes, please.
So there's an off CPU which triggers in on the HSK switch to aggregate the sleep time of each task, but it requires, as you said, code stack from user space. So basically works on frame pointers only. But at least if you don't have trace point, it at least can report some time on each task is sleeping. But it cannot know where it is exactly, but it at least says how much it's sleep. So, and basically the starting point is the per event is designed to be calculated when the task is run, right? Task is running. So if you want to measure the task is sleeping, as others said, you need to record different type of event, like a scat switch. And there's a command perf scat to do that. So you need to take a look at the perf scat command, and there are a bunch of analysis already done with that scat switch event.
So what you were presenting was using CPU clock, and we tend not to use CPU clock. We default to cycles as the event, but because you're running inside of a hypervisor and you haven't got the pass-through like perf events working, then you're using CPU clock. So this wouldn't apply for cycles, as a concern I have. And then in the perf report output, you're showing like for an event, you're saying you've got sleep and you've got the event, but we could have similar breakdowns for kind of like speculative and non-speculative instructions executed. So I think there's a bunch of things kind of like in your talk about like it'd be better to be able to like show in perf report when you have time on the CPU and off the CPU. It'd be nice if we can show events together and so on. In some of like the gecko profiling stuff that we added in 6.6, then it might be possible to add these things. But I'm struggling to see the motivation for a kernel change, especially as it would only apply for the software event.
Yes, it's in the software event, right?
I have a question which is maybe more general. How well can how can we measure the case where perf is, or using perf a case where a task is running but is waiting to be scheduled? Is that something that we can measure this way or a different way? And I mean, you can measure that time, but you cannot get you cannot know where it is waiting to be scheduled, which may be useful, I think.
Yeah, when the task is waiting on the run queue, but it doesn't get scheduled, it cannot span CPU cycles. So regular perf cannot sample those tasks. But if you really want to see that, then you need to trace scat switch and scat wake up trace points.
PerfSCAD already
Yes.
measures that.
Yeah.
Yeah.
Yeah, and there is even a BPF-based tool, which is the canonical tool, which is run queues lower. You have run queues lower. It measures the time it takes from being ready to run to running, and yeah, and you can get trace point backtrace for that as well to see. I mean, yeah, the trace points are there. You can use this already. The default output for the tooling is the interesting part I saw, is we have we have to consider batch like that so that we can show how long precisely how long the profiled application is waiting for I/O. It's off the CPU, and showing what are the reasons that is out of the CPU is something also interesting. But we have on perf record the perf record dash off CPU. So I think that, and it was not so visible because it was opting in 6 or 7. When you build perf, if you have what is needed, which is Clang, a BPF scale will be built, linked with perf, and then you're going to have several features that are based in this mode of operation. One of them is off CPU profiling. So this should become more visible, and people should start using it more. And then we can think about how to further use this information in the default output for perf report and perf stat. Even the perf stat something, you're going to see how many cycles it took, how many cache misses or whatever, and how long it was waiting to be running.
So if I'm understanding correctly, all of this can already be done with record. The only changes needed are in report with once you have all the.
Only in tooling, you don't need to change the kernel.
Yeah.
You don't need to change
Yeah.
Nowadays, lots of features will be implemented as BPF skeletons because the infrastructure is there. You can collect those things rather easily, and then you can run this on older kernels. You go to a machine with Red Hat Enterprise Linux 7. There is a backport there. Probably this off CPU profiling will work there. It's possible because there were backports. So we should, from now on, I would say, to try to use BPF more often in perf, to implement features in perf. Only when it's something which proves really interesting, and then we can think about this. Is in general, it's with BPF like a SCAD X or things like that. If you do it in BPF, it's so good you make it inside the kernel. But if it's something, a corner case or something like that, or experimentation, you start with BPF, and then you consider trying to do it in the kernel, not the other way around, because you will have a limited audience if you do it first as a kernel patch. You should do it first as a BPF thing. If it works, then you move to try to do this in the kernel. Convince the kernel maintainers that this is so important that it should be done, and we should wait for this kernel to be available everywhere.
Are we any plan for get out of frame pointer dependency for BPF? I mean to say, if we are using this off CPU, so dependencies with the frame pointer. So is there any plan to solve this dependency, the applications which are not built for the frame pointer?
So the stack sampling, grabbing the entire stack, is problematic in data centers because you can be capturing things like encryption keys and things like that. So the different stack trace mechanisms have got different, pluses and minuses. There's LBR, the shadow stack features which have been enabled is another backtrace mechanism. I believe the BPF people want to support all of these things, but it's not happened yet.
Okay, thank you.
And there will be a talk, I think, at 5 o'clock today by Stephen Rostet about implementing S-frame, which is yet another way of collecting those things that is being discussed and implemented. There are patch sets for perf, and probably the BPF stack, get stack will eventually, there's work on multiple ways of efficiently getting the backtrace without requiring user space to be frame pointer enabled.
So basically, BPF doesn't have its own like a stack, like a worker. Just use perf, or there's like whatever stack worker available in the kernel.
Yeah.
So BPF doesn't have its own. It doesn't make sense to have only just no difference for any it's just any code running
right
there.
So as soon as the S-frame is mature, probably BPF are going to get this, and then CPU profiling using BPF will get this as well.
Yeah.
So work is ongoing on that direction. It's a problem that everybody agrees, and that there are multiple people trying to improve the current situation.
So my concern about the BPF stuff is more the permissions, because all of these things work really nicely when you root, but if you're doing user profiling, then we have to get past the permissions hurdle.
Right, like BPF doesn't have the per task event thing like that, like manage that you attach to that task only to that one. So BPF doesn't have that concept yet.
Right.
Well, I shouldn't say yet, but I don't know whether they're going to have that ever. But that's the trade-off, and there are ways like try to explore what can you do safely without a root with BPF, and that's a much longer story.
Yeah.
So actually, I was playing with this. I was hoping that if I used the perf record with CPU clock, that should generate a sample even it is the task is sleeping, but it's actually not. Did I miss something? Some easy trick that could do something? Is just even this is sleeping, I will generate a. I was expecting the CPU clock because that's just the time based to generate a sample for me, but it's actually not.
Yeah, but
CPU run into the idle state, so the CPU, the per CPU clock, timer clock will be disabled if the kernel feature no hertz has been enabled. So this is why you cannot receive the timer event.
Okay, so it's a config.
Yeah,
to change the config, it should work as I expected.
I think that if we disable no hertz the config, then
High resolution timer, right?
yeah, the timer.
So in that case,
But now actually, I don't think this is a common case. Usually, that I think that no matter for both the server or for the mobile, the chip, no hertz, the configuration has been enabled by default. So if we just want to do profiling for this purpose, I don't think, for example, in the production, it's plausible.
Okay.
Maybe I'm missing something, but I don't see how this is related to no hertz at all. Like, yeah, no hertz should not be causing profiling problems.
Yeah, I don't think it's a no hertz problem. it's because it's a task event. It only activated when the task is scheduled, right? So it is scheduled out, we disable the event.
Yeah.
So that's the problem.
Unless
Yeah.
you use -A, I don't know.
Dash A is it's a full CPU mode, then that's fine. Yeah.
But
That's fine.
just now, he mentioned that it's not task clock. He mentioned the CPU clock.
But I think he may be confused with task clock and CPU clock. But in this case, it's a task event, and that it should be converted to task clock. Maybe there's a problem.
Okay, so I guess we got 30 minutes, and thanks for the presentation.
Thank you.
Thank you.
We'll get a break and come back in 30 minutes. Get a break and come back in 30 minutes.
Yeah, I was curious about when you switched to, I thought there was only like the timers or minimize that sample to CPU. It's not like fast, how do you like trigger this? Do you pass a PID or something or?
Not like, so people can program the CPU clock on the command line, but if people aren't doing that, they're just running perf with like no options. Then we go for cycles, but when you're running the hypervisor, then that's often not available.
I'm not sure it's a hypervisor problem.
Well, if you're running inside of a gas, then the
Yeah,
cycles
yeah,
isn't
yeah,
available.
yeah,
But then we fall back to find like the next thing that we think is better than cycles precise. And then CPU, one of those fallbacks is CPU clock, which I suspect is why we've got CPU clock here.
CPU clock is the timer?
Yeah, it's right.
Yeah.
Okay.
And it doesn't trigger an NMI, no, so yeah. The cycles triggers an NMI, so it's more precise.
Yeah.
Yeah.
And yeah.
So when the event is open, it arms an HR timer. When it fires timer, it checks the event is still active.
That's like
So does it stop the timer on the last task that sleeps? Like if you have multiple tasks on
the task is get out, it will disable.
Or what if you have multiple tasks that, like, do all of them have to sleep for the timer to stop?
I think each task has different perf event code.
Different.
Will fire different.
Okay, okay, all right.
Oh yeah, that makes sense, because if you scat out, like you don't own the CPU, you should not program the counter there. Yeah, that makes sense.
Yeah.
So what I expect doesn't make sense. Is even the CPU is idle if you are sleeping, like you are not supposed to have your perf event on the CPU.
But if you have a CPU that's overloaded, then you can have a case where the timer goes off, but you're not really running. That's possible, right? Because you're preempted and something else is running.
Yeah.
So it's kind of weird that.
Actually, the first ask is valid or not. I'm not sure. Like you are sleeping, are you supposed to count CPU for that?
Yeah, no.
Yeah, you're sleeping. The CPU can do something else.
Yes, you know, the same thing
Yeah.
over and over. Just they have big perf data file for no reason.
Yeah.
What he wants is precise time. You go to sleep, you record, and you get back to the CPU. And then you say that you are running the rest of the time, because you got just some samples, 4 samples. You're gonna say it's 10%. You say it's 10% because you run for 10 minutes, and then 9 minutes was precisely calculated as sleeping. So you were running the other time.
Yeah.
But that's why he got the 10%. The 90% he can calculate by calculating when you go to sleep and you get back.
Yeah.
We should have perfect pull reporting. If you have old CPU, we should have perfect pull report.
Well, I mean,
and both events together with what he had, and he's saying that's better.
When you look at I mean, if you are not getting samples, you must be sleeping. So kind of like, you know, right up to here, you went to sleep.
He wants to know precisely how much time is sleeping and what causes the sleeping. What causes the back trace?
Oh, yeah. Yeah,
So that's the information that's interesting for this for OCPU. Yes, how precisely.
Yeah.
You know more or less how much time you are sleeping. You're not getting samples, so you must be sleeping. But he wants to know precisely, and he wants to know the second thing that he gets from this is the back traces that says what causes the sleep. And if you can on the application, if you have a train pointer, you can go all the way to the application. If not, you can get all the way to the boundary of the kernel. You can say, oh, it's a few tags, so probably it's locking. Right? I don't know what's the lock because I can go further. Or it's writing something, whatever. You could even get at that point, what's the file that's causing the IO? Because if you would capture the syscall argument. But then for that, you're going to need to use BPF. So there are all sorts of tools that are interesting. What are the files? How long you are taking writing the files? Which files are causing the most IO or time for CPU time, things like that, or the sockets. This is the connection that's causing. Oh, it's DNS. Oh, DNS is causing most of the CPU time. It's trying to resolve some name. So you should take a look at this. Diagnosis, fixer is over.
You can also post-process stitch the stacks, right? So you stitch them and then you know there's a dependency and that's why you slept. Because the actual reason you're blocking might be somewhere far away.
Right,
So you might have to look at multiple stacks.
Yeah, it's just, I think at the end of the day, you get the samples, you get off CPU, how do you put them together and get your answer? I think that's tricky.
You should try it. You build 6 or 7 and then record that off CPU. You're going to do that.
But the issue with the way we have off CPU at the moment is it's a BPF program that runs whilst the clock is running, and then it creates a big sample at the end.
You should do like he was describing. You create when you wake up, and then you
then you create a sample.
Yeah,
So
and go inserting in order.
Yeah. We'd have to have a BPF output event. We'd have to IOPS onto the MMAP, and then we need to do something to process the BPF output.
Right. Yeah. You order everything and you go get it in order.
It's hold on.
You loud? Yes, you are. You are really, really loud. This is Cashbox number 2, and you are really, really loud. Check 1, check 2, check 3, check 4. No more? Ooh. Check 1, check. Oh, wow. Check. Checky, check, check, check. Check 1. There you go. Check 2. Check 3, check 4. Check 5. Check 6. Close to each other. Check, check, check. Double check. Triple check. You're louder.
is the Magnolia room. Oh man. Oh. I have to submit the slides again to the BBB, right?
You actually have slides on the urge summon discussion.
Sorry?
You actually have slides on the urge summon discussion.
I have a couple of slides, but I mean, discussing what people seem to like solving the issue without needing another BoF session. So, yeah. I'm gonna go ask. Do the slides need to be on the BBB thing, or can I just plug in an HDMI?
I've been doing it through that laptop there. You would have pulled up on that.
It's yeah, okay. Other people need to. Okay, sure. Yeah, I can do that. Let's see what comes. But I think it's just HDMI. Let me just.
If it's not too much trouble.
Yeah, sure, no problem.
Story behind that? I think is it ARMS or is it?
I don't know if you can put it there.
Last year when LPC was a Gareth Brooks concert on at the same, well, a series of Gareth Brooks concerts on at the same time.
Okay.
And all the hotel prices were like really inflated or whatever because of it. It was like 100,000 people going to see Gareth Brooks. So I guess they bought there. I remember someone saying the other day that they
They have access to the slides now.
Yeah. I do a lot of work. Yeah. Well, like my options are like I get a big pad, the Windows on it or Mac. I don't know anything about Mac, but I know I'd rather have a Mac than if you could give me all, I think that'd be great.
No, I don't know how to do that.
Corporate IT, right?
So I have my work machines.
No, this is something else.
But I have a.
Yeah. Like, give me a terminal and like, I gotta, like, basically I have like a Nix prefix that I use for like, have all the actual, you know.
So it should be.
Not BSD version of these other ones.
much. I don't remember who said that they had a scarf, but
Oh, okay.
Last week, yeah, I have not been put some of them. They like nailed me on that board. So I do some testing locally, but no, it's expensive. I have every D1 board that's ever been released, but I don't have a plan.
And then it takes a whole ATX.
Good.
Well, it's not a current report.
Okay, and I guess like I just put it in, like I just treated like the ATX case.
Yeah.
With the graph
I put it in my rack, so all my other boards like share, like our space.
Have like a big Bible power supply.
Actually, I don't know for that. Another.
You do like do you have like a way to control like on?
Yes. Yeah.
Bible
Like
power?
wine. There's already a blue small proteins. Yeah. I was correct that better. Shoes.
So I guess yes, I'm not good. Only fix up.
Because like I definitely could use something like, board farm infrastructure. I'm surprised at how like, maybe there is a standard thing for it, I just don't know about it. Power distribution, like UR distribution, that sort of.
Yeah, Eco has some moderator.
Okay. You do for yours, you just have like one board that has connects all the other boards, or you can like USB adapters.
I have them all. Yeah, this is events.
Okay.
Eco has some.
So it should be available on the website.
Like some of those, I've always thought it was weird that we use the USB UART adapters. We have all these steps where it's like 5 or 9 UART.
I don't know how to use presentation on the.
We do that. What do you mean? I can get my laptop.
Okay. Make this one for
You mean like HDMI, you know, the,
I'm using that word, so you should be able to just access it on the app. It's over.
Oh, yeah, because, okay, so.
Right, so let's go.
Take one, and then of course, use the onboard UART, so it's like, why am I going for USB? Then you need like isolation.
Sorry, could be more help. Yeah.
Current between the boards.
Yeah, I'm pretty sure.
No, I think. Go to your event, like my contribution. Yes.
Power back through power back through USB. It's like it was ran together.
Save it. Then we go back to the
Yeah. You should come to you guys.
You think so?
Yeah. Yes, we're facing.
And I still need to wait for the main.
We figured out that you can get something like check and the regulators can be checked for the framework. Don't no, I don't know.
It's actually really cool.
Oh, you're the tech support. Okay. That's good. I was surprised, like, while the presenter was remote, I didn't know until, like,
The time. Welcome to the powering up discoverable bus attached to devices BoF. Yesterday, Abel presented his talk about the powering sequence for devices that are attached to discoverable buses, but that are supplied by non-discoverable resources. And we had a lively discussion during the talk. We had an even livelier discussion in the hall. And it seems like we're getting close to having the final, a good solution that can be accepted upstream. So to summarize what
Is it good now? Okay, okay. It was on though, right? No? Maybe. Anyway, so the solution proposed was to introduce a PCI slot device driver that would be a platform device. It would be the child of the PCI host controller device. No? Can we though?
It would be hardware accurate if it would be.
Yes.
Speak the mic.
Yes.
If you put it under the PCI host controller node, it would be hardware accurate. It's attached to the PCI, so it needs to be child node of the
Are you
PCI.
talking about the DT binding now, or about the structure Linux?
No, DT device.
Yeah. And also, if we make it a child of the PCI host controller node, then we will only instantiate those devices when the host controller is probed, which makes sense, I guess, because creating those slots without the bucking controller.
My point was it's not a requirement. If Linux, I mean, the PCI helplog code doesn't care. You can do whatever you want there. It's if you want to do that, wonderful.
Yeah. Okay. So.
Yeah. This is we're only talking about PCI.
Yeah, I think.
But then
I think we should
can
focus on
replicate
PCI
the
for
same.
now.
You can replicate the same solution basically for every discoverable.
No, this is like really specific to PCI because PCI already has this hot plug capability where we have a way to do drivers for this purpose. We just need to hook in. So for other buses, we would have to restart the discussion.
But it could be similar to the
It could be completely different. Well, let's do this one.
Okay, sure.
And we already solved USB. USB is already solved too. So we got USB. This will be PCI. I guess MMIO already has that, right? Or what was MDIO has one.
Yeah. But
okay, but all right. So let's just take these one bus at a time.
And so another thing that came up later was the fact that we actually have two devices in that package. One is a PCI device and another is a serial device that share some parts of the power sequence, except that it turned out that they don't really. But since we were mentioning that, there has been 2 years ago, there has been a proposal of adding a power sequencing subsystem to the Linux kernel. It was related to that specific Bluetooth and Wi-Fi chip. It seems that we no longer need it, but I thought it's maybe it's worth discussing it. And
so basically, looking at the schematics this morning, we realized that there are actually two separate GPIOs, one for Bluetooth, one for Wi-Fi. Even if the regulators are shared, that can be handled by the regulator framework.
So you're proposing a new subsystem to order powering when we have already all the power management code, which is kind of a nightmare to deal with already. So I'm trying to understand what you said then.
This is a subsystem. You were not in that talk yesterday, right?
I wasn't, no.
No. So the thing that has been proposed multiple times and rejected multiple times is a generic power sequencing framework where you have a device tree description for a sequence of things that you need to power on any kind of device. And then we would be able to hook into that from a PCI hot plug driver or from any other driver.
Okay, I get that. But then suspend, resume, runtime suspend, runtime resume, all of that, how does that work with that? That's kind of my point. It's already a nightmare to deal with that. And when you suspend and resume, you have to redo the powering sequence for all that. And you have ordering based on the device, parent, child, etc. Okay.
Well, not really. So the thing is, the power sequencing framework would make it really simple to have a generic PCI hot plug driver that handles all kinds of devices, because you can describe the power sequencing for arbitrary wireless devices in a device node without having to have code specific to each kind of device behind that bus in the driver that handles the bus.
That's dreaming, seriously.
I don't think it's
We're never going to have generic power sequencing in DT. I'll just say that.
Well, that's unfortunate.
Until we add BPF to device tree.
Because we really need to separate the power management from functional drivers. For example, right now we have a nightmare in I2C where if you don't have a driver, you cannot access I2C nodes to, let's say, do firmware update and stuff like that. And you cannot do firmware update if you have the driver attached, because it can be disturbed by firmware update. So you have to have specific hooks in device driver. You cannot rely on user space solutions. If we had a separate step of powering up the device with the proper power sequencing and allowing access to it through I2C, through Hydro, whatever, and then we had a functional piece that binds on top of that, that would make a lot of operations much simpler and much more, I guess, less convoluted. And it also would be nice from the point of passing devices to VMs, where you have the host responsible for the power management and power sequencing. And then the VM is where your functional piece lives.
Yeah, but you have device driver stacks on top of device drivers, and the higher you go in the stack, you still have power management stuff there. And I mean, Greg can tell, like 90% of the patches I sent recently, they all get backports because that's all bug fixes for that mess. And suspend, resume, runtime suspend, return use of individual devices or entire system suspend, resume is just buggy as hell, because it's hard to get the PM framework being used correctly.
I mean, yes.
And so now on top of that, you want to add this, and so I'm scared. I mean, I'm already dealing with a lot of bug on that. So,
but we already have a CPI which essentially does a lot of that.
No, but again, that's to the level. You have the higher drivers that do power control.
We have mostly decided on doing it with the PCI hot plug driver, but then the question is how to represent the power sequencing in the device tree. And the two ideas that we have discussed so far is either we identify the power sequencing by a string that says what kind of sequencing we need based on the device that's behind it, or we try to describe it, which is the one that Rob said we will never do. So if we're at the point where we just know we need code in the hot plug driver that just knows about all possible sequencing, identifying them by a class of device.
But what I'm not hearing is a discussion how you make that agree with the device 3, like the struct device, parent-child ordering that is used by PM code for doing suspend, resume, and runtime suspend, runtime resume stuff.
Right.
Because then you have dependency between those struct devices to be able to do suspend and resume.
Right. And one problem that I see is if we do it in the PCI hot plug driver, the device tree binding for PCI, as far as I understand this, has a node that is both the slot and the device behind it. So it would have to go into that node. It does solve the problem that you mentioned, where we need the references to all the regulator and clock and so on resources, both for the power sequencing and at runtime. That part becomes easy. But it also does conflate the thing where we have two drivers using the same device node to look at those resources. But the hot plug driver and we have the device driver doing the same, touching the same regulators both at probe time and at runtime.
So Lauren had a question. Lauren?
Yes, can you hear me?
Yes.
Great. It sounds to me that at the end of the day, what we're looking at is power sequencing requirements, regulators, GPIOs, and all that are very specific to each particular device. And traditionally, in a non-hot pluggable platform with non-hot pluggable devices, that is definitely what the driver for that particular device will handle, because the logic that's needed to encode that power sequence is put there. If we cannot move that logic to the device tree, trying to look at the problem in different ways, but it seems to me that if we need to power up the device before we do the enumeration on the bus, which is a hard requirement here, we need to have that logic encoded somewhere. And moving it out of the driver for the particular device, if it's a logic that would be specific to a type of bus, I would understand that. But if it's specific to each particular device, I don't really see a very good way to do that. So are we looking at a situation where we would need a device driver to be able to supply some kind of logic for power requirements before it actually probes? So having a kind of, I don't want to call that pre-probe time, where before enumerating a device on the bus, we would have the driver core trying to figure out if there's a driver that can handle that power-up sequencing. That could possibly be a different driver, but ideally would be the same driver as the one that handles the device with the regular probe after that. Is that something that has been considered, or is completely stupid, possibly?
But isn't it exactly the slot driver that was proposed by Greg yesterday, which would handle the power sequencing for the device that is connected to that slot, so that the power sequencing is done by the slot driver, and then the device comes up when it's properly powered.
You know exactly what driver it is.
I think there is already a lot of that with the classic PM power management code, where it's going to do the, so it's what suspend, resume, shut down we're talking about. I don't think there is like a hook for powering up, but depending on the device class, which could be nothing, or just regular device or a bus device or etc. There's like 4 cases. You can attach your PM operations to that, so it can be a bus operation, a device operation, and there's plenty of cases. I think there's a lot covered already there. It's just a mess to understand and then use. So more documentation for sure would help, but there's a lot there already. So it sounds like you're trying to reinvent something that is already there, and that just needs to be extended a
You
little
can
bit.
figure out the exact driver that's needed, because you'll have a compatible string for your device node that contains the device ID, the PCI device ID.
From that, you can match it to the driver. I mean, that's
But
how PCI
the
matching
drivers
works.
define their own
Normally, you
PM
read the
operation
register.
already, so.
Yes, but those PM operations are provided at probe time, right? I mean, well, not
Yeah.
necessarily provided at probe time. You have them
So
in the driver structure, but I don't think drivers, that could possibly be changed, but drivers today do not expect those PM operations to be called before probe, do they?
Yeah. So,
No. I've suggested in the past to have exactly what you said, a pre-probe hook to call. Another way it could be solved is PCI quirks, which I'm sure no one will like.
Yeah, I've pushed for the
It was tried. It was tried and was
Can
rejected.
anybody hear me
actually.
talking at the minute, or am I?
Yes.
Okay. It's all right. I wasn't clear if I was not intruding due to muting, but anyway, yes, I've pushed for the pre-probe thing before. The other solution, which we have deployed at the minute for SoundWire, is that the probe function gets called, like Srini's just mentioning that on the chat as well. The probe function gets called as soon as the device is known to the bus, and then there's a further callback when the hot plug event actually happens when the device appears. For SoundWire, that's used quite extensively because the devices are actually powered off as part of runtime PM, so they are constantly unplugging and replugging